Second mic. 1, 2, 3, 8. Oh, well, probably, yeah, same. Okay, this is mic 1. This is mic 2. Can we bump it up? Mic 2. Mic 2. Mic 1. Mic 2. Yeah, that's good.
Yeah, cool.
technical people would take to get a screen to work? At least 3. Yeah. So it's a 9:15 start? Yeah. You want you can... Yeah.
Check. Sound good? Oh. We'll just cuddle up. We'll be good.
Yeah. Oh, if only I had them. Yeah.
Yeah, we're good. Well,
Okay.
keep me from being hyperkinetic. I usually walk all over the place.
Yeah, me too. Can we just start?
I'll probably wait for a few more folks to join.
Oh yeah, then we'll just fall off
Yeah. Oh, that actually would probably keep me in line.
Yeah.
Yeah.
permanently.
So we can't move to. So this is it.
That's it.
All right.
See,
Well.
if it was a small stage, you wouldn't feel constrained, but because they told you, it's like, oh,
Yeah. I can walk backwards.
yeah.
We'll probably give it a couple more minutes for folks to. I think there's still a bunch of people in the other room.
Well, they're streaming, so.
And you saw where my intro is in line, kind of just like yours. So we'll just do a cold open, and then you'll do your thing. I'll do mine as soon as I start talking.
Yeah. Yeah.
Oh, I guess I should put my hat on too, huh? Me twinsies. There we go.
Anything. We're sponsoring, so.
You got your
Oh, it's still got a sticker on it.
sticker on
Thank
the
you.
Good doofus.
Thank you. It fits your life.
Thanks, bud. You have a smaller head than I do. How about that local sports team?
Mouse.
What's that?
Got the mouse. So we have to.
Oh, yeah.
Yeah.
Nice and big.
Are we
right?
ready?
Yeah, we're good.
Okay.
All right.
Well, we're on
Guess
live.
we can kick it off.
Go for it. Okay. Welcome to Fujay Day, JConf. Ooh. Thank you for coming and spending. Well, hopefully this. It was a bit cold this morning, wasn't it?
It was a little chilly.
bit cold, yeah. But hopefully we'll warm you up with some cool talks. So this is the first one. Superman or Iron Man? Can anyone be a 10x developer? Anybody heard of the expression 10x developer? Woo, yes. Anybody here a 10x developer? Okay, that's cool, because that's the wrong answer. Right, okay. So you've met these guys, right? You will have met people who just seem naturally to get more fix more PRs, you name it. They just seem to naturally be able to deliver more. Yeah, we've met these guys. And though we probably shouldn't call them superheroes, quite often they get that sort of, I don't know, moniker. Oh, it's these great guys, they do all this great stuff for us. They're amazing, right? So wouldn't it be good if you could be one of them? So we're going to explain just how you could be a 10x developer. And you'll be surprised, I hope, to see that the answer is not that you go and do it yourself, but actually you do it as a team. But we'll get there. Right. So who would like to write 10 times more lines of code? Really? Yeah, one or two. Okay. Who wants to fix 10 times more bugs? Yeah, who wants to work 800 hours a week?
Don't we already?
Are we ready? Yeah. But that's what we're trying to show you, how you can achieve the productivity without having to actually do these things. Because fixing 10 times bugs is not actually what you want to do. You want to have the normal amount of bugs or less bugs. That makes more sense, more productivity. Right. We don't want you to have these things. We don't want you to have a secret identity, be like any Superman who does things alone, because that's the wrong answer. And you've probably seen people who say things like this. I wrote the thing overnight as if it's a magic trick, as if this is the really good thing to do. So that's not right either, right? Right, so I've been around, I say a bit, more than a bit, several bytes, right? This is me. My name is Steve Poole. I work for Sonatype, hence the moniker. I care about Java, I care about security. I've been doing JVMs and Java and APIs and, been in Apache Foundation, the Clip Foundation, all these places, right? Great. So I have a big background in this space. And I have met hardly any of these guys. Hardly have I ever met a 10x developer. I've met a few, and not all of them were developers. Right? None of them were superheroes. They didn't do things on their own. They were just very good at helping us all be productive. Right? And they were all professionals. So when I talk about 10x developers, what I really mean is how do we help everybody become more professional, more productive? We're going to interchange, I think, 10x developers and professionals, but you get the sense. It isn't about being a superhero. It's about what can you do to be more of a professional. Right? And it does take time. You cannot become an expert, a professional, without investing time and effort. Right? And you have to pick the right role models. You do not want, over and over again, you do not want this apparent superhero behavior because that takes you down the wrong place. Right? This is the role model you want. How do you learn to be future me? How do you learn to deal with the mistakes that you're going to create? Right? They're the role models. Who helps you get there? Right. So a 10x developer, these professional developers, are much more like Duke on a hoverboard than some mighty hero tackling 10 times the bugs that everybody else is. Much more like Iron Man. Because an Iron Man, if you think about Iron Man in the movies, what's it about? It's about taking the skills you have, the knowledge, the experience, the brains, and applying them in new ways to achieve something that other people find that comes naturally. And as we said, there aren't that many of these superheroes. Right? So 10x developers look more like this. Right? They deliver high quality value, but only do what is necessary. And they understand that the code they write, thanks, Justin.
That's my fault.
The code, yes. The code they write, and I can't, this is like, one of the superpowers that you should gain is to understand the code you write is the means to the end. Right? It's the success of others that's important. Don't get head up. Don't put your ego into the code. It's not the right thing to do.
They were fishing, so I thought cod. It looked right.
Yeah, good save. Yeah. And the last thing there is understanding that it's all about a team sport, right? It is about helping everybody else be successful in your team, right? 10x developers don't say stupid things like this, right? They don't go, I thought I was using the tool correctly. No, they're much more thoughtful and considered and rational about their actions, right? You will never get professional developers saying this. And if you are a professional developer, or you consider yourself a professional developer, have a think about the times you've used a tool where you didn't know actually what it was supposed to do and you just Stack Overflowed it, right? Right. So actually, we want to show you that 10x engineers are craftspeople, people who care about the process and invest their skills in the right way. And the challenge is going to be, where is the best place to invest your skills? 10x developers are productive because they have clarity. They think about what they're trying to achieve. They just do one thing at a time. They do the right thing. Right? It's the right code, it's fix bugs, it's learn new skill, but it's focused on the objectives, right? Small wins, because that moves the needle forward. Every time you do something big, you run the risk of things not going the way that you expect. Right? And 10x developers succeed because they are able to take the risks that needs to happen because they're prepared. They've already got the things that they need, the test suites, the understanding of the tools. They've reduced the uncertainty, right? Because that's the way forward, right? Right, now this is a really hard skill to master. I've been doing Java development and C code development for 30 odd years. And I still get the manual out and read things and say, how does it work? Because we all do, we learn things, right? Right? But the most amazing thing is it turns out that actually this is more than just a skill. And what this man is going to explain to you is just how actually we can all be the 10x developers, because actually there's a science behind all of the things that I've just touched on. How you do these things, how you think about it, how you focus. So with that, I think I will hand over to Justin.
Thank you, Steve. Thanks, everybody. In case we haven't met before, I'm Justin Rioch. I'm the Field CTO Chief Evangelist at Gradle. My background is primarily in software development. Spent a long part of my career writing code, and then moved into enterprise architecture, systems integration with a big focus on open source. And now I talk mostly about developer productivity. I think the consciousness of the industry is really shifting towards this. In fact, I'm not sure if you saw the most recent 2022 Gartner CEO report that came out, but for the first time ever, CEOs have actually converged on developer experience as one of the most important things that they're thinking about. And I think that's great. I think it's a long time overdue. So we're going to talk about how developer experience kind of relates to productivity. The origin of this 10x myth, or whatever we want to call it, probably started with this study that happened in the late 70s and early 80s called the Coding War Games. So you had these two folks, researchers, Tom DeMarcos, Timothy Lister, and they devised a study that they called the Coding War Games. Basically, about 600 developers from over 92 companies took part in this study, and the purpose was to kind of discover what are the best and some of the worst traits of developers. The competition unit was a pair of programmers from the same organization, but they weren't peer programmers. They were actually competing against each other in the same organization. A program spec was fixed, hey, go write this thing, and the participants logged the time it took for them to complete that task. They used their own workspace and their own familiar tooling and languages. So there's no prescription, hey, you have to use this language or you have to use this framework to do it. Do whatever you're comfortable with in terms of your setting. If you want to learn more about that, we'll probably get these slides out. You'll see a link to it here. There's a big white paper on the study. This would make its way into a book called Peopleware. Really good book, still holds up. I like to, as you'll see me do a couple of times in this talk, draw on what I call the ancient business wisdom of the 70s and 80s. There's actually a lot of really good thought during that time about productivity and how to make work effective. So the best programmers outperform the worst by roughly a 10-to-1 ratio. All right, so again, that's probably where this 10x thing came from. And there were some interesting non-factors. For instance, the language, with the exception of assembly language, didn't actually matter in terms of productivity. So people were doing things in their own language. Number of years of experience. This one's a little hard to hear. But about 2-year developers with about 2 years of experience were performing at roughly the same productivity as those who had 10 or more years of experience, which is pretty interesting. I know, right? Shocking. Yeah. Number of defects. So did these people just write a bunch of crappy code with a bunch of bugs in it to just get it done? No. Actually, there were a number of participants who had completely defect-less code that they wrote for this, and they actually performed slightly better. And then finally, salary. Another difficult one for managers, but the top performers only differed in their salary by about 10%, from the bottom ones. So what did matter? Well, one of the big takeaways from the study is that programmers from the same organization performed at roughly the same level. The average difference was only about 21% between the paired programmers that they were bringing from the organization. And that 21% becomes statistically insignificant when you think about the fact that top was 10x more than bottom. So people working at the same company were performing at roughly the same level, either very well or not so well. They didn't work together on the task, but they came from the same organization, and the best organization actually performed 11 times better than the worst. So Harlan Mills, who was a pretty famous computer scientist working at the University of Florida, said that while this productivity differential among programmers is understandable, there's also a 10-to-1 difference in productivity among software organizations. So basically, the takeaway here is that the best performers are clustering in some organizations, while the worst performers are clustering in others. Those that perform almost as bad as this HDMI is performing. Some companies are doing a lot worse than others. And there's something about the environment and the corporate culture that's failing to attract and keep good people, or making it impossible for even good people to work effectively, okay? Now, the data that came out of this study was very interesting. When they started asking more kind of features of these organizations that were in the top quartile or the bottom quartile, they found out that most of the data, most of the reasoning for these folks performing at the higher level really came down to developer experience, right? So if you look at how much dedicated workspace do you have, those in the top performing quartile had 78 square feet to work in, whereas the bottom quartile only had 46. Is it acceptably quiet? Right? Way more people who were in the productive organizations said that it was. Is it private? Can you silence your phone? Even back in the 80s, they had phones. You had to hit a big button to silence it. It was a little bit different. Can you silence it? Yeah. Can you divert your calls? Do people often interrupt you needlessly? So even though the phrase hadn't been coined at this point, the data really said that increased productivity came down to developer experience. And this matters even more now, right? I don't know if any of you have seen the statistic. I think it's staggering. IDC predicted this back in 2020, October of 2020, that 65% of the global GDP would be digitally transformed by now in 2022. That prediction came through. It was accelerated by COVID a little bit, but take that in. 65% of the global GDP is digitally transformed. That is a lot of code. And a lot of organizations aren't even really aligned in the way that they think about productivity. So between Microsoft and the University of Vancouver, there was a joint work that developed this thing called SPACE Framework, right? And SPACE Framework is a nice normalization model for determining how people are thinking about productivity. It does a lot of different things, but it basically breaks down productivity into these 5 categories: satisfaction, performance, activity, communication and collaboration, and efficiency and flow. And the way that this framework can work is that you ask somebody to describe what they think about productivity, and then you literally categorize each sentence that they have in sort of a free-flowing manner of speech into any of these 5 categories. Was that statement about satisfaction? Was that statement about collaboration? Was that statement about efficiency and flow? And in a study back in a newer one now that was in April of 2022, developers and managers were asked a very similar question. They were asked to answer, when thinking about your work, how do you define productivity? And the managers were asked, when thinking about your team, how do you define productivity? So almost the same question, right? Well, overwhelmingly, the developers made statements that were more related to activity, all right? How many lines of code am I cranking out? How many story points am I dealing with, right? How many modules am I writing, right? It was all about activity. Whereas managers were concerned more with performance. Now, performance being defined by things like, did we meet our deadlines? Did we meet our release dates, right? So a lot of organizations aren't even aligned on their vocabulary around productivity, which can make it very difficult to move forward with things that are actually important, that bring us closer to being 10x organizations. So let's talk briefly about the physics of performance. Again, drawing on the ancient business wisdom of the 70s and 80s. I'm a big fan of Eli Goldratt, Theory of Constraints, and The Goal. Anybody familiar with The Goal? Read that book? All right. What about the Phoenix Project? Anybody checked out the Phoenix Project? Okay, more people, popular book. If you read the intro to the Phoenix Project, they are very clear that they stole their ideas from The Goal. It's pretty much the same idea. You've got a page-turning business fiction drama about a struggling company. They're trying to keep pace with their competitors. A change agent comes in. In the case of the Phoenix Project, they introduce DevOps, and they win and save the business, and it's great. The theory of constraints is central to Eli Goldratt's work, and it's a complicated theory. There's a lot to it. The thing is, Eli Goldratt was not a business person. He was a physicist. And he was one of the first people to make that connection between the laws of physics can actually be used to help make predictions about how a business is going to perform, right? And it gets us in this mode of thinking where instead of considering business cost, we have to think about business throughput, okay? The theory of constraints breaks any complex mechanism or machine down into 3 basic components. You have inventory, the parts that make this machine work. You have cost, the energy associated with putting those parts together to create throughput, whatever that machine is supposed to do. Now, in the case of a software organization or a software company, cost is organizational cost, right? Inventory is code, and throughput is money, right? So this theory tells us that what we really have to do if we want to positively impact our performance for this company, or for this organization, we have to adopt practices that simultaneously increase the throughput of that business while decreasing cost, right? This is one of the big things where, for instance, layoffs, right? Layoffs help to control cost, but they are actually deleterious to throughput. So believe it or not, layoffs don't fix a business, right? They're only temporarily controlling cost. If you don't have a strategy to also increase the rate at which you're getting, in our case, the code out to market, you're not going to really make a meaningful impact in that business. All right, so we have a practice that we call developer productivity engineering. And I'm going to talk about that a little bit and how it relates to building 10x organizations. And to think about DPE, you've really got to start here, right? These kids look pretty happy. Ecstatic even. And of course they do. They're learning how to code.
No, they just hacked Uber.
Oh, they just hacked Uber. You're right about that.
Yeah.
No, that guy was 17, I think. Close enough, those, you know. But no, they're happy. They just ran maybe system.out.println hello world, and they hit enter, and it popped up on the screen, and it's amazing, and yay, wow, look at this. And you know, coding, for people who really love it, I mean, I think we can all relate to what the creative flow feels like when we're really in our flow state and we're really doing great work.
Who loves writing good code?
Oh, I think we all do, right? Yeah.
Oh, come on.
And the brain has been mapped while developers are writing, actually. They've done these studies, and it's this amazing soup of right brain and left brain activity going on. So no wonder it's so ecstatic, right? On the one hand, we have, you know, creatively thinking about the problem that we're trying to solve, and then we make sort of a hypothesis with the build tool chain. We say, I think this code that I wrote is going to do this thing that's going to help me solve this problem, right? And then we wait for the tool chain to give us that feedback. So now I would ask, what if these kids were waiting 45 seconds, a minute, an hour, some of the most extreme cases we've seen, 20 hours, to get that feedback back from the tool chain? They're not going to look like this. They're going to look like this, and they're probably going to go find some other hobby or something else to do. So I love this quote about creative flow. It isn't about being the best, because once you tap into the creative flow, the best doesn't exist. It's about experiencing the magic. It's about being in that place where your heart is free. It's about grabbing hold of the intangible and making something beautiful, right? So what are we really talking about then in terms of maintaining creative flow for developers? If we can postulate that maintaining that sense of flow is going to lead to better productivity through a better developer experience, what are we really talking about? Well, you can imagine that this is a developer and they're dealing, like we all do, with feedback cycles, right? They're writing the code, they're click and run, and then they're waiting for the compiler to do its thing, to run its builds, to run its tests, and let them know if they've done the right thing. Sometimes things are fine. This could be a local remote or in a CI environment. Sometimes things are fine. Sometimes they just take too long, right? Sometimes the build or test cycle just takes too long. Sometimes it takes too long to fix, right? Something fails and we end up spending our time trying to diagnose that failure instead of coding. And then the worst one, the one that really keeps me up, are the problems, the toil, the inefficiencies that could have been avoided altogether if there was just a little bit more proactivity in watching what was happening with the build. So unfortunately, still, in 2022, despite 65% of the global GDP relying on software and these feedback cycles to be efficient, here's how a lot of our calendars still look. We're up, we're fresh, we're coding, we're good, and then we're waiting. We're waiting for a local build to complete. And then it fails. So then we spend the rest of the morning trying to debug that failure. We're playing 20 questions with the build system. We're on Slack. We're trying to figure out what went wrong. We go to lunch. We code. We're happy. We're in our creative flow state again when we come back from lunch. We're waiting for the local build to complete. And it completes this time. Yay, we fixed it. So then we're going to send it to CI and let it build. And then tests are flaky. And the tests that were succeeding in our local environment are failing in CI. And we're going to spend the rest of the day trying to diagnose that. I think we can do a little bit better. DevOps, 12-factor, Agile, all these practices have still not captured all the bottlenecks and friction and obstacles to throughput. And we're numb to it as an industry. A lot of this stuff that we deal with, we just see as an occupational hazard of the job. We interviewed a guy from Netflix who focuses on developer productivity. They have their own developer productivity team, a guy named Danny Thomas. I'll shoot you I think I have a QR code to a blog that we did with him. And he said something in this interview that we had, in this intake. He said, it is staggering the amount of toil and friction and frustration that engineers are willing to put up with, right? Because I think we've just sort of believed that long build times or flaky tests or avoidable failures are just occupational hazards of the job, and we can do better than this. We can wake up from this a little bit. A lot of these bottlenecks are hiding in plain sight in the developer experience itself, and they're out of scope for a lot of the commoditized solutions that are out there around DevOps and Agile. Not that those are wonderful practices. They increase throughput, they decrease cost, and so they're going to be successful, but they've still left some stuff behind right there in the developer experience. Troubleshooting failed builds could involve clunky tools and not great collaboration. A lot of devs are still waiting minutes or even hours for a build and test feedback. So a 10x organization should think about reducing build and test feedback cycle times and improving the consistency and reliability of their builds. So we need to get out of this mindset where we ask the question, okay, is the cycle fast enough? That's the wrong question to ask. The right question to ask is the cycle as fast as it can possibly be, given all acceleration and observation and analytic technologies? Right? We're going to get into some of that now, but that's the essence of developer productivity engineering. Fast feedback cycles are really important, right? I think we don't always consider the cascading impact that they can have to other parts of the organization. On the one hand, of course, there's less idle and wait time. I think we covered that a little bit. That means less context switching for developers, less having to change their focus from writing code to whatever, jumping on Slack and answering emails and stuff while we're waiting for cycles to complete. Well, in the last 10 years, a lot of science has come out, you may have seen this, that humans can't really multitask. Like, we convince ourselves that we can, but it's just an illusion. Our brains can't really do it. But in the last couple of years, we've discovered something even more critical. Not only can we not really multitask, but trying to force our brains to do that is actually bad for our executive functioning. And it's actually bad for our brains to try to force multitasking. So you end up with much more focused developers, which has a direct impact on productivity and quality. But also, when you're building more often, when your feedback cycles are faster, you're building your code more often, which means you're refining it more often, right? You're introducing earlier quality checks to the process, which means fewer expensive downstream incidents. You're dealing with smaller chain sets when you actually put your code changes in, which leads to fewer merge conflicts and more efficient troubleshooting overall, and a faster mean time to resolution. Are we going to come back? There we go. So I think probably a lot of people are probably familiar with this cartoon. This is the mindset that we need to get out of, right? I mean, I love Randall Munroe, I love XKCD, but this is not a good excuse anymore, right? You got sword fighting in the hallways. Well, we're working, our code's compiling. No. So it is time for developer productivity engineering. So what's different about DPE versus other ways of managing developer productivity? This practice focuses on taking an engineering approach to productivity, right? So rather than trying to lean on developers to crank out more code, instead it's saying, let's use technology to make build and test cycles faster, and let's use observation and analytics to try to proactively deal with problems that developers would normally have to deal with as part of their toil. Let's use technology to get rid of that. And it follows in the footsteps of a lot of these other practices that I mentioned before are able to increase your throughput while also decreasing your cost. So it's certainly following the same core set of principles that guided more of this ancient business wisdom, just-in-time manufacturing and business process re-engineering, change management, which would become agile and Lean Six Sigma type of practices. Ultimately, of course, DevOps. And now, we're going even further left and finding more and more bottlenecks that we're eliminating with the practice of developer productivity engineering, with DPE. It addresses 5 major pain points: waiting for build and test cycles to complete, inefficient debugging of problems, flaky tests, which Spotify kind of famously calls the infinite pit of sorrow for developers, and we'll get into that a little bit. No metrics or KPI observability, right? Very few of us are even tracking the right type of metrics that would define developer experience. And so as we all know, 1,000-year-old adage, if it doesn't get measured, it doesn't get improved. And then this all does have an impact on CI as well. If we're able to make local builds more efficient for developers and we can root that in the build tool chain, then CI systems are going to experience the same thing. They'll become less expensive, they'll become more reliable, we'll have more agents available to do our jobs. And this isn't just our speculation, right? Gradle on the enterprise side is really focusing on developer productivity and this practice of developer productivity engineering. We did our own study. We looked at some of the early adopters of this practice and asked them what were they experiencing before implementing these practices, and overwhelmingly, 90%, too much time spent waiting on build and test feedback either locally or during CI, insufficient observability of analytics on build and test performance and regressions, inability to easily troubleshoot, and managing the growth of build and test cycles as the code base grows. Because ironically, the more successful a software project becomes, the more lines of code, dependencies, and other developers working on that project, the worse the developer experience becomes. The feedback cycle times increase, the amount of bugs increase. So when we talk about the Iron Man principle of 10x, we really mean building a powered armor for ourselves using technology. We really mean using engineering to fix this. So that's a lot of theory, but in terms of the tools in practice, for faster build cycles, we recommend looking into build caching. Okay, Gradle and the open source build tool has had build caching built in since 2017. It's not the only tool chain that has build caching available to it. Maven has this now as well. GCC and Clang have the ability to do build caching. For faster test cycles, we recommend test distribution, which is a little bit different than like CI fan-out. We'll talk about that. Predictive test selection, which is pretty new. It's a machine learning-driven approach to test impact analysis that Facebook sort of pioneered in a white paper that they published in 2019, so relatively new. And we'll talk about that a bit as well. Efficient troubleshooting through build scans. Build scans are gathering lots of forensic information about what happened during the build and putting it into a single shareable interface. Now these are available in the Gradle build tool as well as Maven for free, part of the open source tooling. Recommend you look into them and start using them. Failure analytics, right? Just track failures across your development organization. Figure out how many developers are being impacted by those failures so that you can make data-driven decisions about which ones you should be dealing with proactively. And then reliable test through flaky test detection, right? So build caching. Introduced to Java by Gradle in 2017. Steve, is a build cache a dependency cache?
Oh, of course.
It is. It's the same thing. No. So actually, when Steve and I first started working together and thinking about a talk to put together, we both were like, you know, people get our stuff confused a lot. Like, you hear build cache and you think dependency cache. You think like Sonatype Nexus. But they're different things, right? They're very complementary. They're important to one another, right? But they're dealing with different problems. Dependency caches help you with the security of your supply chain and with governance and with managing bandwidth, right? Whereas a build cache is actually there to accelerate a single build. Right? It's there to accelerate either Gradle tasks in the case of Gradle, or Maven goals, or Bazel targets, right? And the idea is that we want to be able to pull outputs from the build from a cache if things haven't changed, rather than rerunning that part of the build. All right? So especially in a modular build, right? Most of our build steps are going to create some type of output, right? Compiled classes or test results or something like that. And they're going to have a distinct set of inputs, right? Source code, or the unit test, or the JDK major version, or compiler class path, all these different things. And if the situation is completely identical to a previous run during that build, why rerun that part of the build? We can just pull the output from cache. And if we do this elegantly by generating the way that Gradle works and the way that Maven works is by generating a hash of input from things like source code files and all the inputs to that build, we can do this elegantly to the point where we can distribute this cache, right? So that a Follow the Sun team, for instance, can populate a build cache overnight, and then your first build of the day isn't pull down the new code changes, wait an hour for a clean build, and then actually be able to start your work, right? You can benefit from that remote cache immediately. What about test distribution? So test distribution works by using some type of autoscaler. The agents that we use just run test agents in Kubernetes that are capable of executing JUnit tests and returning feedback back to back to the kind of the central source. It can happen locally, right? So you can schedule these tests to run across distributed agents in parallel from the local machine. And hopefully, you can take advantage of things like elastic autoscaling, like we have in Kubernetes, right? And so this practice is a little bit different from something like a CI fan-out, which is what a lot of folks do when they want to try to achieve this sort of parallelism in a test cycle now. They'll manually partition test sets into smaller sets that then turn around and get scheduled in CI to run in parallel. But there's a couple of problems with sort of all of these existing approaches. Build caching is great, but sometimes things do legitimately change, and then we need to rerun those tests kind of no matter what. You can achieve some single machine parallelism using various build systems, including Gradle, but even that's going to be limited by the resources of that one machine. Mac's going to be hovering. And then CI fan-out doesn't help during local development. We work with a number of productivity-focused organizations, including Atlassian. We were having a conversation with them a few months ago, and we just said, we were speculating, what are some characteristics of a very healthy tool chain? And we said, well, if you can do everything locally, right? I mean, if you've really got the build efficient, and if you've really got the ability to distribute tests, then you shouldn't have to wait on CI to get all of these optimizations. You should be able to do this locally. That led us to a kind of pet campaign that we call Build Local instead of Buy Local. You can find those Gradle t-shirts floating around somewhere. So test distribution allows us to do things locally, and it doesn't rely on CI, and it doesn't rely on manual partitioning, right? So better experience. Here we go. So here's a great example of this. Netflix has implemented both test distribution and build caching. And you can see, it was Danny Thomas, the guy that I mentioned earlier, contributed to this blog. They'll talk about how they reduced one of their back-end Java apps from a 62-minute test cycle time down to less than 5 minutes, just using build caching and test distribution. And can you imagine, what that has done in terms of the way that this team is now able to work on this application? So the blog will kind of take you through, how they achieved that and what the results were. And what about predictive test selection, new form of test impact analysis? Well, how does this one work? Well, you can see the white paper here that was published by Meta, Facebook. They were Facebook at the time. I'm having a hard time calling them Meta. So Facebook published this paper back in 2019, and it's effectively taking a machine learning model to look at a history of changes that have been made to the code base and try to predict what that's going to do to the test set. So instead of running 20,000 tests, most of which are probably just going to succeed, which is like, hey, great, pat on the back, but kind of a waste of time, instead it just says, all right, well, these 50 tests are the only ones that are actually likely to change their status, so only run those, at least pre-merge, right? When you're doing things incrementally. It's a little scary, oh, you're going to skip tests? Not post-merge, you want to run everything, obviously. But pre-merge, you can really get a lot of gains here by using a solution like this. And another cool thing about it is it doesn't require a deep learning model. The white paper describes a gradient-boosted forest, which can run on any old CPU, right? So it's not something that you have to have a crazy cloud GPU rig or whatever to make work. So these things can really be a force multiplier. Sorry that it keeps buzzing out, when used in combination. Build caching can help us avoid running unnecessary tests and steps of the build that have been run in the past. And then predictive can say, okay, if we still have to run stuff, maybe we only really have to run these. And then when we decide, okay, we really have to run this smaller set, let's run them in parallel in an elastically auto-scaling way. Are we? Yeah. Well, I think we're close to wrapping up. Yeah. 10x organizations also track build failures and flaky tests. So do you? I ask this question a lot to big audiences, and the answer is almost overwhelmingly no, right? I think I asked this question in JFocus to a crowd of 600 people, something like that. The only people that raised their hands were the Spotify customers who were already our customers. They were using DPE and they were tracking this stuff. So do this though, put common failures on a dashboard and collect impact data so that it's not just one loud, angry developer saying, oh, I've got the worst problem in the world, you need to deal with this immediately. You find out that, oh no, you're really the only one experiencing it, and it's probably your fault. Instead, we can say, okay, these failures were experienced by this many developers and they wasted this much time, so let's deal with those first. And the same with flaky tests. In fact, our Gradle Build Tool team and Gradle Enterprise team, they schedule flaky test days, where they open up the dashboard, they start at the top with the flakiest tests that they have in their build tool chain, and they just start proactively working with those and eliminating the flakiness, right? And then what does that do? It prevents altogether developers running into unnecessary failures. 10x organizations also track local build times. Do you? No. But it's the simplest metric for developer experience, right? Just saying how long are developers waiting for builds to complete and putting that up on a dashboard can have a tremendous impact in the way that you think about improving their experience. Because without focus, problems can sneak right back in, right? We accelerate a build once, it doesn't stay fast, right? As we change all kinds of things, like adding a new annotation processor or upgrading our endpoint security, sometimes that build goes from 5 minutes to 8 minutes, and in real life right now, what happens? Nothing. So that sucks, the build took longer this time. Oh well. But we can do something about this if we actually put the data forward. So yeah, most regressions go completely unnoticed, unreported, and not addressed. So to recap, we reviewed kind of the history of productivity thinking and explored the mindset of a 10x developer and organization. And we rooted that mindset in pains and solutions and demonstrated what we call next practices, developer productivity engineering, and introduced some new tooling and some new pains. So if you take a few things away from this, take that most 10x developers aren't born, they're manufactured. Developer productivity is deeply linked to developer experience, and if you do nothing about productivity, life will get worse, right? That's just basic entropy. You have to decrease cost and increase throughput, not one or the other. Fast feedback, efficient troubleshooting, and reliable cycles are key. So start with observation and take action into data. If you take one action from this, start putting this data up on a dashboard. Build a focused team for productivity, like these other organizations have. And check out our book on developer productivity engineering if you'd like. Totally free. You see Gradle logo on the front. That's it. It's a vendor agnostic practice of developer productivity engineering. I think we're just slightly over, so we'll go ahead and wrap it up. Yeah.
What's the way we can collect all the results and feed a dashboard?
So we built special agents that actually run in Docker.
Can you repeat the question?
Oh, I'm sorry. Yeah, the question is how do you get test feedback back from the distributed test agents? And the way that you do that is, in our case, we wrote custom agents that could run JUnit tests, and they report it back to the build system. So the build system actually launches the agent through an API, and then the agent reports its status back to the build tool itself. Yeah, good question. And I know we're over. I want to be.
I mean, we're around all day, so.
Yeah.
A week? No, well, I am. You're going home.
I was supposed to go to DevOps World, but it looks like it's been postponed because of the storm. So.
Yeah. So I think if you get the idea here, so if you measure something, you can keep track of it, and then you can start affecting it. But if you don't measure how your job works, how your team behaves, you can't improve it. But if you do measure it with using these sorts of tools and others, then you get insight. And if you start saying things like, we won't let this get worse, we'll make it get better, everybody benefits, the whole team benefits. And just by thinking a little bit differently, you really can make a big difference to your productivity. Yeah.
And it's all about data.
Yeah.
So,
cool.
Thanks.
Thank you.
Appreciate it. Enjoy the rest of the show. All right. That's
Sorry for the technical difficulties, but it appears as if it's working now. All we had to do was reboot it 3 times and it started working. I don't know, right? But we'll get started in just a minute. We're just making sure the live stream is up, and then we'll let Teresa get going. Okay? Thanks for your patience. Sorry for the technical difficulties, but it appears as if it's working now. All we had to do was reboot it 3 times and it started working. I don't know, right? But we'll get started in just a minute. We're just making sure the live stream is up, and then we'll let Teresa get going. Okay? Thanks for your patience.
Are we on now? Awesome. All right, thank you so much, everyone, for your patience while we get through the technical difficulties. It always has to happen at least once at a conference, right? Welcome to my talk, which is called Making Good Choices and Untangling the Yarn Ball of Open Source Java Dependencies. And thank you, Fujay, for letting me talk today and having me. My name's Teresa Mamarella. I am a developer advocate at Sonatype. I've been in the open source Java space for a while now and have contributed to several JDK and compiler projects like OpenJ9 and Cubic, which is a Java static image prototype. And in my current role, I talk to Java developers about being more secure across their software development life cycles. So Java's had a bit of a hard relationship with dependencies for a while now, including not being able to find classes all the time when necessary. The class path can be brittle sometimes, and class loading can be really tricky. But that's not what I here to talk about today. We're here to talk about dependencies more broadly, but this is just to illustrate that this can be a pretty challenging and frustrating problem to address these kinds of runtime issues. And it becomes even harder when considering the fact that the average application contains 128 open source dependencies. Our applications start to look a little bit like a tangled ball of yarn or a plate of spaghetti, and this isn't really that far from the truth. This is, in fact, a real dependency graph, which looks remarkably like this squiggly line here. And since I'm better at expressing logic than feelings, I've created this AI art for you to express the amount of dread you should feel when talking about these kinds of issues and these kinds of bugs that developers may need to face. You've likely all heard of the Log4Shell vulnerability by now, and 6 months after the fact, I like to think of it as this sort of dependency type of problem. Just to do a really quick overview, the Log4Shell vulnerability was publicized in December, and as a quick summary of it, Log4j is a logging tool that's used really often in Java projects, and it was found out that if you were able to figure out how to get user input as into logging variables, you could potentially use the JNDI technology to make a call to a remote server, which would then serialize a class back to you that could be malicious potentially. And the implications of this vulnerability were huge. A lot of Java developers had to work over Christmas. Anybody here had to give up some of your Christmas break for Log4Shell? A couple of you. What made this vulnerability so bad and why it keeps coming up time and time again is because it allowed bad actors to pretty much do whatever they want with a system if they're able to find their way into it. And the other thing that made it so bad is it's relatively easy for someone to exploit. So I work for Sonatype, and Sonatype actually manages Maven Central and created this dashboard to record what versions of Log4j developers were downloading. And this shows the downloads between the months of December, when it was publicized last year, and May. And as you can see, it got a little bit better, but not that much better. And by the spring, about a third of downloads of Log4j were still of these highly vulnerable versions. So what exactly went wrong here? Are Java developers living under a rock? I don't think that's the answer. This was a highly publicized vulnerability. Even my non-technical friends and family were asking about it, especially those who associate my job with the little pop-ups that come up on their aging Windows computers. They wanted to know even what Log4Shell was. Not only was it publicized in the media, but the Federal Trade Commission of the United States issued a warning that they would pursue legal action against companies who did not take reasonable action against protecting their consumer data. And what they were referring to in this one was, in particular, the Log4j security vulnerability. Well, what really happened here was transitive dependencies. And I'm going to talk about this term a lot, so just to make sure we're on the same page, when I talk about that, a direct dependency to a Java application is something that's declared in your POM file, something you're intending to use that you know without a doubt and pretty easily is there. A transitive dependency gets pulled in by those libraries that an application may be using. And because of the way build tools help us abstract this problem away, it can be difficult to identify that they're there or really even care about them, just because it's been made pretty easy for us not to. And this is exactly what happened with Log4j. Application developers may have fixed the version they're using in their application, but that package could have been pulled in by all kinds of other areas. And there may be still vulnerable applications that may not be aware that they're in fact using them. And it's also extremely difficult potentially to identify that they're there. So my company Sonotype did a study last year that showed that about 70% of the time, dependency upgrades that are made by developers are suboptimal choices. And this study was done with 100,000 Java applications across 4 million component migrations. So that means that across this study, 2.76 million were poor choices, potentially leading to something that could be one day Log4j. If we look at that in a bit of a bigger context, Maven Central has 70 million component downloads every single week. And if those are upgrades, that's the potential for 48 million bad decisions happening all the time across the software industry. And potentially billions every year of dependency upgrades that are something that could hurt you. The point I'm trying to make with all this is that developers need to start making better choices. And I shouldn't say developers particularly, but development teams in general. So what this study was based off of was some objectively bad choices that were being made, but also some subjectively bad choices where it's not always clear what the best answer is when upgrading, which is what makes it so challenging. So some of the objectively bad choices were, upgrading to alpha or beta releases, which vulnerabilities are often found in. And it can also, lead to using sometimes half-baked features. If you think about the JDK, there are a lot of preview features that come out that are subject to change. The next objectively bad choice is don't upgrade to a vulnerable version. But again, it's easier said than done, because that vulnerable version might not be in the package you're pulling in. It could be in a transitive dependency, like Log4j, for example. Next objectively bad choice, upgrade to a lower risk severity if your current version is vulnerable. And this is pretty easy if you just have a severity 10 CVE Log4j, I'm going to upload to the next one. But if you have, say, several medium vulnerabilities that are inflicting a package, that could become sort of challenging to figure out what exactly is the least bad solution here. And finally, the last objectively bad choice is, I should say the other way around, what you should do when a component is published twice in close succession, upgrade to the most recent one. There's probably a reason that it was published like that. But there's some subjectively bad choices too when it comes to dependency management. So for example, you might want to stay on a common migration path to reduce build breaks. Choose a version that the majority of people are using, because believe it or not, there is studies showing that there is some safety in staying with the herd. And if all else is tied, choose the newest version to stay fresh and eliminate technical debt. So the point is, it's not just enough to wait for the next Log4j to come around. This is our modern digital infrastructure filled with open source technology is starting to look a little bit like this, and it can be unsettlingly dangerous if we don't actually know what's in it. There was a study done in the Cortex Expanse report showing that when a new vulnerability gets publicized, scanning by threat actors starts to happen within 15 minutes, which is way too fast for really anyone to be dealing with. The average development team takes 12 hours versus this 15 minutes. And so it's not really enough to just be thinking about what do I do when this happens, but how do I prepare in advance for things like this to happen? So the steps to take for that are, first of all, be choosing new dependencies wisely. Knowing what's in your application in the first place, that's kind of a non-starter. Assessing existing dependencies and making sure you're actually okay with the amount of risk that's in an application and those transitive dependencies. Continuously upgrading components, continuously monitoring for security vulnerabilities, and having a remediation strategy. Well, the first one we've touched on a little bit already, but that is how to choose new dependencies wisely. So I'll start with some pretty reasonable guidelines. The reason a new library is probably being chosen is to solve an engineering problem. So does it solve the engineering requirements, such as the correct features, performance, scalability issues? Other considerations could be things like training cost and ease of use. Is it well documented? Is there a supportive community of open source engineers that will help you if you have trouble installing and using their software? And if that's not enough for the organization, is there paid support options or third-party companies that will support you if something goes amiss? Another thing to look for is project activity. Is it being actively maintained? And for those contributions, are they being reviewed with rigor, and are they quality code? Aside from these more sort of obvious guidelines, there's compliance and security to think about as well. But for choosing open source libraries, licensing is a hugely important one. Pulling in licensing that might be more restrictive than what you've committed to in your application, could result in legal implications. And security, again, is another one. So how quickly does the community react to a vulnerability when it comes out? Which version of the project is least vulnerable if I'm choosing which one to actually use in my application? And lastly, and I think one of the most important security questions is, does this hurt my current security posture? Am I taking on more risk by bringing this library into my life and my application? But in order to answer this question, of course, it's important to know what you're using in the first place. What, in fact, is in those transitive dependencies, in that black box? It really brings us back to Log4j, and that just the fact that 30% of Log4j downloads were still vulnerable in the spring shows that doing this manually really doesn't work and is not the answer. And so one type of technology that's been becoming prevalent more recently is software composition analysis tools. And many companies are building free tools around this area. GitHub, GitLab, Snyk, Sonatype has one as well. And the purpose of these is to be able to identify these third-party open source libraries that we may be using and provide recommendations around what to do with them. So that could be around security, including choosing the best version of that package, legal compliance, code quality, and general project health. Now, you've likely seen these types of tools before, but one of the things I wanted to draw attention to is how they work. And just downloading and relying on something like this is really not enough, because not every tool is created and scanning equally. It's quite nuanced. So one thing to look out for is that there are different types of scans. So believe it or not, some scanning is simply potentially looking at a POM file and saying, oh, this must be everything that's being used. But that's Usually not true. Other types of scanning look for those transitive dependencies more thoroughly by doing things like actually downloading the libraries and then seeing what comes along with it. This is an example of what one of these scans might look like, at least from the security point of view. This is what Sonatype does, but just wanted to point out that this transitive dependency information is something to look out for when choosing your own tool. Another thing you'll see quite a lot of, start seeing quite a lot of in these tools is something like this, export Cyclone DX. Well, what in fact does that mean? So this is a sort of new standard of tracking dependencies called an SBOM. And the reason that this has come into existence is just because scanning itself is so hard and can be very error prone. And so this concept of software bill of materials actually came from the manufacturing world. So if you think about it, if you're buying a car, you can reasonably trust that whoever built that car knows exactly the parts that were put into it when it was made, the versions, the types, so that if they find out one day that they didn't work, they can issue a recall and protect public safety. That's the same type of concept that's being applied here in the software world. It's important to know exactly what's in applications, and especially for third-party software, so that if I go to you and I say, hey, I want to buy your software, you can provide me this list, this bill of materials, so I can go through it and say, ooh, but you're using Log4j at a bad version. I cannot buy this from you. You need to fix that. It's just a way for me of knowing what type of risk I'm taking on. For exactly, as I said before, that those scanning tools can sometimes be flawed. And so SBOMs are helpful for providing clarity around application dependencies, for tracking known and emerging vulnerabilities. So when something comes up and I need to know, am I using this package, I can consult my SBOM. And for also helping make decisions on third-party dependencies and knowing exactly the risk that I'm taking on. So at least in the Sonatype world, we talk a lot about the software supply chain, and this is sort of the concept that the software bill of materials is built upon. I just wanted to touch on what this is quickly and what it means when I say software supply chain. That really is the process of building software in order to ship finished products. So I would compare the suppliers of a supply chain to third-party software like open source components, warehouses to component repositories like Artifactory or Nexus repository. The manufacturers are the software development teams, and the finished goods are the software applications. So back to software bill of materials. This actually came about through an executive order from the White House last year, where Joe Biden is trying to improve the nation's cybersecurity. And the regulation is that any vendor that provides software to a government organization will, by 2024, have to provide that bill of materials so the government can then assess the risk that they're taking on. Now, what does this have to do with all of you or with open source developers? Basically, 90% of components used in open source applications are in fact open source components, even if they're being supported by someone else or being packaged and redistributed. There is open source in most applications. So these projects will likely follow suit, and you're likely to see SBOMs pop up in more and more projects in the next few years. So what exactly does an SBOM look like? This is the the minimum number of elements that are defined by the executive order. So there's data fields to show things like the supplier, the version, when it was built. It's to support automation, so being able to create it automatically to be able to scale across software ecosystems. And also, the standards should define the operations of requests, generation, and use. So what is the relationship and how does it work when I ask for one, et cetera. And currently there are 2 types of SBOM standards. So I don't know if you remember back to the screenshot I showed of Sonotype lift scanning tool, but it said export Cyclone DX. So that is just one of the 2 most prevalent SBOM standards that we're seeing right now. Just wanted to put this up there to show that you will likely see these terms floating around. And it's not really a question at this point of which one is going to win out over the other. I think it's likely that both are going to be used and be interchangeable as well. So the next version, as far as I'm aware of XPDX, is planning to be something that can be transformed between these 2 relationships. All right, so we've got our scanning tool, we got our SBOM, we know exactly what's being used across the build system. Now, you have to assess was that actually what you meant to do? Is this okay? Things like, are there existing vulnerabilities that you maybe weren't aware of? What's their security posture like? And are they ready to take on the next Log4j? So again, the SCA tools, scanning tools, do a lot of this work, but I wanted to do a little bit of a deep dive into like how they're doing it and what they're looking at. So of course, the first thing you may or may not probably heard of is CVEs, which is Common Vulnerabilities and Exposures. This is a way of categorizing public vulnerabilities as they come out. And a vulnerability is a security flaw that can be exploited and is proven to have been possible. So these are pretty basic. They have an identifier and a description, but it doesn't tell you a whole lot other than that. So there's also a scoring system that tells how bad this may be. And that is called the Common Vulnerability Scoring System. That is a commonly used method. It measures the severity of each CVE and it bases them on ease of exploitation and impact. So Log4j, for example, was super easy to exploit and extremely impactful, and that one got a rating of 10. All of these can be found in the National Vulnerability Database, and this is where a lot of scanning tools, well, I should say likely all scanning tools are pulling from this in some capacity. But there's typically more data than this in a lot of those tools. And the reason for that is that there's a lot of money to be had in cybercrime. And so it's not always very motivating for a cybersecurity hacker to disclose their vulnerabilities. In fact, cybercrime is now officially more profitable than the drug trade, and it costs approximately $6 trillion in damage every year. And so a lot of these products, these scanning tools, actually have a team of hackers that are sort of working to fight against that and being a little bit more proactive than just using what's in those vulnerability databases. Another scoring system that's a little bit new, but you might also be seeing, is called the Exploit Prediction Scoring System. And this one's kind of interesting because they're actually using machine learning algorithms to look at patterns of prior exploits and to figure out how likely it might be that certain CVEs could be exploited. So again, Log4Shell got a 90% chance of exploitation. So aside from being able to track what's already out there, another thing to consider in terms of security of open source packages is, are they ready to take on the next Log4j? So one initiative that's come out recently is the OpenSSF scorecard, which is basically a GitHub badge and a set of scans that are run to check if packages are trustworthy and doing what they can to be prepared for a vulnerability. So this comes from the OpenSSF Best Practices Working Group, and their entire role is to help identify good practices, requirements, and tools that can help open source developers create and maintain more secure software, helping maintainers learn to write secure software, and providing tools to help developers adapt these good practices in their daily work, such as Scorecard. So the idea here is to help improve the security posture proactively of open source projects, but then also to help people who are consuming these projects to know that, hey, this project cares about their security stance. So this is just a brief example. These can be run in GitHub Actions or manually. This was a manual run I did to just sort of show the types of tests that are being run here. Some of them are more simple than others. It could be something as simple as, does my project have a license, in fact? And some of them can be more complicated, such as, do I have an SBOM, which is a little bit of a more difficult question to answer. All right, so we know how to choose dependencies wisely. We know how to create an SBOM and figure out what's in that black box of transitive dependencies, and how to assess whether or not they are vulnerable or risky. The next step is being able to continuously upgrade those dependencies. And this is important for a number of reasons. It can be for eliminating technical debt. Following upgrade patterns may help reduce risks of regressions and breakages. It could be retaining engineering talent. If you're using 10 and 20-year-old software, that might not be as appealing to newer developers as the latest and greatest, for example. And of course, security considerations, which keeps coming up as a theme in my talk, because as I mentioned previously, there is in fact safety in numbers when it comes to upgrading. And so Sonatype did another study about what the best way is to be upgrading, and should you be keeping up with the latest or staying behind? And the answer is actually somewhere in the middle. So starting in the bottom left there, this is a bit of a clustered approach to dependency management, which is having manual workflows and not keeping up with the edge of upgrades. This can bring up a lot of technical debt and increase security risks and make it so it's really difficult to pivot and upgrade when major vulnerabilities come around. The next extreme on the right there is living on the edge, and that is just upgrading as soon as the next dependencies come out without any sort of context or a nuance there. And while it is good to be staying close to the edge and upgrading frequently, it still can lead to security exposure and ultimately can reduce quality of life for developers, because this can be a lot of work. So the best one is, in fact, living close to the edge. So being smart about what you're upgrading, but staying relatively fresh as well. And this study actually showed that on average, the best version is 2.7 versions behind. Now that should not be a rule of thumb by any means, but just to give you an idea that the newest one is not always better. And then on top of having continuous upgrading, ongoing security scanning is important as well. So you've probably heard of DevOps. I know it was talked about quite a bit in the last talk as well. But the next movement and the buzzwords are shifting left and DevSecOps. And what this means is making security part of the development process and not creating more work or asking developers to become security experts, but just being empowered to make decisions when they come about quickly. The downsides of having this type of model where security is in sort of a separate loop is it can be really slow, and security can potentially be a bottleneck in a very streamlined build and deploy system. It can also be really expensive to remediate if you're not getting feedback from the very beginning. And so that is basically the idea behind DevSecOps. Help developers make some slightly better choices, not living on the edge and creating more work for themselves, but also not lagging behind in terms of upgrades. Now, I know this is a developer conference, and again, I'm not single-handedly asking each of you to go implement this in your organizations, because that is, likely not possible depending on what level you're at. And so a key question that I get asked quite a bit is, how do I get my leadership to buy into this? So short answer is, be the squeaky wheel, keep bringing up the issues here. And the Log4j example is a great one, and so are some of these studies that I mentioned. And aim for improvements, not to be perfect. These types of systems take quite a bit of time to be done well. And we're not aiming to have DevSecOps in profession, but something like an SBOM in an Excel sheet to start out with would possibly help in the future. And for the long answer, would be happy to chat about that later. All right, final step in this process is have a remediation strategy. And for this, the pieces kind of fall into place if you have the other pieces already done. So having an SBOM, for example, makes finding vulnerable packages really easily when necessary. Keeping close to the edge of upgradings makes patches, when they come about and need to be done quickly, more of a routine. And finally, choosing with deliberation those open source communities to support you will help you feel good about the fact that you can rely on them when necessary. All right, so key takeaways from this talk. Again, working smarter, not harder, by having automated tools to help with these decisions. It's not up to developers to do this completely, but there is a bit of a shift in mindset in being able to think about these things sooner in the development cycle. SBOMs are coming. It's probably a term you'll start to hear more and more, so just something to be aware of. And finally, that security education is becoming a critical skill for developers. In fact, I saw a study that was done by the US government recently that basically categorized naive developers or untrained developers as an insider threat. So if that's not motivating to have some security education and just be aware of best practices, I don't know what is. So later in this conference, just wanted to give a quick plug for further talks that are happening from my company. So we have The Secret Life of Maven Central, which is by Steve Poole, who gave the talk just before this. And this is a really interesting one because it gives a lot of behind the scenes of Maven Central, the service that we don't always spend a whole lot of time thinking about it, but has a really interesting story. And then I will also be doing one around Java coding best practices for security, in case you wanted to know more and not be that insider threat. And that's all I have. I believe there's a break right now, but this is the schedule for the rest of the day, in case any of you need to know. So thank you. Hi.
Can I ask a question?
Sure.
You can come out first.
Yeah.
I like how we are trying to define everything inside a BOM and are things as you expect them to be, but does it also cover the problem of dependency confusion? That the dependency that you expect actually is
Announced it was a short break. I know it got paused by the thing being out.
Most of these folks are.
I didn't know what the. They're going to go give the announcement of, hey, everybody come on in, and then that'll take it back down. Yeah, you got the mill about, so you got to have somebody be like, everybody, there's still a room. Yep. Yeah, you repeat the question that people ask, because otherwise the audience or the people online can't hear it. You say, oh, your question was this. Yeah. I know, you get all the people who come in and they're like, oh, yes, blah, blah, blah. Yeah, sure. What in the world is he talking about? Yep. 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 And we have all... there's also the hype behind the podium. I've done these things before. Oh, that's probably it then. All right, is this large enough distance away? I can move this one further. Got it. Oh, okay. Sure. That work?
Yeah, you'll know when it's not working. Thank you.
All right, there we go. I think the mic is fixed. There we go. So no buzz. I guess I had the other two mics too close together. Two different mics. One is wireless. Let me clip this back on. All right, we'll make that work. There we go. Good. All right. All right, I guess we can start after the break. Thanks everybody for coming back. I hope we're all having a fun day at FUJAY for JConf. The thing that I want to talk about now is security since Java 8. So what's been going on in the platform since Java 8 was released back in about 2014, and generally how have things been going? The reason that I tend to talk about this topic is that I spent a pretty significant time in the space of security, dealing specifically with the security of Java applications and managed runtimes. From a long time ago, when I was an old circus performer, I did a lot of software engineering, writing code, building applications, doing a lot of design, incidentally right here in Chicago. Then I decided I want to figure out how to secure applications. I knew how to break into them. I knew things that could go wrong. So that's the time where I switched to do software security consulting. There was a company called Fortify. We did static code analysis And then I figured out how to do that particularly well. So they said, do you want to come over and be the product manager of this? And my first response was, what is a product manager? I don't actually know what that is. Lo and behold, back in about 2013, for those of you who've been coding in Java a long time, you'll remember that the security of Java back at that time was not particularly great. So there was a large company whose logo is red that needed somebody to come in who knew how to wrangle the security of software, and I said, that sounds particularly interesting. So I went and I joined that and assisted a lot with the security of Java 8. Then flash forward to now, I've done a lot in cloud migrations. I've done application security again with a company called Contrast. Now I'm Senior Director of Product Management for Azul. We provide one of the JDKs. If you'd like to use either of them, they go particularly fast. And with Fuji, I've just been hanging around in the community, the Slack, the different groups for quite a while. And I was working with everybody to do a jug tour on security last year. I went around and I talked about what are different attacks that are going on in the ecosystem. How do you defend against these attacks? And it was really interesting because security is a nice thing that's constantly going on, and there's just a nonstop stream of attacks against things. So I didn't need to build out a large play of like, how does this particular breach work? What goes on there? There was just one about every time that I went to talk to somebody. When we first started in September of last year, there was a large exploit going around against Atlassian Confluence systems. I'm going to explain how that works in a little bit. Then in December, there was Log4Shell. Incidentally, the shirt that I'm wearing right now, where you see the coffee cup with the skull logo on it, on the back of the shirt is written, "Live, Laugh, Log4Shell," because some of us spent so much time dealing with Log4j exploits that we just couldn't get enough of it. Well, fast forward in time a little bit, back in April, there was another one that was released, Spring4Shell. It was a way that you could compromise Spring applications because they had a defense that protected you from going from class to class loader. But when they introduced modularity, you could go from class to module to class loader and thusly exploit the system. Same thing back in April, there was a critical patch in the core Java runtime in Psychic Signatures where a JRE just became a little too gullible. Now, some of you might say, hey, that last one up there is from April. Do you have any new security exploits? Literally earlier today, while I was sitting in that chair, I was on this side of the room over there, I was just going through, I don't even look for these. It turns out that a friend of mine has been sitting on an about 2-year-old server-side template injection flaw in a Java templating framework called Pebble. So what you can do in this framework is if you give it a bit of instructions and you are able to control the template that it uses, you can just get that thing to execute a bunch of arbitrary code. So you can completely take over their server again. So anyone out there who is using the Pebble templating engine, please be mindful and go take care of that because there is an unpatched 0-day exploit in that is not overly complicated to do. And I always like to structure my talks in a series of patterns, a series of styles that we can go through to break it into sections. The first thing that I want to talk about today is how Java applications are being attacked. I want to walk through a couple of the exploits that are going on, both against the JRE or the applications that you use in your libraries, and look at the actual attacks that are causing that application to get exploited. Then I want to talk a little bit about what's happening recently in Java with the JDK or some of the libraries or the different patterns that people can use, and talk about some things that are coming soon. And then I always like to leave with defensive steps that you can actually do. So how can you harden your Java applications to make them a little more resilient against being exploited? Now, there's a lot of naysaying in security where people can say, oh, this is dangerous. Oh, there's a risk over there. Oh, you got to worry about these things. But in general, I think overall, the Java community, both the JDK leaders as well as the library authors in the community, are doing a pretty good job of staying on top of what's the risk to our applications, how do we defend ourselves, how do we get a regular patch cadence. And I think a lot of the security risk that affects Java applications has moved significantly less from the idea of there are attacks against Java itself, which occurred a lot in about 2013, 2014, a lot of 0 days back then. And it's more about what's the business case that you're using Java for? What are the libraries that you're using? How is your application structured in a way that creates weaknesses at integration points? And the risk has moved less from Java is risky and more to the concept of software is risky and Java lets you work with that. Now, a couple of the exploits that are going on, the last one that was in September of last year, it was really easy to attack Atlassian Confluence because what they were doing, they had a feature in there called Object Graph Notation Language that's just a domain-specific language where what their application would do is it would take various levels of the code that it was supposed to execute in OGNL from remote code, and it would pass those directly to the executor. So all you had to do if you wanted to break into an Atlassian Confluence server was to give it a query string. You see that's a series of Unicode elements up there in the top. And if you read it carefully, what you get is you can see they pass in class, they forename, and then they go after Java runtime. Get runtime, exec, and then they pass a command in there. So what an attacker can do is, as someone who's remote, maybe they need to be authenticated, maybe they don't based on your Confluence settings, they could completely take over your Atlassian Confluence server by simply sending a URL string into it. That's generally regarded as not very good because anyone who can access your Confluence server, anyone who can read pages on it, can just tamper with their URL, those query strings, even get parameters, and just totally take over the server. There was a patch that was issued against that. The United States Air Force gave a very meanly worded statement at Atlassian that finally got that to be patched. But effectively, if you take remote input from people and you execute that as code, that is bad. That is the definition of a remote code execution exploit, and you should not do it. If you are running Atlassian and you haven't patched it in a while, you haven't patched your Confluence instance, it is a very good idea to do so because that was a remote code execution exploit. So in essence, the OGNL, that object graph notation language, it's a safe feature. There's nothing wrong with using OGNL in an application. The library is fine, but the problem occurs when you take remote data from people and you say that remote data is the code that I want to execute. Because what you're doing is you're giving remote users the ability to execute their own code on your server. Generally speaking, not a good activity. But let's move into Log4j. I know we heard a lot about it in the last presentation. There were a number of attacks against that. And you can look at a variety of the attacks that go on, of people who try to put parameters against a web application. They try to submit get parameters, post parameters. Well, my username is JNDI. My favorite one at the time was people who photoshopped a Log4j exploit over on top of a car's license plate. And the reason that I think this is entertaining is a lot of organizations try to defend themselves using techniques like web application firewalls, various bits of web scanning. And those are fine. I don't want to tell you to not use those. But for those of you who develop Java software here, think about the way that you'd create a license plate recognition system. You would log everything that you saw. So if you were going through parsing a corpus of images, those are not web accessible. There's no way to filter that on the output because it's literally an image. But when somebody photoshops an exploit over top of that that says, JNDI:LDAP, and then they give you a site to connect to, your license plate recognition system is going to log that. And as a result of logging that using Log4j, your JRE is going to say, I know what I'm going to do. I'm going to go download the class at that location, and then I'm going to run that class as part of my logging. So that gives them the ability to totally control your server, and there were a pretty significant number of people doing different attacks like that back in December of last year. And the unfortunate fact is that you can still do a lot of those attacks today. You can still issue those Log4j payload exploits against a large number of applications, and unfortunately, they actually still work. So if you haven't patched your Log4j, that's one of the ways to exploit it. I think it's funny because who wouldn't log their input from a car license plate recognition system and just totally take over somebody else's server? Well, what are some other attacks that are going on? How are people compromising different Java applications today? One of the major sources of flaws in the community for a while has been deserialization attacks, where you go, you give a JRE a class to deserialize, and then as part of deserializing that object and reading it back into its contents, the JREs will actually execute the code that's a part of that bundle. So what you get on systems that use deserialization is another ability to execute arbitrary code onto them. And the easiest way to do that against a variety of frameworks, there's a popular tool called why-so-serial that a number of people will use. What you do with why-so-serial is you can simply give it a command that you want to execute, you choose the framework that you know your target is running, and it will generate a payload that you submit to the application, and if the application deserializes that class, lo and behold, you get something like a remote shell on it. Well, Spring4 Shell, that was not a deserialization flaw. That was a remote code execution exploit. What happened in Spring4 Shell is they had a defense in there for several years designed to prevent people from exploiting the system. Very good. What it did was it prevented you from using a scripting language to go from an instance of a class to the class loader, because then you could get it to do things and you could get it to execute things. And if you use Java 9 or above, Java 9 has the concept of modules. So there was no behavior that stopped you from going from a class to a module. So essentially you just inserted an extra stop there on your path to exploitation, and you would say, thank you for giving me the class. I'm going to go and I'm going to get access to the module system here. And then once you had access to the module system, then you could hit the class loader. So years ago, they had placed a defense in there to defend against another exploit that stopped you from going from class to class loader. And once modules were introduced, all of a sudden there was a new path. But the thing was, nobody knew at the time that they had to add modules to that deny list and stop you from getting to those as well. So that was the exploit in Spring4 Shell that occurred back in April of this year. Well, in the same time frame, it's not just the Java libraries that people are able to attack. There was one that was in the JRE itself. So CVE 2022-21449, it's always hard to pronounce those numbers. Effectively, the JREs had a situation where if you were doing cryptographic validation with elements and someone presented them a certain type of certificate that had a certain number of the elements on it, those JREs would just become relatively gullible, and they would say, that's a really good number. I trust that. I'm going to believe anything you say because you presented me with that certificate there. So if you have an application that was relying heavily on JSON Web Tokens, JOTs, or other cryptographic validation, it's a really good idea to make sure that you've patched your JRE to one that defends against this. That April critical patch update from earlier this year provides a valid defense against this that you can use. So all you have to do is upgrade your JDK. Now, there's a lot of these attacks, but so I always like to look at what's the common element, what's that unifying path that I can go through to recognize a way that I can deal with all of these different security vulnerabilities. And there's essentially two variants of these. The first is mixing data and code. That was Log4j, that was Spring4 Shell, that was Atlassian, that's a lot of them. The problem that occurs here is when an organization mixes data and code and they say, I'm going to take that user input and I'm going to pass that user input into something that I'm going to execute and issue a control statement from. This is where you get a variety of other exploitation techniques, like SQL injection is another one. Essentially, anytime you mix data and code, you get a bad result because it gives someone else the ability to specify what your code is going to be and change your control statements. Now, another one here that we heard about in the past was vulnerable dependencies. I have my direct dependencies, I have my transitive dependencies. All of these older libraries that I'm going to use and incorporate, I've downloaded, I've built my system. If you're not keeping up to date with patching these vulnerable libraries, then chances are the vulnerabilities that are in those older libraries are going to nail your application. For example, today, if you're still using Log4j, it's okay that the Log4j group had a mistake in their product. It's okay that they made a mistake. It was a big one, but we all make mistakes. All you have to do is make sure that you're not using that vulnerable version of Log4j anymore. If you are still using it today, you're still vulnerable. So the main thing that you have to do is upgrade to make sure that you keep them out. Spring had a mistake. Again, they fixed it. It's okay for applications and library teams to make mistakes, but if you sit there using the older version of the library, and you're using the Log4j that's vulnerable, or you're sitting there using a version of Spring because you haven't updated it in about a year, it's probably a good time to update those libraries, especially when they contain a series of known CVEs. At the same case, Confluence, they had their remote execution exploit. What should you do? update your version of Confluence. The main role is just don't keep using that old vulnerable version and sit there and say, oh, I haven't been hacked yet, nobody's come after me. But why does this matter to developers? And here I edited to give a compliment to Teresa for the talk that she did in the past, or the previous one. Effectively, why should I care? Why should I pay attention? I'm a software engineer. Why do these things matter to me? Well, in the case of Equifax, that was the example back in about 2017. They lost a ton of data in about 2017. Given that we're in the United States, chances are good you were a part of this breach. Almost everyone was. That breach occurred from an unpatched version of Apache Struts. They had it just sitting in there. It was known vulnerable, and they said, we're supposed to patch that. It would be a good idea to patch that. And they didn't, and somebody managed to break in. I believe it was a deserialization exploit in Struts as well. And lo and behold, the end result of that, beyond being hacked, beyond having to deal with dealing with a breach and dealing with the fallout, they were issued a fine in the amount of about $575 million, which is quite a bit. And they actually had to pay it. It wasn't one of those slap on the wrist fines that sometimes go through. They actually had to pay that. Well, the other reason that this should matter to you is the Federal Trade Commission. Teresa, this is the thing that you were talking about. They actually have been active in software libraries in the past. They had a settlement with Oracle on Java security in about 2015. Things were written on that. They had a settlement with Equifax in 2017. They were the ones that issued that $575 million fine. And back last December, they literally issued a statement out there reminding people that they have the ability to fine you. So I love the fact that the FTC stepped out and said, hey guys, remember us? Hey, we know this Log4j thing is going on. We're the ones that issue the fines. Did you know we can fine for that? So they literally said the FTC intends to use its full legal authority to pursue companies that fail to take reasonable steps to protect consumer data from exposure as a result of Log4j or similar known vulnerabilities in the future. So basically what they're saying there is if you don't patch Log4j, they're not going to go after you. But if you patch Log4j, or if you don't patch Log4j and you lose consumer data, they are really going to dig into you. But, you know, I talked with people a lot of the times, and no matter how much security risk I tell people, no matter how much I say it, I have a lot of people who sit there and they say, oh, that's not going to happen to me. I've already got my priorities. My management has set what to do. I don't need to patch these security vulnerabilities. Don't worry about it. You can still be exploited. That's fine. Well, you know, I got to test these vulnerabilities. I got to test my patches. It's okay. You're working on it. Doesn't matter. It's been about 2 years. Okay, sure. Security becomes a priority, you know, you'll have to make time for it. There was a comment that somebody told me a while ago is security is not the priority until it's the only priority. If you want it to be the only priority, you are certainly welcome to do that. Don't let me stop you. Also, a lot of the guys who go out and attack these applications, they have automated crawlers just like search engines. Shodan is one of them. That has a whole bunch of mostly IoT stuff in the back end, but effectively you could just crawl around. You look for signatures that systems do. This is why if your version of Tomcat or JBoss or WebLogic or something tells its version, people could just search for that version, they find your server, and then they compare that server against exploits. It's really not that hard. All right, but what's been going on in the realm of Java security, and now that we've dealt with the way that things are attacked, how can we go, what's happening that actually gives us some capabilities to defend against this? Well, there's a couple things that have been going on that give us an opportunity of different things to do. Some of those are modularity that's had a bit of a security impact and made things a little bit better. There's a release cadence where there's regular patches to the JDK that you're able to patch and implement and get upgrades that fix security cases. Also, the security manager was deprecated. That's the thing that most of you forgot was even there. It was designed for applets back in the day, and that thing is now deprecated. Doesn't mean it's gone, it means it's deprecated, and a couple new and different defenses. Now, the reason I talk about modularity first is this deals with what the concept of an attack surface is, which is someone who wants to break into an application, they have to find a way to get code to execute. So that's called the attack surface because it's the location of the ways that they can deal with your application. If you're a web application, you have a web attack surface. If you're a back-end data processing like a license plate reader, your attack surface is your image processing engine. And what I like about modularity is it gives boxes that things can go in terms of what that attack surface is. And now that applets are gone, I have significantly lower of an attack surface. But if I need to deal with a vulnerability class like XML external entity injection or XML bombs, which can explode the memory by referencing themselves, that's all inside the java.xml module. If I want to deal with JSP injection, if I'm just dealing with remote code that gets uploaded to my server and I execute that as JSPs, unfortunately a thing that I've seen, java.compiler. Meanwhile, SQL injection is a class of weaknesses that you can use to attack database applications that don't sanitize their input. That occurs in the java.sql module. And one of the reasons why I find modularity to be an effective defense, it's not an effective defense in itself, but it gives you an opportunity to deal with the modules themselves, such as removing them and making sure that they're not even there. Now, the release cadence, the big benefit about this, where there's a new critical patch update about every 3 months and a new major version about every 6 months, is it gives you an opportunity to plan ahead. You know what's coming, so if you're talking with a project manager, if you're speaking with someone in your management chain, you can talk to them and say, hey, in about 6 months, I'm going to need some time to do some compatibility testing because I want to upgrade our JRE. That's perfectly fine. Because what you get there is the ability to have a security patch where you can roll out and update your CVEs, or update your defenses against the CVEs by applying a new version. And effectively the way that this looks, either dev can update it or ops can update it, is you have a series of green dots there where each green dot is a critical patch update that fixes a lot of vulnerabilities. And you just want to keep pace with those green dots doing the best you can. You don't have to update every quarter. It's perfectly fine if you need a little bit of extra time, but stay as close to current on the green dots as you can. But every once in a while, there's an end of public life that goes on where, you know, it's time to move from Java 8 to Java 11, or it's time to move from Java 11 to 17. Yeah, there's other ones in there, but this is what the majority of people are doing. And at that point, you have your choice of two options. You can either update your application to run on the next major version of Java, which isn't going to involve some compatibility testing to make sure that you run on it, make sure that you can support all the APIs, and that's that path there that moves you between the different Java versions. You can do that, which requires some development, or you can locate someone who still provides security updates to your older Java 8. Those are both perfectly fine activities. It's just a question of what you want to do. Essentially, if you say, my application runs on Java 8, so I'm going to stay on the very last end of public life release, that's generally not a good idea because any vulnerabilities that occur in that last end of public update for Java 8, you don't get the security patches, and it's a good idea to install the security patches because those are the things that defend against psychic signatures. Those are the things that defend against the various deserialization attacks. And elements like that. So you want to keep as far to the right on your security patches as you're able. Now, another thing that happened was the deprecation of the security manager in Java 17. Deprecation does not mean removal. If you use the security manager, you are still welcome to do it. You can do it if you want. If you're going to use it, if you say, hey, this is a really interesting thing, I forgot that security manager was there, it has the word security in it, security is important, therefore I should use it. It's really not a good time to start because it's going away. I wrote a couple articles about this in InfoQ. I thought it was particularly interesting to cover. It's just, you know, what's happening now that there's a security feature going away. How does a security feature going away actually improve the security of things? And as I was talking with people about the security manager being deprecated and what that meant and how to deal with it, I was making some jokes that analogize the security manager to Radio Shack. Because Radio Shack is this store that you remember it from a long time ago and you thought that was a really good store, I want to shop there. But the truth is you never actually went there. You only went there because you found like an old radio in your grandpa's closet or attic or something and you thought, I'm totally going to fix that. Once I get time, I'm gonna rebuild that thing. I'm going to use it. Boy, if I ever get time to work on this, I'm sure going to work at it. And that's what you go to that store for. The truth is nobody shopped there. I didn't go there. Nobody remembers the last time they went to a Radio Shack. But they basically sold a bunch of DIY solutions where you didn't actually want to use them. When you wanted a radio, you went out and bought a radio. You got one that actually worked. So the Security Manager, in the same way, was this really cool project that looked really good, that everybody thought they should use, and you thought, oh gosh, I should really use that. I don't use it, but I think I should. I don't shop at Radio Shack, but I like the idea. So it's a great store for someone else. And the reason that the Security Manager is not particularly effective is that it was built a really long time ago and defended against a different threat model that doesn't really matter today. So originally it was created for Netscape Navigator. When you had that applet plugin that sat there and you could get the dancing cartwheeling Duke who spun around and just did different things because JavaScript nobody really knew what it was back at the time. That's what the Security Manager was designed to defend against, was the concept of portable code that you didn't know if that code was safe to run on your machine. Well, the majority of applications now, they don't need to defend themselves against portable code. They need to defend themselves against the data that they process. So for me, it was particularly interesting. I got 2 articles that I wrote about the Security Manager. And it was interesting that in the several week span, I think it was like 6 weeks or a month or something, in between the time that I wrote those 2 articles, I met more people who wanted to talk about the Security Manager in that like 6-week time than I saw in about a decade of application security consulting with a focus on Java application. So nobody was really using this. And one of the reasons why nobody really used it is that securing an application, creating a policy, you need context for it. Like if I were to ask you now, if you're using a Tomcat, if you're using a JBoss, if I said, do you know what files that needs so you can create an allow list? I wouldn't know. I don't know what Tomcat's supposed to use. How am I supposed to get the answer to that? Deserialization is a risk. Do you know what classes your framework needs to deserialize? How am I supposed to know? Oh, is it safe to access the etc password file? Well, yeah, that answer is not a yes or no. Yes, it's okay to access the etc password file if you need it for the purpose of authentication, but no, it's not okay to access the etc password file if you're reading for files to serve to remote people over the internet. So the problem with a policy file was there was no real understanding and no clear roles in terms of whose job it was to actually create these, because it ended up in this no man's land of persona where neither the developer who built the application nor the operator who ran it knew what files it was supposed to ask. The person who built the application would say, well, I don't know where it's going to be deployed. You have to be relative to that system. And the operator would say, I know what's relative to my system, but I have no idea what you're supposed to access. So essentially, the Security Manager, if you went to use it on a back-end system, it relied on creating a policy file with answers that nobody had. Now, another one of my favorite things that's gone on is the creation of security events that get piped out to JDK Flight Recorder. Flight Recorder is one of my favorite tools. There was a Twitter feed of vote for your best JDK feature a couple years ago. And me and a friend were doing like a poetry slam in favor of it. I wrote a lot of Flight Recorder poetry. It was real fun. If anybody wants to go look that up and get a blast from the past in terms of what we did at the beginning of COVID. But one of the nice things that's here is that it gives you a lot of good information that you can look at and see, because you can't secure what you can't see. So that element of, oh, well, give me a listing of classes that I'm allowed to deserialize. How am I supposed to know what those are supposed to be? But in JDK Flight Recorder, you have the ability now to monitor deserialization events, which gives you the capability to actually monitor your JDK in a dev or production environment and see what those classes actually are. And the big benefit of this is it makes some of the other features possible. So I think in Java 9, there was something called serialization filters where you could create an allow list that said, I only allow the following classes to be deserialized. Now that was a really interesting feature, but the truth was when it came out, almost nobody could use it. Because if you said, oh, you can create an allow list of classes, what am I supposed to put there? Nobody actually knew what it was. So only once you created the listing and you got a recording of what classes you deserialized in an environment where you knew and actually tested your application, that was how you could create the allow list of saying these classes are okay to deserialize. So prior to Prior to the presence of deserialization events through JDK Flight Recorder, it was next to impossible to create that list. And if you need to use your serialization filter now, what I would do is test the application with a Java Flight Recorder in place, collect the listing of classes that I deserialize, and then I would base my allow list on that. And now I can actually use my serialization filter. But we don't want to just stick with different recommendations. Oh yeah, I went to this talk and all I heard was that different things are risky and that I can deal with them. I want to talk about some defensive steps that you can do right now if you go and are working on your application, or if you go later this week and you say, I want to defend my applications to make them a little more resilient. And the summary of steps that you can do right now is, number one, the easiest thing that you can do is maintain relatively in line with a patch cadence. Periodically update your JDK, periodically update your libraries to get the latest version of them. Number two is you can actually shrink the JDK to reduce the attack surface by taking advantage of modularity, because attackers who want to break into an application can't hack what isn't there. And then three, you want to apply some other JDK features. Now the patch cadence is relatively easy. It's conceptually easy to stay up to date with. It's not hard. I know it's work to actually do it, but about every 3 months, expect to update your JRE to the best of your ability. If you can't update on a particular 3-month time frame, if you have to miss one, that's okay. You know, there are certainly ways to mitigate it and you can deal with it. But what you don't want to do is to lag and fall, 2 patches behind, a year behind. Oh, I haven't updated my JRE in about 2 years. At that point, you have a significant amount of technical debt behind you that contains a large number of vulnerabilities. Now, in terms of monitoring libraries using the software composition analysis, periodically update those libraries. Set some kind of automated process that automatically updates them to the latest version, or something about 2.7 libraries behind current. But if you do that, then you have a cadence of, you patch the log4j, you patch the Spring4 shell, and you have a regular way of doing that. Because if you don't do that, if you're like Equifax, they had a very large breach that lost a lot of data. That breach led to a very large fine, and it also led to a short prison sentence for the CIO. He didn't go to prison related to the breach. He went to prison because he was doing insider trading on the breach. He knew that it would be bad, and he sold his stock, and that was considered insider information. So he was actually sent to prison and forced to pay some restitution on that. And the restitution actually exceeded the amount of money that he made on the trade, so that was a nice thing to see as just a regular trader. Now, how do you shrink the attack surface of your JRE? There's a tool in the JRE called JLink that gives you the ability to actually remove older modules that you're not actually using. And the reason that I like doing this approach is that people who want to attack your application, who go after it using a variety of known exploits, they can't attack what isn't there. So if you use 2 tools, JDEPS, the Java Dependency Analyzer that can pick out which modules you're using, and JLink, you can get a listing of the modules that you're using, and you can remove the modules that you're not using. So for example, if you're not going to use java.compiler, you can just take it out of there. That way, if there's ever an attack against java.compiler module, if there's ever a CVE in it, you don't even have it, so you can't be breached, and it's not even there. Same thing, java.sql. What's the easiest way to get rid of a SQL injection vulnerability? To not even have the SQL API in there at all. Because people can't attack libraries or capabilities that aren't in your application. You can use JLink, generally combined with JDEPS, to simply take those older modules out. The other one that I like is JDK Flight Recorder. Excellent tool for monitoring the performance of your application. You can go in and get really deep inspections. You can figure out what the garbage collector is picking up, how often it's running. You can figure out how you manage your memory, where that's going, what's your I/O. You can get a lot of really detailed information from it. But on the security side, the best thing that you can grab is what are the deserialization events that my JRE has been doing. Because if you know what those deserialization classes are, you can create that allow list and only allow things that you know are safe to be deserialized. That will save you against getting nailed from a lot of deserialization exploits. Now, if you're interested in security, there's just a couple people who I think are particularly interesting. I'm up there in the top left. Yeah, so I don't tweet as much. I probably should use Twitter a little bit more. I focus on the Azul JREs and the JVM. I do a lot of Java security, Java analysis. I'm also one of the tech editors over at InfoQ in the Java queue. On the top right there's a guy, Ron Pressler, who was particularly intelligent, writing a lot in terms of what's going on with the security manager, why are those things being removed. And down in the bottom, I used to work with Arshan and Jeff from Contrast Security. Jeff is one of the authors of the Enterprise Rootkits paper that has a lot of techniques about how to take over different Java applications should you ever wish to do so. And Fujay, obviously we all know that's a pretty good place to be. There's a nice community Slack where a bunch of people can talk. A lot of really good articles, so I'm glad to see a number of people here today just going through and talking it through. And so with that, I can kind of mill around. You'll recognize me by my Log4j shirt throughout the day. So yeah, your primary takeaways is update your JRE about every quarter. Make sure you're keeping pace with it. Deploy via JLink. You can remove modules that you're not using. And just record different security events that you're doing and get a handle on what your JREs are actually doing. Thank you very much. Oh yeah. We can do a Q&A if people want. I don't know what the status is. I didn't see have a time. Yeah, I want to make sure I don't take into the other presenter. Any questions on security or breaking into different JREs? I think it's a fun activity done well. Sure. What do you got? Yeah, does Checkmarx have some of the capability? So yeah, Checkmarx is a security vendor in the application security testing space. Actually, I'll get back up here as I answer things. There's a variety of vendors that just provide different tools. They tend to do static analysis of software to find defects in your custom code and composition analysis. So they'll give you basically those two things. Yeah, is Flight Recorder more runtime? Flight Recorder is focused on detecting what's happening in your production JREs. So the premise with Flight Recorder, it was created back in the old BEA JRocket days to get really deep performance metrics. So it will tell you about what your production applications are doing. So you can get production insight. And that's great on performance, but what I like it for is what is it doing that pertains to security? What files is it accessing? What have you deserialized? I saw a question over there. Yep. Yeah, what's the difference between JDK Flight Recorder and various tools like AppDynamics and New Relic? AppDynamics and New Relic are fine tools to use if you use them. Go ahead. They'll both give you pretty detailed metrics. I think JDK Flight Recorder, it doesn't need an agent, so it's already a part of the JDK. So if you're using a JDK that supports it, you might as well just take advantage of it. I'm sure AppDynamics and New Relic have invested a lot in their interfaces. They have done pretty well, so you're welcome to use either of them. Any other questions? In that case, I will make sure that we have a number of other speakers, and we will try to get everyone moving. Sure, what do you got? Yeah, what plugin do you use to see Flight Recorder events? Flight Recorder is generally paired with a tool called Mission Control that gives you the ability to see its diagnostics. Otherwise, Flight Recorder also has an event streaming API where you can get that data to go to a particular destination.
paper. I don't know if you
Yeah, I
noticed
saw
that.
that.
So I'm going to try to, I'd like you to try to put this in the center.
Okay, that sounds good. A little bit. My screen's really dark. One, two, four, two, eight. It was working before. Of course. I'm testing it works and then it doesn't in real life. Okay.
I know all about that. Yes, please.
Going outside.
Okay, good. And then this one is a recorder. We'll put it off to the side. But if they're too close, they feedback. I mean, this picks up the digital signal from the other one.
Okay, sounds good.
So, say, oh, can you turn that on and you say test?
Testing the mic. Testing the mic again. Okay. There it goes. Okay. Hello, everyone. Sorry you didn't get a break. I am it before lunch, though, so hopefully you can manage to stay with me for the next 45 minutes before lunch. This presentation is Give Your Build Some Love. It will give it back. I'm Amanda Martin, developer advocate for Gradle Build Tool. And first off, I don't know many of you here. How many of you are software developers, actual developers? Okay, awesome. How many of you are build tool engineers? Really? Wow, okay. That's a lot more than I thought. So this is geared towards software developers. For those build tool engineers in here, just sorry, it's probably way, way too easy for you, but it's for the software developers. So a little bit about me. I have been at Gradle for 5 months, not very long. I absolutely love it there because it's an open source community. And I love interacting with software developers on how to improve their build because software developers shouldn't spend too much time as a build engineer. I think that they're very different. You should know a little bit, but you don't have to get into the weeds. So this presentation is available on tinyURL. So if you go to that link, you'll see the entire presentation. You can save it. You can do whatever you want with it in the open source manner. It is yours to have and keep and whatever else. I like to go to that presentation during the presentation, copy it, and take notes in the speaker notes. That's kind of my thing. And then you can go to your work and pretend like you are an expert in build tool engineering. Okay? So the agenda for today is we're going to go over what is Gradle, the structure of builds, and then we're going to get into some details that I think are really useful for that software engineer. And that's the Java versions, testing a little bit, dependencies, which you guys have heard a lot about already, and then the big one is performance. What can you do to your build to make it perform better? So first, the evolution of things. In general, when something comes to be, you start with the basics, the core features. And then, as the thing evolves, we get an evolution, where we start to add performance features. We start to add safety, security, as we saw with the last two presentations, and of course, assistive features. Now, this is true for almost everything that we look at that has evolved. Therese did a good example of cars, so I'll duplicate that here and also use a car example. The very first car, it could essentially just accelerate and turn and a little bit of brakes, right? But over time, cars have evolved. We have more safety. We have more assistive features. We have airbags and self-parking. So cars have evolved to have all these new things to it. Well, build systems are very much the same. They started out as just something to compile your code, and then we added testing, packaging. Now, however, the build tool system can do so much more. We know that the build tool can do Uber jars. It can do a whole bunch of group tests. There are so many things that the build tool can do that oftentimes people say that it can do too much so they don't even bother starting to use a build tool because it's so complicated and hard to kind of learn the nitty-gritty details. My job here is to help you into that though, so don't be scared. So as you use the build tool, we know it can compile, test, and package code, but over time, it's able to give the user a little bit more feedback. For example, if you use the build tool, you can get some analysis on how much test coverage you can have. If you use the right plugin, you can do some code styles, so you don't have to worry about all those pecky tabs and everything else. You could also generate your POMs if you want to export it to somewhere else. So there's a lot of feedback that we get from the build tool that makes it so that it does a lot more than test, compile, and package. It's now a really useful part so that you can take your programming further. So a little bit about me. I've been doing coding in some regards since about 2005. It's been a long time. Most of my code, this is how I compiled it. I have scripts upon scripts upon scripts that just compile the code. If I wanted to upgrade something, well, oftentimes I would take somebody's code and put it in my package. Copy, paste into my package. Sorry, Therese, I know that's bad. And then I would just run it and compile it like normal. And that was good for small projects. It worked. But as we've gotten bigger and bigger projects, this isn't efficient for so many reasons. And there's also none of those assistive features in this manner. Now, Gradle comes up a lot. This was a tweet that just happened the other day that I really liked because, you know, how do you describe what Gradle is or what a build tool is? In this one, they say, this led me to explain Gradle to a family member. Gradle is a little program that allows you to easily reuse code written by other programmers and other stuff. And that's true. That's what Gradle lets you do. If you see some other code, you can easily take it into yours. Make sure you can trust it, though, because otherwise you might have security vulnerabilities, and we spent time learning about that. So Gradle is a little bit more than that now, though. Gradle has this completely extensible configuration model. We have an entire dependency resolution engine. And of course, like you expect from a build tool, we execute tasks. That's kind of the core feature right there, right? Okay. So we've been around since 2008. So my coding is older than Gradle itself. I feel a little bit good about that because I didn't use it until about 5 months ago. That lines up, huh? So we've been around for a long time. We are one of the top open source platforms, one of the 20 most popular according to TechCrunch. And we get 30 million monthly downloads. So we're there, we've been there for a while, and we're well used. You see us in Java, which is why we're here, in Groovy, of course, in Scala, and then a whole bunch of other places. We also are in Kotlin. I heard some people talking about Kotlin in the hallway track, which is pretty cool because we really like Kotlin. We also have Gradle Enterprise, which is essentially what funds us as an open source community. And this is what Justin gave his talk about, which is all about developer productivity engineering. And by the way, DevProd engineering is a great concept. They have a good book, but also they have a conference in November. So if you like conferences, then this is a really good one where you get to hear from Netflix and Meta and all those places. The other thing that the Gradle Enterprise does, and this is what I love, is it does build scans. Build scans are a free tool where you can go into your build and you can start to see, you know, which classes take longest. You can start to see code coverage and everything else in your build scan. And this is completely free because it's essentially one of the ways that people go in to buy the enterprise product. So I love build scans. And of course, we're hiring. Lots of job openings. So those software engineers and the build engineers that raise your hand, we're hiring a lot of people. Okay, so how do you use it? Most of us probably use it via the Gradle wrapper. Now the Gradle wrapper is anytime you're in the command line and you type in /Gradle W and then whatever task you want to run. The great thing about Gradle wrapper is the person that you're sending your project to doesn't need Gradle installed on their computer to use the Gradle wrapper. It's all built in. They need Java, but they don't need Gradle. So if you're trying to package up your project and send it to another software engineer, you don't want that software engineer to worry about the build at all. So they use the Gradle wrapper. Now, This pains me so much, because my first operating system was TWM. Anyone use TWM? Tom's Window Manager? No? Someone's smiling back there. They've at least heard of Tom's Window Manager. So everything was command line back when I started in 2005 because I was hardcore Linux. So this pains me, but a lot of people don't use the command line apparently anymore. I don't know. So you can also use Gradle from the IDE. I prefer IntelliJ. Some people like to use VS Code. We do both. And then, of course, you could also do it with other various command line usage. So notice in here that I have docs. This is the only slide I have docs listed as docs. After this is just links. But one of the reasons is because then you could click on it and see how things run and whatnot. OK. So like I said, Gradle is an expandable configuration. So when you look at the docs, this is probably a little backwards from what you're used to. Here is using the base plugin Java. And whenever you're doing a task, in this case, in the bottom right is the assemble task. That relies on other things. And so the assemble, it takes all of the jars below it and the source jars, and so that it could assemble them together. In this case, that jar is composed of classes, and then below that is compiled Java. So Gradle knows to go in, and if you're doing the assemble task, it essentially builds everything up from what is needed. Now, as we go through, you'll see that there's a lot of people that contribute to Gradle, and we have a very extensive plugin system. And I'll get into that, what it means in a minute. And part of that is because we have a dynamic DSL that allows people to write a lot of build scripts. So here's how I like to think about how it works all together. We have the Gradle API, which is written in Java. And then some people plug in directly into that API through their build scripts. But most of the time, people use the Gradle DSL, which is in Kotlin or Groovy. Right now, a lot of people are using the Groovy with a big shift to Kotlin because Kotlin is used by Android and stuff. So it's more and more people are using Kotlin all the time. And then we have a lot of people that write plugins, either in Kotlin, Groovy, or Java if they're going down to closer to the API level. But on top of all of this, and for the software engineers, are the build scripts. And that is what really matters, because that build script tells you how you're going to interact deep down below with essentially those classes and the jars. OK, so that's what is Gradle. Now we're going to go into the structure of the build. So this came up a little bit with Sonatype. We have, like Maven Central, we have a repository. And with that repository, we pull in dependencies into our code. That's all fine and dandy. We understand that. But then, like Eric was getting to too, we have all those transitive dependencies that get pulled into your code. You make your code, and then you want to share your code, just like everyone else that made it. So that means you're going to publish your code. Then your code is available in that repository, and the cycle repeats. And so this is why it's important that you have secure code, but also use all the secure code. So in our speak, we have dependency management, which is essentially accessing the repositories and pulling in the dependencies and the transitive dependencies. And then we have the tasks which compile, test, and publish your code. Remember, those are the core features. Everything else is kind of an add-on and extra. And then the script is your code, your build configuration, how you want to define things. So the core concept is we have a build configuration that uses tasks so we can help manage dependencies. Now, like I said, one of the cool things is we have this build automation tool that is customizable. You could do almost anything you want with it, sometimes too much if you ask some people. And that's because we have this extensive plugin framework. If you go into our plugin portal, you'll see tons of plugins that can do a lot of different things. One of the good things is that's a lot of examples. So if you're trying to do something, then you can see how it's done because someone's already done it. OK, so some of the base plugins. We, of course, have the Java plugins. Now, the two that are most used are the Java library plugin and the application plugin. Most of the time, I use the application plugin because you essentially want that main class configuration. If you have a main, then you're going to want that application. Now, the application plugin automatically uses that Java plugin. So that means if you're using the Gradle application plugin, you're writing a Java application and you already have the structure for main. So by using this plugin, you have kind of a whole set of configuration that's pre-built for you. And you don't have to define where your main is or anything. It's really nice. And by the way, we also have a Kotlin plugin that does much the same thing, only it's for the Kotlin. And this is really cool because you can have Java programs sitting on side of Kotlin programs, and you could actually build them together. You know, source main Java, source main Kotlin, right there, and they build together. And if you have the Kotlin code with the Java, then you just apply Java application and the Kotlin plugin, and it's perfect. This plugin is, by the way, maintained by Kotlin, not by us. And so you can start to see that the open source community is this really big, rich, vibrant community. Okay. Now, the plugins that we have are just one type. Like you saw with the Kotlin, there's a whole bunch of community plugins. And the plugin portal is just widely used. You could publish your own plugins there for other people to kind of download. Some of the best ones we'll get to a little bit later. But it's just kind of, if you have time, go to the plugin portal and see what's available. It's just amazing. You have plugins to help sync with Kafka, with Kubernetes, just everything there that you already want. It's already written probably. And of course, then there's local plugins, which if you're not a build engineer, you probably won't fuss with too much. So these plugins are like the big overarching thing. The plugins, what they do is they provide tasks for you to work on. And a task is kind of the basic concept in Gradle. So you have an input, your code, maybe a different jar, something else. That does an action, and that results to an output. Now, a lot of the outputs are stored in a Gradle directory, something that you'll probably never actually look into, but it's there so that you can be saved for later references. Okay. Here's one example of a task, and this is the test task. And you can imagine that all this is inputs. In this case, we have inputs, which it sets a location inside your directory, and it will output the reports of the test. Now, one of the things that I like about this is here you can see kind of the dependency tree for that test task. And so it uses a whole bunch of other things. We need compile Java and process resources for this one. And so that means those have to be defined before you do this one. And all of that is kind of the behind the scenes what Gradle is doing, so you don't have to worry about making sure your test has all those other features. Now, when you're writing these tasks, this is something that has kind of changed over the years, where we have lazy configuration, it's called. And this took a while for me to get used to because we want our tasks to be lazy. Lazy means they don't have to use as much resources. And so a lot of the times you might see the task.create, and those are very eager, meaning they gobble up all your resources. Every time you do a build, it essentially runs or essentially makes that task. If you don't want that task made, you're saving resources, and you could use the task.register. So in that case, it's going to define the task without actually creating it, which is really useful. If you're doing a more elaborate test, you might know how to use it, but most of mine are like that. The other thing that I use pretty extensively is the do first and the do last. Now, these are tasks that if you know you want to have something run before another task, then you're going to put in do first, and then you'll see your task graph where it always relies on the do first before the next one. Okay, so, and then like I said before, the build scans is another one that I use all the time. Each one of my settings.gradle file, I have this blurb because at the end of every run, it generates a URL that has my build scan. So that means if there's a problem, I could take that URL and send it to someone, and they can help me troubleshoot that problem or see how I can manage resources a little bit better. Of course, a caveat, this is only recommended for personal projects, open source projects, things like that. You don't want to do, send your Netflix build or something to it. So all of this so far has been kind of the key overarching facts for kind of small projects. Of course, Gradle is very extensible, and so we can change it so it's bigger projects as well. In this case, we have a root project, and off of that root project, there's a whole bunch of sub-projects. Now, This might look familiar, especially to Android engineers, because oftentimes you'll have a whole bunch of projects. One of the recommendations for this type of thing is to kind of have a build source folder so that you have a central place to manage your build configuration. And I think I have that next, yeah. So in this example, we have a build.gradle.kts, that's our Kotlin version, and each one of the sub-projects has a build file. So in this case, we have the app in the model, and each one has different dependencies, a different configuration, and a different management. Now, the problem with this is that it can get very hard to keep track of the configuration of all of these projects. And then if you're taking your project and you're publishing it, then somebody else is going to take your project, and they have no clue how you manage your project. So this is not necessarily always the recommended method. The way that we recommend now is to use what's called a build source folder, build SRC. And this is really good for kind of a central location for all of your build logic. And so you can have your build logic in one spot and then apply it to the other projects. And in this one, you can see that it's called shared build conventions. I like that name because then you know that it's a shared convention between the projects. So some tips that they don't tell you that is kind of useful if you run the thing. If you're running the Gradle wrapper, -- console equals plain or -- console equals verbose. Those are really useful if you're trying to kind of troubleshoot your build. I use the verbose almost most of the time. It spits out a lot of stuff, but oftentimes you can scroll through. You could pipe that to a file and then read it later. Both of those are really nice. So let's zoom out on the structure of a build. So we have two different types of people that generally use it. We have the build user, which is going to be your software developer. And then we have the build author, which is oftentimes the build tool engineer. Sometimes it's the software engineer that has to kind of delve into the build. So the build user, they're going to be launching the tasks. For example, debug, test, assembly, and so forth. They don't need to know a whole bunch of the build structure. They just need to know which tasks to run. And so those are the ones that you're going to send your project, and you say, just run this, and you'll get everything working. And that's because behind the scenes, there was a build author that made the build logic that is essentially what Gradle uses to run. Now, a third party is those plugin authors. And so all of that is essentially taken into one central location, which is your Gradle project. Now, all of this is stored in a folder. That's why I have a lovely folder here. Because all of the Gradle logic, you have your build model, which essentially delves into that DSL. You have your task graph, which goes into the execution project. And so as a build user, all you really care about are what tasks to run. OK. I can spend more time on this, but I want to move on since we have a lot of performance stuff. So now it's kind of getting into the details of what software engineers probably want to know. First one is Java tool change. So we saw last time that it's really important to upgrade to the most recent version of Java. That is really important. But sadly, not all projects are capable of running the newest version of Java all the time. And so you might have some sub-projects that use an old version of Java, and this other one that uses a newer one. And that's OK. You might be used to having all of those problems with your Java home, and that was a common pain point with developers. And so we went ahead and delved away to kind of fix the Java issue. Now, you might have heard of different infrastructure provisioning tools like Puppet. Has anyone used Puppet? A few of you have? OK. I never actually used Puppet. So, and there's, of course, virtual images. And if you use these tools, you can make sure that you have the correct version of Java available for the user. Just because it's the correct version of Java is available doesn't mean it's the right version that is used, though. And so what we have is we have something called tool chains. And what tool chains do is it makes sure the correct version of Java is used for each project or sub-project. And so here's a little bit of the code, and you can see it's pretty easy. This one is set to, anyone want to guess what version of Java this one's using? I see mouthing 11, so that's perfect. And of course, like everything, you can turn this on and off with a tool changed flag. So where this becomes really useful is you can start to specify which tasks will use which versions of Java. Here we can see that we have Java compile is set to 17, and then we have an extra kind of project in there, and the run extra is set to version 18. And so if you give this to that build user, then depending on which task they run, they're actually going to use a different version of Java. And so hopefully the goal with this is when you give it to the user, you no longer get that complaint of, why do I have some Java home error or something? Because they're going to be using the right version. Okay. Now another big one is testing. I think everyone has seen the testing pyramid. And Justin talked a lot about how testing is really slow and people want to speed it up and whatnot. Well, end-to-end testing is always going to be slow. We don't really want to do that too often because it's so slow. But unit test and integration test are something that we frequently run all the time. And those integration tests, especially, they run really slow. And so I've skipped a few before. I know I need to run them because they're so slow. Now, one of the things that we do is we split the tests so you can run your integration tests at a more cadence than your unit tests at a frequent cadence than your integration tests. So of course we have a task to run all tests. But if you split it out, then you could run the unit test and the integration test separately, and you can choose your cadence then. Okay, so let's see what that looks like. Well, first, some of you are probably used to splitting out the unit test and the integration test. The way that this has been done before is you create a source set. These are the sources for your unit tests. These are your sources for your integration tests. You configure the dependencies for both. The integration test often had many more. You set the class paths, and then you create a custom task for each one so that each task was different. When you ran the unit test, only the unit test ran. Integration test, only unit. So now we have something called the JVM test suites. And this is really cool because when you use the test suites, all of this other stuff with your configuring class paths is kind of done behind the scenes automatically. So first, we, of course, apply the plugin in our build file. And then we start to program how we want the test to actually work. And so what this one does is it makes an integration test folder, which is essentially a different part of the unit test. So you can run integration tests separately. And this is a very basic example. There's a whole bunch more in the test suites documentation. So another big part of testing is test coverage. With TDD, I've heard that it's a 5 tests per line of code is one of the recommendations, which that seemed a little high. Anyone have a better number than 5? No? I've never had 5 tests per line of code personally, but I guess some people do. So we have the Jacoco plugin, which is really nice because it will tell you how many lines of code are actually tested. And it will fail your build based on that number of lines. And so in this case, we are, of course, applying the Jacoco plugin. And then we have the Jacoco test coverage verification task. And what this task does is it essentially looks at it and counts how many lines of code are covered. And if it's not 90% of lines coverage, then it's going to fail that build with this task. That's kind of cool. So now if you have a software developer that's adding code to your project and you send this to them and you have them run this, their build will fail if they don't have enough tests for their thing. So some other ones that people really like is for code styling. For code styling, there's the Java check style. It's a really highly used one. For Groovy CodeNarc, for Kotlin detect, and this essentially checks your code style and helps apply the right rules for the language. And then, of course, we still have a Scala one, which I haven't met more than like 5 users that are interested in our Scala, so I'm not sure why I included it there, but it's there. Okay, so now dependencies. So we recently launched Gradle 7 And with that, we have version catalogs. This is a really new feature, but it's one that kind of is amazing for dependency resolution. A little bit against the normal Gradle policy is that this is a TOML file, and the TOML file has 4 sections where we have the versions, the libraries, how you want to bundle together, and then the plugins that you might use. So what does this look like? So here you can see we're defining the Groovy version. We're defining the check style we want for our code. Excuse me. We have the different libraries that we're using, and notice on this bottom line that we're actually applying the different versions that we want with some weird language down here. Then we bundle up our Groovy ones together, so all of the Groovy, we can just use it with just one Groovy, and then we're using some plugins. So when we're using that version catalog, we can use what is defined in that version catalog, much like any other dependency, where we have libs dot, and here groovy.core. And so I'm setting that as an implementation dependency. And then, of course, I do the same for the other ones. I could have shortcut it. But I wanted to talk about how these are an implementation dependency. One of the common problems that I've seen is people use an API rather than an implementation dependency. Now, there's a big difference, of course, between the API and the implementation. And that depends on whether you want the essentially dependencies to be available for others later on down your project. So when you're making these, you got to think about whether it's an internal implementation dependency or if it's an API and you want it available for others later on. Now, everything in green here is essentially the different configurations that are available at this point in time. And so you can have it so that it's a runtime only dependency or a compile only dependency. And you want to think about the scope that you have for those dependencies. And then, of course, these are the ones that are commonly used. So when it comes to the version, this is a huge thing because we just heard the last 2 talks about how you should use the version that makes sense for security. You should upgrade. You want to make sure that you don't upgrade to something that's not secure. And that is true when you're defining your build logic as well. And there's a lot of ways to kind of manage your dependencies. In this top one, this is using version 2.3 or later. So if there's a 2.4, 2.5, that is later, so it'll use that version. If you have 2 exclamation marks, then that is strictly. That's the one that I like to use a lot because it allows for a reproducible build. I know exactly what I'm getting. I know what's going out. So I use that strictly most of the time. And then, of course, snapshots, which I rarely use. If you want to see more about kind of the version, then there's a link there for that too. But then we also have the bracket and the parentheses, which allows you to do kind of the bounds of the versions. And people like that a lot. But I like the strictly the best. And as far as security, that's a good call too. So one of the problems with versions, of course, is, like I said, they can change. And so if you take your project and you want to share it to somebody else, and you're using something that's like 2 point plus, it might work on your computer at that time, but then tomorrow you send it to your user, and suddenly it's now 2.7, 2.8. Well, maybe one of the things you used somehow broke. Now the build won't be producible and it will fail for your user. And so I like that strictly. Now the other thing that this is really useful for is whenever you're using a build cache, the versions are cached for a certain amount of time. And so if you're using version 2.6, it's not going to necessarily pull that 2.7 for your build right then. So if you send your build somewhere else, maybe they're using 2.7, but you might still be using 2.6 because it's cached. So some of the common pitfalls I've seen. The other thing that Gradle does, and this is another behind-the-scenes thing, is here we have a dependency on Guava 30.11. We also have a dependency on Juice 5.10. So Juice also has a Guava dependency. For 5.10, according to the dependency graph here, we know that the dependency is on Guava 30.1. Well, since we defined the dependency 30.11, it's going to automatically override that Juice dependency and use the 30.11 everywhere. Only one version allowed of each dependency. I like that, but not everyone does. Okay, so these are version catalogs. And the thing that I really love about them is you can have all of your dependencies in one spot and then use them for your other projects. And so in this, we can see that it's just you're using the library or the version catalog from a different project. And so if you're starting to have a project and you have a trusted set of dependencies you want to import, then you can pull in that version catalog in one spot. Okay, running through this fast because I know lunch is in like 5 minutes or something. So performance. Gradle automatically has, like I said, a lot of those features that have come with time. Kind of like assistive lane driving in cars. We have compilation avoidance, but then we also have incremental builds. So whenever you're running our projects, you'll see a lot of up-to-dates. That's normal and okay. It means it pulled it from something that happened really recently. Everyone's using this already. Some of the things that aren't being used, though, is the build cache. It is amazing to me how many people haven't turned it on. And yes, this is from Justin's talk, although the data here is different. This is data from Spring Boot. And here they had a build that took 20.25 minutes, and that was just how long it took to build. And then when they used just build cache, it dropped to 3.22. So a pretty big drop. And this is just with, using build cache. So what is build cache? Oftentimes when I'm developing, I will make these changes. Oh, does that work? Build. No, that didn't work. What about this? No, that didn't work. Then I go back to the drawing board. What about this? Okay, I'm back to where I was. And so each one of those builds is essentially stored on your local build. And so if I go back to the beginning, then the build is going to be instantaneous because that already happened. And so every single build is stored locally, and it essentially pulls from it. Okay. Now, to turn on build cache, you can have via the command line -- build cache, or what I do is I put it in the Gradle properties folder. And this isn't done by default, so you have to add it to your build, but it makes it so that your build pulls from all the other stuff. And so if you have system.printout hello world, and then you add other stuff to it, and then you go back to hello world, the hello world will actually be pulled from the build cache because you've ran it before. Okay. So another feature that I absolutely love is the configuration cache. Now this is not yet stable. Sorry, so it's one of those in the works. But we are seeing great improvements with it. And what this does is it caches the entire configuration lifecycle. Now there's essentially 3 phases of a Gradle lifecycle. There's initialization, configuration, and execution. Most of the time, software developers don't care about configuration, right? And most of the time, configuration doesn't change. If you're changing your code, the configuration of the build won't change. And so configuration cache means you can use that entire build cache before. So in order to use this, you have to change your settings.gradle file to enable this. And then also the Gradle properties, you have to add it in too. But the savings of the configuration cache are huge. This is Tony from Square. He tweeted this the other day, that at Square they're saving 5,400 hours a year by just turning on the build cache. That's huge, right? I think that's like 3 years of engineering time or something ridiculous. We just finished a hackathon with configuration cache. We're trying to make it stable, but it's a really big process, so it's not there yet. Here's another example of kind of how the configuration cache has helped with some people. Just running the help task drops it. This is the assemble task. So you can see configuration cache is really helpful with time. Another one that isn't used very often that I highly recommend that you turn on is the continuous build. Now, and this is such a fundamental change that I actually go into my IntelliJ and change it so that this is on my most used task, -- continuous. Because when you're in your program and you're changing, your class, your method, whatnot, it actually senses the file has changed and it will run that task behind the scenes. And so if you have like an Android app, for example, up, and you have the continuous enabled, it's like you've ran that task again behind the scenes. And so you don't have to essentially worry with your build. It's kind of automatically there. Another one is parallel. By default, most of the tasks are run synchronously, one after another, and you have to actually opt into parallel. This is because if you have multiple projects, parallel isn't very smart, and the input, if it's uses the output of one, if it's using the input to the other, then you might get a build failure. And so this is another opt-in one. Now, finally, this is the last one, and this is for probably the build engineers have probably seen this one before, I'm guessing. And this is the profiler. I like to use the profiler when I'm at the final stages of my kind of program, and I want to see what takes a long time to run and why. And so you essentially, this is an entire separate thing, but you have a performance scenario and you're running it essentially like, do I want this version of Java or this version of Java? I did this recently with, I think, some Maven builds where I ran Maven on something and Gradle on something. It was kind of seeing the benchmarks for it. But it really lets you have the insights for your build, because the profiler lets you see how long the builds take to run. And it does essentially a clean build again and again and again and again. And so this is after like 20 iterations. And the output of that is a flame graph, or a flame chart, or a graph. Now this flame chart, this one is interactive, done a little while ago. But if you click on it, you can actually zoom into each one of these to see how one version compares to the other and where you can have that potential speed up. So those are pretty nice. Okay, 1 minute over, so not bad. We went over all of these things. You can reach me on various social media platforms. We're on Gradle.com and Gradle.org, and this talk is on that tiny URL if you need it. Any questions? Except for from the build engineers. I'm not taking questions from them.
What is the easiest way to get Gradle to give you information? Well, so one of my biggest problems about using Gradle is I'll use plugins, and depending on how the plugin is written, the configuration for it is just vastly different from a syntax perspective. Whereas in Maven, everything's just XML.
Yeah.
How is there a good way in Gradle to like figure out if something's supposed to be assigned as a map, a list,
So the question is essentially, with all the plugins out there, how can you know how to interact with that plugin so that it's something you're expecting, essentially? Because in Maven, it's a very uniform way of doing it, and with our plugins, it's all over the place. Does that frame it up good? Yes. Yeah. And so this is actually a really common pain point with our community. And we have a plugin portal that has all these plugins, and some plugins are way better than other plugins. And so some of the things that we're looking at is having like a test suite for plugin authors. So here's the test that they have to run so that they can get like a badge on their thing. Maven Central does such a good job at how they handle that, where you can see downloads and all the other statistics. And down the road, we're hoping to have that type of thing too, so you can see how many people are using certain plugins. And most of the time, if it's a highly used plugin, then it's probably something that's easier to work with than one of those that's not there. That's still in development, though. We only have about 20 developers, so things take time. Good question. Any others? Everyone just wants to eat, right? Okay. Thank you very much. Oh, another question. So with Spring Boot and Gradle, the versions?
So the thing when you update to 7.0 more for Gradle, and Spring Boot is not catching up yet, right? So, so we need to, still remind you what version of Spring Boot, but Gradle is like, having issues with that. And also, when you update to Gradle, the older script, right? You're using Gradle 5 or 6. That's not even compatible with the latest version of 7 version. Syntactically,
So if I got that right, Spring Boot and Gradle, why do the versions not line up all the way? That was the first big one, right? So it's actually funny because if you look at our download numbers, Spring Boot is one of the biggest ones that is being used all the time as far as plugins go. It's really, really huge. And right now we're on Gradle version 7.5.1 actually. And I'm not sure which one Spring Boot is using right now. But being compatible with Spring Boot is one of the things that's like one of the top priorities for us. And so if you have some examples, then point them to me, and I will bother our devs to make sure that they are compatible.
In Gradle website, do you see a tabulation between Spring Boot version and what version of Gradle you need to use? But when you use the older version of Spring Boot, there is some issue.
Yeah. So essentially, when you're using an older version of Spring Boot, there's an issue. And if that's the case, then I know that in Android, that's where I do a lot of my time, there's a compatibility chart where if you're using this version of Android, you got to use this version of Gradle, and so forth. I don't know if there's something like that with Spring Boot, but maybe there should be. Or if you're using this version of Spring Boot, we recommend this version of Gradle. That would be a good idea to have.
And also when you go into the upgrade of Gradle version, the script used in like 5.0 version of Gradle is not compatible with 7. And syntactically, we need to change a lot of changes. Like for example, usage of objects to methods. So these are a lot of changes we need to do to migrate to 7.0 level.
Yeah. So he's pointing out that the syntactic changes is going to like 5 to 7 in Gradle. And that's one of the big things is a lot of times when we make those changes and the big changes, we're going to get a lot of breaking changes. And a lot of time and effort goes into kind of making sure that your project is good from 7 to 8 and so forth. It takes a lot of developer time, it really does. So, but we do have some migration guides. If you look at the release, you'll see that there's a migration guide for all of them. That spend too long writing. Okay. What's that? So when we're doing scopes, we have essentially the API scope or the implementation scope and things like that. And so the compile only and the runtime scope. But it's time, so let's talk at lunch, okay? Okay, thank you guys.
Okay, getting ready to start. You guys ready? All right. How's it going, everybody? Thank you for coming to this talk on Lights, Camera, Action, GitHub Actions. Oh, I'm sorry. Hello, everybody. Thank you for coming to the talk on Lights, Camera, Action, GitHub Actions, particularly for Java projects. So really quickly, in the hands in the room, anybody use GitHub Actions? Oh, good. Has anybody not heard of GitHub Actions? So everyone has, and cool. Great. So for those that don't know, I want to give you a little bit of context. So imagine you work for a company, and this fictional company, and you recently heard that there's a security vulnerability in the current JVM that's running in production. And particularly in, say, 17.0.3. And usually in CVEs, or what is known as common vulnerability exposures, sometimes they can be very, very bad, where it gives an attacker access to your JDK. So of course, if your boss would ask, how fast can you get this patched, and how fast can you get this back up online? All the while, the users can actually, they won't even notice downtime and, experience any, lag or anything. So how do you answer your boss? You may answer, well, it depends, right? It really depends on how you deliver your software. For instance, like CI/CD, or how you release, how do you test, how do you build. So if you use old methodologies in software development life cycles, such as like handwritten scripts, they're very error prone, and you could really have a bad time, just an all-nighter trying to, swap out the JVM, run a bunch of tests, and if you have things working well, and it takes time to schedule deployment and such. But if you use CI/CD pipelines, you're probably in good shape, because you're doing things in an automated fashion. And CI/CD, if folks that don't know, it's called continuous integration, continuous delivery. So the idea is to rapidly do this in an automated fashion. So real quick, a little bit about myself. My name's Carl D. I'm a developer advocate for Azul Systems, where we build high-performance Java runtimes for companies to help reduce infrastructure costs. If you want to hear more about me, you can just look at that QR code. It's not a hackable. It goes directly to fuj.io. So it has a lot of the blog entries that I write about. And I used to be an ex-author of some Java books, and my last one back in the day was Java 9 with JavaFX. So back to CI/CD and delivering software and this automated fashion. I think most of you have seen this diagram. It's quite common if you see in development shops, such as you plan, you code, you build, you test, you release, you deploy, and then you monitor, right? And then it goes around and does it again. You plan, you code, you build. So it's infinite. You see this a lot. But you're probably more familiar with the orange sections, which is code, build, test, and release and deploy. but mainly as developers in a team. Those orange sections are probably automated using common tools such as the ones you see here. Some people might use other things called like cruise control. If back in the day in C++, or they'll use different types of tools, but these are the common ones that are used in the Java world. And so now these particular things have pros and cons. If you're not familiar with, if you don't use any of these, you may not understand the pros and the cons, but I'm just going to list them out just to share with you. Runners are basically, it's like virtual machines that have the operating system or that platform version so that you can run and test and build on that instance. So for instance, in Travis, you can actually specify the various runners that you can have for Mac, for Windows, and Linux. So in Jenkins, you might have some difficult issues because if you run it on a particular node, it's on one operating system. So you may run into issues where if you want to build for a different platform, you may need another instance of Jenkins running on that particular operating system. And also in Jenkins, you may have issues with memory, because if you have concurrent workloads of building software, you're going to run into memory problems if they're running at the same time, or the particular jobs that are running. And then the third option is caching dependencies. Often we use Gradle or Maven, and usually transitive dependencies like jar files are pulled down to the local environment, and then that helps build the software. But if you have multiple projects being built, they're sharing the same jar file from the same local repository. There's no reason why you can't use it. But if you're destroying or cleaning up the environment and you're rebuilding a project from brand new, why do you need to download it from Maven Central or some centralized repository? So caching dependencies is very important to speed up your build process within the CI/CD pipeline. And another very, very important thing, and this is what this talk is mainly about, is about GitHub Actions, and which we'll talk about later, is actually swapping out the JVM or the JDK. So for instance, there are many vendors that support and build an open JDK version. So you may want to pick a particular JDK versus another vendor. Because in the cloud world, within like Amazon, they have Corretto, and Azure world, they have their Microsoft build of the OpenJDK and such. So what's great, since 2019, GitHub is not only just a source repository, but they also offer CI/CD services to build, test, and use their runners for free. So it's awesome. They also provide concurrent or parallel uses of their runners, so you can build for, say, 3 different jobs or 4 different jobs on 4 different instances, simply at near the same time. So if your build and test and deploy or release takes 4 minutes, they'll all finish at around the same time, but they give you 4 for free running in parallel, which is really great. So back to the idea of CI/CD and automated processes, you really want to just focus on coding, because all this stuff should be automated, the orange sections, after you code or change code, like build, test, and release and deploy. You just want that all automated. So back to the use case in the scenario where your boss really wants this JDK swapped out. This is how, he just wants this back online and the user's happy. So this is a typical response in how you should respond to your boss. So the idea is that the security officer or the security team says, hey, we call it CPU or critical patch updates. And those, if you're a customer of, and you have paid support through a JVM vendor like Azul, they would provide you the patch release of stream builds that you should use to replace the current running JVM in production. So really quick, again, this is not hacked. It really goes to github.com/carld/GitHub-actions. If you guys want to look at the project, I have four or five workflows that is going to do the whole process of the CI/CD pipeline, which is actually, changing the JVM that we want, which is going to be 17.0.4, and it's going to be the latest. And what's being deployed will be the JRE that's headless. It's smaller than just the JDK, so once it replaces it, you can go there and look, but I'm going to show you further. I'm going to show you the QR code again so that we can watch the process of the CI/CD pipeline actually occurring. So the application is a really simple microservice written using the Micronaut framework. And so in Micronaut, it's very similar to Spring Boot, where you go onto that URL you see, and you can simply build out your dependencies. You pick Java, or you could use Groovy if you want, or Kotlin, and you could choose your build tool. And I'm going to use Gradle in this situation. And so Gradle will do the build, the test, the typical things that you would see in that yellow section that we showed earlier in the graphic. And then, of course, JUnit is a dependency. If you want another testing framework, it's fine. But it has a simple test that comes with this demo when you hit the generate button. So just like in Spring Boot, they have a controller, and here is a endpoint that's created so that you can hit the endpoint. So I made it really simple. So the idea is that the standard Java properties, java.version, all I'm doing is outputting it. And that just shows that it is at 7.0.3, the current version of the application in production. So the idea of this, the workflow or the GitHub action workflow, when it finishes, it'll deploy automatically to production, and then we'll hit that endpoint again, and we will see the new JDK that was swapped, the security patched version that'll just swap and, does the testing and it deploys automatically. So yeah, that's what I wanted to show you too, really quick. So I will talk about how to do this later, but this is what a workflow looks like. This whole CI/CD pipeline is like 40 lines of code. It's not, well, if you call YAML code, it's a markup which describes a workflow in GitHub. And here there's a lookup, and here I'm specifying the build version. And this is what the current version in production is in this demo. And then the idea is to switch it out with the 17.04 and this thinner version of 17.04, which is the headless version. So GitHub Actions, we'll talk about that in a minute. The idea is that you can pick different packages, like how you want the JDK to be downloaded and set up before you do a build and a test and a run. So again, here's the QR code to the GitHub project of this talk. What I'd like you to do, if you want, you don't have to, we can go through it, but the idea here, there's a tab called Actions. This is what the talk is mainly about. So yeah, if you click on it, the Actions tab on the left are all the workflows. So the talk, I'm going to talk about GitHub Actions in a minute, but the one of them talks about deploying. So that is all the orange in that graphic. That deploy workflow does all those steps. It does the building, it does the testing, it does the release, it does the deploy, all in one script. But the other ones are the things about how to set up Java when you actually create a workflow. So really quick, yeah, let's do that now, actually. So really quick, here is, whoops, okay. Can everybody see that this is the current version? And so the idea is to go to the page, want to go into the workflows. I'm sorry. Oh no. Okay. Okay. Can everybody see this? They can see this workflow? Yeah, this is kind of hard to see. Should have brought my mouse. So in YAML, I actually use the comments there. Just gonna do that. So what you want to do after what you want to see is, so here you have this workflow that's actually being kicked off. So you can watch this and just examine it at the moment. And then I'm going to just explain the workflow in a minute. So here's just kind of what it looks like. You can watch it actually perform the GitHub action or the workflow. So while that's doing that, let me just go back to the talk. So I showed you the Swagger API that shows that it's at 17.03. I have a Docker container. And so I just want to show you the high-level architecture of what this little demo will do. So what it has is a container called Watchtower, and that container actually looks at Docker Hub for changes. And then at GitHub, you saw me in the YAML edit mode where I changed the version of the JDK, and it's using, I can talk about that later, but what it does is it builds the Docker file and it builds the image, and it picks the right JDK, and it actually builds that container or that image, and then it pushes it up to Docker Hub. So it's because it's detecting the change, it then redeploys that container that's in production with the new version, with the right JDK, with the right patch. So while that's going on, someone in the room can tell me if it's done or not. It's one of the workflows. I think I clicked on the wrong one, but the one that I wanted to try to click on was the one that actually said deploy, which actually did that workflow at a high level. So what is a GitHub workflow? So this is a YAML file. It's really simple. It goes in, it's a convention at GitHub on your work project in your working directory at .github/workflows/ whatever your file is, .yaml. So your file, and I'm going to go through what a workflow actually consists of. It's really straightforward. I mean, it's in these three boxes here you see. First, you listen to events, and these are Git events. And these are the three common ones that are used. So for instance, if somebody were to push code, a developer decides to push code, that event's triggered, the workflow will detect that change and it will run the job, just like in Jenkins or any other CI/CD tool, and then pull request. Since GitHub is, an open source, repository for everyone to contribute into open source, a lot of times people will get pull requests, and you want it to build separately from the main branch, and you don't want it to be disturbed. So pull request, when you listen for those, you can actually run jobs and create builds and tests on a different branch if you want. And then the last one is workflow dispatch, which is you as the repository owner, you have the ability to actively kick off the job if you choose. And it listens for it, and then it actually runs the job. So then there's these concept of runners, like I said before, very similar to Jenkins, or no, not Jenkins, the other CI/CD tool. Allows you to run, virtual machines or nodes that are on a particular operating system and versions of the operating system. So you can get a version of Linux or you can get the latest of Linux. And so each runner will run a job, and each job has steps. And the two kinds of steps that you can only have is run scripts, simple bash commands, or PowerShell, whatever operating system that's installed. And then the second thing is GitHub Actions, and that's what this talk is mainly about. So when you create a project at GitHub, you just get a blank project, right? Well, you create stuff, but when you click on the Actions tab, you're going to get this search field to actually search for things in the marketplace, and they're already made available templates that allow you to set up Java projects and even Node.js projects. But later I'm going to show you, we're going to click on the setup workflow yourself right there. But yeah, just to show you just the common things that they'll present to you. Sometimes if you have a wider monitor, it'll show it to the right. It'll say, oh yeah, you should use Gradle, you should use Maven. And those are fine and dandy. Those are really nice. And I think now the GitHub action is called setup at V3, which is up to V3 now. So we're going to click on that and actually build one ourselves. It's really straightforward. Like I said before, it's those 3 boxes. You know, it listens to an event, it runs a job on a runner. Each job has a number of steps. Pretty simple. So here we have, we created a workflow. It's a file that's in that convention that I mentioned earlier, .github/workflows/whatever you want .yaml. And so when it listens to the event, just keep in mind that see on line 3, it says name, that's a keyword. So the YAML file, it follows this convention that on colon is also a keyword to listen to those events. Those push and pull requests and workflow dispatch, those are actually keywords also related to what it can listen to. The reason I say this is really important because sometimes YAML is very difficult to kind of understand because you don't know what is keywords and what is user-defined words. So for instance, jobs, colon, is a keyword. That means that a workflow can consist of one to many jobs. So that in line 19 is a user-defined job. So I named it build. So I could have called it anything. I could call it hello world. That is not a keyword. Just keep that in mind. So of course, runs on is a keyword. I showed it in the previous slide that you could run a runner, a particular operating system. I think we don't, or GitHub, not we, they don't support the ARM64 yet. So that I'm not sure when they will. So you saw on the previous slide, there was one runner. So how do you specify multiple runners? So you could create in YAML an array. You just simply specify it in that way, you know, in quotes, comma, in quotes, and angle brackets, or brackets. So how do you make it such that it's easy to look up instead of, you know, hard coding it in that way? Because you could actually reuse, it's the concept of, so they have this thing called a strategy object, and there's keywords, and then there's things that you define, which we'll explain. So here is a strategy object. See that keyword? It says strategy colon. Underneath that, it says matrix. That's a user defined. That could be hello world. That could be whatever. So nested under that object that you define, OS is also user defined. It's not a keyword. So that could be hello world, whatever. So later, well, you could see it in runs on. So if you want to specify this lookup, you use the $ double curly brace, and then the, notice it says matrix.os. I know it's defined later, but YAML's really loaded up in memory, and you know it's like forward referenced. So here it's defined below, but if you want to create a job, in this case, that one job called build, since you see 3 runners, 3 types of runners, it will run that job 3 times. So if you notice, and then if you have, what we'll see is we'll create different versions of Java, the Java runtime. So that's multiplied even more. So it's going to run like this version on this Linux operating system. It's going to run this version, you know, on Mac, and so on. So like I said before, strategy is a well-known object within GitHub, or GitHub Actions. So that's a keyword. Matrix is not a keyword, it's user-defined nested lookup, so you can make it, here it's nested only one level deep. And then fast, or fail fast, is an actual it's a keyword of the strategy object. And that's defined where if you say false, it'll, it means that if you have a runner, if you have two different runners, and if one fails, it's okay. You're still going to go on and run the second one. If you have that as set as true, if one fails, don't even run the other runners. So for instance, if you literally have a bug in the Java code, why run it on all the runners? You want to get out really quick, let the team know, and we fix that problem. And then, of course, this is another keyword. It allows you to run simultaneously on different runners, up to 4. That's what I said before, that GitHub allows you to run 4 at the same time. I think you can, for enterprise, you can have more, even more, running all at the same time. So now we're getting down even, we're almost coming to the end, because this is the most important thing, is about the steps. So I said before that the steps are, you can run scripts or you can run GitHub Actions. Those are the two types of things that you can do. So the very first GitHub action that you'll learn is the checkout. So the checkout action, it's at version 3. It's good to just use what they kind of recommend, is, that's the latest. But what it does is simple. It checks out your source code. Then you do whatever you want. It's just like you're at the command prompt and you're locally with your project and you do Maven builds or Gradle builds or whatever. So in summary, a workflow has multiple jobs. Here's a user-defined job called build. You have runners. You can run multiple runners, which you use strategy and nested object lookups. And then you have steps, and of course you have scripts or GitHub Actions. So just really quick, if you are in a bind and you don't really know what GitHub Action can actually serve your simple task, you may want to just know how to do it in Bash. You know how to do it within the command line. So this is just really simple. This is how you run a script. There's a keyword called run, and then you just run your script, like here in this example, but that's for a single statement. And if you use the pipe symbol, it allows you to have multiple statements. So in the example or the demo where I use the whole CI/CD pipeline to go from coding to all the way to deployment, at that last step, that's where I actually wrote script code to do the build and the push to Docker Hub. And then it would deploy locally. So now we're going to talk about GitHub Actions, and GitHub, especially the one called Setup Java. So Setup Java is a GitHub action to build Java projects. So by default, they give you Maven, they give you Gradle. So if you go to GitHub Actions, the documentation, they'll tell you, I have a link at the very end, but it'll tell you the available things that they give you for this setup of Java. So it's almost like you're a developer locally and you're building your project. All these tools and build tools are all available for you. but it's really easy to specify, and I'll show you. So the original one is version 1 from Setup Java. They partnered with our company, Azul, and the very first version only supports Zulu, which is our build of the OpenJDK. It's derived from the OpenJDK. And like again, runs on, everyone knows that that's a keyword, and we use a matrix lookup of those 3 operating systems. And then in the strategy object, you have your matrix that's user-defined, matrix.os, matrix.java, and those other attributes or options. And so this is how you set up or use Setup Java at version 1. So if you're doing this workflow yourself, you're not going to the marketplace, because the marketplace will by default use version 3, which I'll explain in a minute. So here, these are keywords. So when you use this GitHub action, it says uses. That's keyword, colon, the GitHub action that I just mentioned. Then the with. These are the options for the Setup Java action. So you're specifying see it says java-version, that's a keyword. Your matrix.java, that's not, that's something that you defined where you're looking up and you're substituting it. So if you had 3 different JDK versions, your job is going to say you're only running it on one kind of runner, say Linux. So it's 1 times 3, right? 3 different versions of the JDK. So that job is going to run 3 times on 3 different runners. So anyway, that keyword is java-version. You're specifying the Java version that you're wanting to install or use to set up your Java environment to build, test, and such. And then Java package. This is kind of cool. It defaults to JDK. Now you can specify JRE if you want to. Say you want to run, you just care about some performance metric and you just want to run it on a thin, you don't want the whole JDK just to run some simple test. And we also provide JavaFX bundled, the modules that are bundled with the JDK, because in Java 11 or Java 10, JavaFX was removed. So like in Java 8, JavaFX was actually part of the JDK. And so there's other options such as JRE plus FX. So yeah, so what are the benefits of V1? V1, because they partnered with us and our company, we've been around for a long time supporting since Java 6. So we actually have customers that use Java 6. It shouldn't be really, never mind. So the idea here, it's great. It's easy to use. V1 allows you to have all these combinations of packages with a lot of versions, even EA versions, early access releases, which is really great because sometimes you want to test the new features, you want to play around, but some of the vendors that we'll talk about in the next slide, which is the marketplace, will provide an easy template and it'll put in there V3. The GitHub Actions for Setup Java is now up to V3, and V2 actually was similar to V3. It didn't have these other vendors. I believe the first vendors in V2 were Adoptium's Adopt OpenJDK, and then they changed over to the Eclipse Foundation, which is now Xamarin. And Microsoft also has created a build, and Corretto has, their build, which is Amazon's build, and Liberica, which is Bellsoft. And so these are the available options for V3 for these vendors. So the other the third keyword would be distribution. That's a keyword, and when you, so here's an example of the supported vendors of the JDK. Now, you got to be careful because just because V1, like Zulu, supported since Java 6 and all the way up to even EA releases, Tamarin doesn't. Not that that's a great thing. I mean, what's good about Tamarin is that they do support all the LTS releases, and all of these builds, you know, from Zulu to Liberica, they're all TCK tested, which is great. I mean, they're all fine. It just depends on what you want, because even some of these vendors, they're mainly focused on cloud, so you may not want, they may not have like JavaFX packaged modules with the JDK if you're doing a build for that type of project. So one other nice keyword is called cache. Because Setup Java provides Maven and provides Gradle for you, there's this concept of caching dependencies. In Maven, it's your locals .m2 dependencies, and it pulls them down from Maven Central, and it has gobs and gobs of jars and their versions. But it would be nice if you could, if your project or job requires Maven, you would put Maven there. And in this case, it's Gradle. And it makes your builds and tests very fast between runners. So it's kind of like centralized cache of jars. So here are the distributions that you can select and add in your GitHub action for V3. And so this is what it typically looks like. You can watch the job run. In the name part of the step, I can actually use the substitution, the $ curly brace, and you can see it on the left when the job is being run successfully. It says build on test app on Zulu, and I'm using that matrix lookup that's user defined, and that's where every time it runs a job, it can nicely display, you know, what distribution, what JDK version, on what operating system. It's kind of nice. So when you're watching the workflow actually process. So here's a really great GitHub action called, this is a setup Java in the marketplace. It's called fujio/setup Java at Disco. My colleague, he's sitting right there. He created this incredible API. It's called Discovery API or Disco API. And this GitHub action is actually using his API, and this API allows you to download any JDK distribution from anywhere. So you can even get the proprietary ones from the company that's red. And you can get ours if you want, our commercial version, which is called Zulu Prime. But our community edition, which is called Zulu, you could specify that, or IBM Semaru, which is another anagram for runtime. It's just like Tamarin. It's another anagram for runtime. I didn't know if anybody knew. And Alibaba has Dragonwell, and so I mean, it's even more than that. So again, you see the keyword with or uses that GitHub action, Java version, and then you have the matrix lookup. So you can, and these are there's probably more than this, but this is like a huge list. So there you have it. So the last GitHub action that I want to show is it's great in my opinion if you are a person who likes to adopt things that are new, like very cutting edge stuff within Java. So like recently released in general availability or GA is Java 19. I'm sure most folks have heard. Project Panama is in preview release. It's JEP 4.24, and I believe Project Loom is also in preview. I think so, for virtual threads. Project Valhalla is still ongoing and such, but anyhow, if you wanted to play around with these new APIs, or you want to provide, be on the mailing list and actually contribute or fix bugs and help the open source community, you can use this GitHub action, which will allow you to pull down the early access builds or the development branch at jdk.net. So, and this is a little bit different from Setup Java, but it's quite similar. The only thing difference is you'll see the ID, that's a keyword, and it says download-jdk. And if you go to the GitHub project of Oracle Actions, they'll provide the additional options that you can actually choose from, because at the moment, I mean, it's still, this is very new, but the width is the same as Setup Java, and then you have a website. I think you can change that out, but currently it only points to jdk.java.net. That's where all the latest development branches are located. And sometimes if you go there, you'll see the builds already built for you if you just want to download them. So anyhow, and then release, that of course the matrix.release or java-release, that's user defined, but that release is a keyword. And so here's an example of how to pull down those projects that I mentioned. So here at the time when I wrote this slide, 19 was EA, and that, when you just say 19, you don't have to say EA, but 19 is that development branch, the OpenJDK. So now you can actually put 20 in there, and you're getting the latest and greatest from GitHub. And if you wanted to play around with Loom or suggest any new things, you're pulling down the latest right there. So you type in Loom and you're getting it. You probably can't get this to work with Gradle or Maven or whatever because it's so cutting edge. You may want to run simple unit tests, just Java-C and compile it and such. So here's another, this is pretty much it. I just wanted to show about the Disco action. So if you're really, particular on what kind of JDK you want, here's just a laundry list of a build that I wrote. It's like pretty exhaustive. It's pretty cool. So we're coming to an end. I just wanted to let you know that, if you do builds the old way, you're probably going to be hating life. And if you do it the new way, you'll be a happy camper. And using the new GitHub Actions, especially Java projects, it'll just make your life so much easier. You don't have to deal with a lot of build tools and such. So there you have it, GitHub Actions. Any questions? No questions? Oh. I'm sorry. Oh, I'm sorry, I can't hear you. I'm sorry, can you use, it's similar to JFrog, but are you saying that, can you mix them? Can you? Oh, yes, you can. There's a, in GitHub Actions workflow, there's two ways. One way, there's an attribute that allows you to go and fetch the download that you want. It's like internal in your company or whatever, that particular build. There's another way where you can output it like I have to I have to tell you offline because I have to look it up. But the idea is that there's a way to interact with the GitHub workflow. So like if you build an artifact, you don't know what the artifact is. Like for instance, the Oracle action, right? Say I want to run a test, but I haven't, because it's the latest and greatest, I'm actually checking out the code from Loom. And until the output is actually created, the artifact is the JDK. And then you may want to use that as part of another process. So you can, it's not that hard, but you can. That's a little advanced, but you can. But if you're talking about integrating it or mixing it within JFrog, I'm not really sure. Not really sure. Well, I think that was an issue before. Even now, I think I still haven't done it. I haven't really done that where you use a newer version, like an EA version of a JDK. Gradle doesn't support that. So, yeah, I'm not sure how I can answer that, but you may want to talk to someone from Gradle. I'm sorry, I really can't hear. I'm sorry, I really can't hear. There's a weird sound. I'm sorry. Oh, the YAML files? Yeah, that's better. I would love that. I think I'm also out.
Okay. So the question is, okay. So we have all the configuration inside the project, right, to build using Git action, correct? Can we move out from the project and keep in separate project or repository?
Good question. So the idea is that you want to separate the workflow, like have it outside, like you want to build it outside. I don't think you can, not that I know of. Like for instance, if you're in GitLab, like GitLab's infrastructure, it's called GitLab CI. Right? That's a different YAML specification, so that workflow is different. So it only works in the GitLab environment, and this GitHub action only works in their infrastructure environment. So you couldn't run it in your in-house. You have to use their runners. Same one, but different project. He needs the mic again. I just hope we're not running out of time. Super sorry, can't really hear.
the thing is that we have the project, right? And in project we have the source code, all the thing.
Yep.
And we have the Gradle, basically GitHub action configuration, YAML file to build the application, right? I just want that to be outside.
You want what?
The configuration to build the application, it should be outside of the project, the code.
Yeah, I mean, it only works, that configuration only
Inside
works.
the
Oh,
project.
you want configuration information outside of the YAML?
Keeping outside the whole configuration to build the application. So Git action is using the YAML file to build the application, correct? When we commit any code, correct? And that configuration is in the same project.
I think I know what you're saying. There's something that I didn't mention within GitHub Action Workflows. There's something called secrets. And those, like say tokens or passwords, you can store them on GitHub and you reference them in the workflow, and it can actually, the configuration can pull those in without exposing the passwords, if that's what you mean. Does that help? Maybe?
Or probably I will talk after
Yeah,
this one.
yeah, maybe
Thank
it's
you.
better we talk offline. We're done? Great. Well, thank you for having me. I hope you enjoyed it.
if you can stand in between those two dots. That one
Mm-hmm.
and this one over here. So if you go, yeah.
Back and
just
forth.
in between, in between.
Oh, okay. Oh, now I understand you. Okay. Okay, can you hear me? Okay, sounds good. I think we're good to start. Welcome everyone. Thank you for attending my talk. This is Security Microservices with MicroProfile and Okta in under 40 minutes, hopefully, if everything goes okay. So let's start with introductions. My name is Fabio Turizo. I am Service Manager at Payara. We are a small company on the UK. We'll talk about us in a bit. I am from Colombia. I had difficulties traveling due to the tropical storm. So it was a fun anecdote that I think many people share over the weekend. And you can find me on Twitter, I'm Fab Turizo. I don't tweet that much. I follow a lot of people and a lot of technology, so be my guest if you want to follow me. So Payara is basically, we are a company that we developed a product that is the evolution of Glassfish, which has been the standard reference implementation of Jakarta EE, which was formerly known as Java Enterprise Edition. We are part of the Eclipse Foundation. We are a solutions member because we support both Jakarta EE as a technology, as a working group partner, and we contribute to the specifications, and we also co-develop in other specifications for the MicroProfile, Eclipse MicroProfile implementations as well, which I'm going to talk about in a bit. We are also part of the committee member of Jakarta EE, the Enterprise Edition for Java projects, or E4J, which is the governing body of the entire thing. So our start product is Payara Platform Enterprise, which is just a commercial supported version of Payara Server and Payara Platform itself, which is just middleware. For any company that has Java developers, that they are willing to invest in Jakarta EE as a technology, and that they are offering services in multiple industries like finance, e-commerce, etc. Our two, let's say, best representations of the technology is Payara Server Enterprise, which is, the traditional application server that you can install in whatever environment you want to use. It also has Docker compatibility for, modern cloud developments. And we also have Payara Micro Enterprise, which is a jar that you can launch from the command line, much developer friendly, much cloud native friendly. You can use it in many environments because we also support Docker, Kubernetes, and other infrastructures as well. So, but again, we are an open source company, and the point of open source is not just simply charging everyone money and see how everything goes, but the intention is to encourage the community to come to our site, to see our products, to believe that whatever we are doing is actually helping each other grow. And the intention is that we have a community offering that is built on focusing, let's say, that aspect of developing and innovating applications, because the point is not to get stuck in the past. Things have changed over Java, and I'm sure that you will hear it from Venkat on his talk at the end of the day. But the intention is that Java has changed a lot, and Java Enterprise and its ecosystem has changed a lot, and the intention is not to get stuck on closed source software that people are reluctant to use, but rather just simply see what's open, see how's the code, and see how people contribute to it. And if businesses grow, companies grow, invest on it. Give us money, we'll keep each other back, and the idea is to see where we go. So now on to the talk. The self-promotion part is over, so you can now rest. Security is hard. And I'm going to ask this question just to check, but how many of you are responsible for maintaining a database of user identities on your businesses or on your corporations? None? Just one? Okay. I see one, I see two. Security is hard, and I'm sure that the people who raise their hand have trouble sleeping at night sometimes because, yes, absolutely, managing or safely managing user identities is the main concern of this part of the role. Making sure that not only your database doesn't get compromised by bad actors in any way, but that you're also making sure that your users are effectively, let's say, and safely managing their identities, making sure that they're using same passwords, that the passwords that they're using are strong enough, that they're renovating those passwords, let's say, regularly. It's something that they're doing, and that is part of your job description, making sure that they are able to properly, let's say, adopt your practices in a sense, because you don't want to force users. If you try to force your users to follow your practices, they might get tired, and the usual, let's say, IT user, let's say, they are not adamant on following proper practices unless strictly necessary. Another concern is securing microservices with minimal risk, because whenever you develop microservices, remember that you're developing the smallest unit of possible work or the smallest component that your application will interact with. And this smallest component needs to have better security or the same level of security as other components in your application infrastructure. So it is extremely important that this redundancy of securing each microservice component is built in a strong manner. And performance impact is the other, let's say, aspect of this. So you have to make sure now that you're developing microservices, or if you are developing microservices, how do you properly manage the performance impact on high availability environments, making sure that if you have a distributed environment with multiple microservice clusters, all of these clusters are properly tending to high throughput, to high performance for securing or for securing requests, or making sure they're authenticating identities or authorizing identities. The solution to this is to rely on an identity platform solution. And again, I say solution in a sense because this is exactly the concept. It's not a silver bullet. There are, of course, some caveats with this. But the important thing is that all of these concepts that I described have already been implemented. You don't have to reinvent the wheel. You don't have to start implementing a user management solution, a password sanitization algorithm, or some, let's say, mechanisms to properly validate that your identities or your user identities haven't been hacked in any way. All of these, let's say, solutions I have already designed and have already thought about these problems, and they have solved for you. And there are many solutions on the marketing, but I've chosen these four, Auth0 and Okta, which are fairly known services on the web that you can just simply go to the page, sign up an account, a free account, start using the service, and see how you go. And if the intention is your business grow and you have a really big need for an identity solution, then just simply give them money and start having a proper enterprise support contract with them and seeing how that goes. However, that doesn't mean that you have to go with an established service. You can also use a solution on your own network or on your own infrastructure. And ForceRock and Keycloak are two really good solutions. Keycloak is open source. ForceRock is open core in a sense. But the intention is that you can just simply download those solutions, implement it in your infrastructure, and you don't have to depend on a third-party service. Because again, and I say this with a big, let's say, maybe every now and then you can hear that even the biggest companies can get compromised. And that's something that will never change, even if you, let's say, trust your money and your data with a company. You don't have an absolute 100% guarantee that these guys really won't get compromised in any way. It's a gamble that you do. But again, it's a big gamble because these companies are already tailoring with these challenges every day. That's something that you don't have to start from scratch. So why I choose Okta? No, really, no strong reason. I actually have this talk with Auth0 as well. Auth0 was bought by Okta last year, so that talk kind of got redundant. They're two services that are still separate, but they're mainly part of the same thing and follow the same philosophy. And I also have a talk with Keycloak, so I kind of rotate these talks out. But I always like to talk about the services because it's always good to do some healthy promotion. So Okta is a stable service, it's supported, they have 24/7 support, so if you have any problems, you can call a phone line any time of the day if you're struggling with something. They are fully OpenID compatible, OpenID, which is the standard of the security measures that we're going to review in this talk. It has to be certified, and these guys already have covered that requirement. They have a multitude of features. I couldn't even summarize them, but between those are multi-factor authentication support, social login, self-registration, etc. It's very easy to use. As I will show you, it's just a simple dashboard that it doesn't require or has a huge learning curve. Anyone can start creating anyone can create an account and start managing their domains and tenants using Okta. Again, not a silver bullet. It can be that tomorrow Okta will get hacked, and this will make me look bad for even promoting the service at this talk. But the intention is that you don't have to rely on the service itself. You can just simply switch out. If your security solution gets compromised, nothing prevents you from grabbing that data, taking your data elsewhere, or maybe even implementing or designing or using one of the open source solutions on the market and bringing everything in-house. Because that's the good of it, that you have the options. Now, microservices usually relate on stateless communication. The idea is that every request should be idempotent. Whenever you execute a request, the data and the security context must always be provided within that request, and you always get a response. Either that request gets authenticated and authorized, and you get a valid response, or the authorization failed, and the user is not allowed to do something, or you couldn't verify the identity of that user, and you are trying to get a breach in any case, or the usual, a user got a password wrong or something similar to that. And the intention is that every security mechanism should do that validation separately for every request that you do. And that security context propagation must be done in one span, because again, microservices are multiple components that instead of the big monolith where a request is processed only once in an application, when you are designing microservices, they will communicate with each other. So the request will get passed over every component in the change. And every component in the change is responsible for validating that security context every part of the journey, in a sense. So a good solution to do this, because again, the intention is not to reinvent the wheel, is to use JSON Web Tokens, which is a standard technology. And the intention that JSON Web Tokens is nothing new. You probably have heard about that before. JSON Web Tokens are just simply a JSON Web Token is just a simple payload in JSON that contains three parts. Let's say an algorithm configuration, a signature, a cryptographic signature of the payload itself, and a body that contains the token, let's say, access information. Who is trying to access the information that you are validating, whether that user has an identity that is currently valid or it has expired, and what groups or roles that user belongs to, because the intention is not just to authenticate that user, but to make sure that that user is authorized to do what they are attempting to do. So this is not new. This is a standard based on an RFC 7519. I won't go into details because, again, it is fairly popular online and you can get any information about it anywhere. And the intention is that since it's a standard, it relies on a set of standard claims that anyone can just simply validate. You can code your application, making sure that if you receive a JSON Web Token, you are sure what you're getting. And JSON Web Token is supported on top of OpenID Connect, which is an interoperable authentication protocol. The idea is that OpenID Connect is just a big body of standards that explicitly state how an identity solution will interact with both applications and services that consume the data that they host in a secure manner, because the intention is that this is not a protocol designed just to, allow the applications to just simply exchange data, but to do that in a uniform and consistent way. It's ideal for microservices because, again, it's built on top of the HTTP protocol, on top of REST and JSON. So any modern application framework can interact with it in any way. It's built on top of OAuth 2, based on what Google created a long time ago, but now it has been completely standardized by the Cloud Native Foundation, and it's easy to use in message flows because the intention is that whenever you have an application that interacts with an OpenID Connect authentication authorization solution, you will interact with a base of flows. Either you get a read client flow where you are requesting client information in behalf of an application, or you are interacting with an API and you need to call and extract the data that an API is exposing in order to get the data that you need. So, we are talking about microprofile, and just to give you the quick summary, MicroProfile was initially conceived for microservices. The idea was to design a friendly developer stack that you could use in order to develop applications quickly, like what Spring does. But the idea was to do that in the Jakarta world, where originally in the beginning, when it was Java Enterprise Edition, it was super slow in order for you to start coding applications in the way that you intended. And then MicroProfile was born in order to fill that gap. But nowadays, with the advent of Jakarta and Jakarta being also owned by the Eclipse Foundation, it has diminished this role because MicroProfile is still heavily used and is still heavily oriented towards microservices and cloud-native applications. But the intention is that you will use it in tandem with Jakarta and other cloud-friendly technologies. So the main part of MicroProfile that we're interested in is MicroProfile JWT, which is a specification within MicroProfile that states how applications need to be coded in order to interact with an OpenID solution, in this case, Okta, which I will show you, and how to properly manage role-based access control. What is of interest is that MicroProfile states how a service needs to be coded in order for other applications to call that service, and how they need to extract the data of that service in order to validate if the user has access or has permissions to execute certain operations, which is just RBAC, role-based access control, whether a user belongs to a role or a group. And it's a three-parter, because the intention is you introspect the caller's identity. You see, oh, this user is the one that is executing the call. Then you validate it, but the one that does that validation is not the service itself, it's the identity provider. So in this case, Okta will tell you whether or not that user is actually who he says he is, or who they say they are. And then access to the resources are verified. So after validating that user identity, that user will have to then cross-reference its either permissions based on roles or groups or whatever you want to call them, and see, oh, this user belongs to the admin group. They can execute an admin operation, or they belong to a less permissive group. They can't execute an operation, and hence you will get a 403 for byte HTTP error code. And it has flexible claim validation. The idea is that not all identity providers follow OpenID Connect to the exact same, let's say, degree that you should do, because again, providers take their own flexibilities. Every provider is different. In particular, Microsoft is known to be a bit, let's say, stubborn in how they follow OpenID Connect, especially when you are interacting with applications that use Microsoft Active Directory or Active Directory Federation services. So MicroProfile JWT was created with that flexibility in mind as well. Now, in order to showcase all of this, there is a demo that I have created on GitHub. It's up to date. You can clone the project, run it self-contained way. Technically, it uses an Okta tenant that I created for myself, so you will be able to create users, but they will be restricted. But in a way, it lays the groundwork if you want to start testing yourself the technology, or even if you want to use another identity solution. So let's head to the code. And the code of this application is just a Java application using Maven. It is just a simple multi-component project. It has 3 components, 2 services, one which I call session service and another that I will call speaker service. And the details of these services are in here. Technically, it is a conference event management. So if you, for example, would like to organize a JConf Dev or a local Duke conference or not other conferences, even if they are not related to technology, then you could use this application in that way. It has 2 microservices, one that manages the speakers that will talk at the event, and another that will manage the sessions that are held at the event. And it has a 3rd component, which is a single page application written in JavaScript, standard web modern development, that will host and will use these microservices in order to expose everything as an interface to the end user. It has 3 roles: an admin that can literally do anything. They can create new sessions, view all sessions, delete sessions, view registered speakers, accept speakers into a conference. It has a speaker that can view all their fellow speakers and can register themselves as a speaker. And I know that it doesn't make any sense, but for the purposes of the demo, that's a feature that was created. pay no mind. And it also has attendees, which are people that just simply want to attend to conferences. They will just simply want to log into the application and say, I will attend to this event. That's it. They don't want the hustle of going through an intensive beta process of the application itself. So to showcase this, let's explore the code of the services. So remember, these services are implemented using MicroProfile, and this also use Jakarta E in the background. So for example, let's open the speaker service. Let me show you. Speaker service has a speaker resource, which is just an API endpoint written in JAX-RS, or Jakarta REST Services, which is the new name of the technology. And it just simply exposes an endpoint that allows you to get the data of a speaker based on a parameter, the ID of the speaker, get all data of all the speakers registered in the database, add a new speaker, accept a new speaker, and check the speakers. And you can see that embedded in the code, there are some annotations that are useful. The first one is the roles allowed annotation, which simply allows me to establish which roles are allowed to call this service. See that I haven't configured anything regarding my identity solution. I'm just simply saying which groups are allowed, or roles in this case, are allowed to call my service. And in this case, there are two of them, the admin and the speaker group, or roles. And one of the operations in particular, the ASEC speaker, is only available to admins. And overwriting the annotation definition, and in this case, oh, you're not seeing that. Sorry, have to. Okay. Now you should be seeing it, actually. Can you see well in the back? It's good? Okay, thank you. So back to where I was. So the speaker resource is the class that defines the API endpoint. It just simply, it's a Jakarta REST service endpoint. It has multiple methods for getting this data of a speaker, seeing the data of all speakers, adding a new one, accepting a speaker, and verifying that the speakers exist in the database. Really basic endpoint configuration. And in here, you can see that I'm using the roles allowed annotation to simply state which roles are allowed to call this code. In this case, the roles are admin and speaker. I am nowhere defining these roles other than on my identity provider solution, which will be Okta. And the only interesting thing that I have in here is that the accept speaker method is being overridden by saying, oh, only the admin role can call this operation. That's it, pretty standard solution. Other than that, this application uses persistence, Java persistence, or Jakarta persistence. It uses an embedded database whenever I start the microservice. The microservice itself is configured to be run using Payara Micro, which is just a simple jar. And in order to do this, I just simply have configured this Maven plugin, which just simply grabs a version of Payara that I want to run. I am going to run the latest version. And that's it. I configure a port, and that's it. It deploys the application, and it starts. So let me show it to you. We'll just simply say, let's run. And in here, in the background, we'll be running this using JDK 17, because it's nice to use the latest things. And, well, not exactly the latest, because Java 19 is the latest, but the latest on Java long-term release support. So in the meantime, the session service is exactly what you would expect. In here, you can see that the session service has an API endpoint, has two, one for registering attendees to the sessions and another for managing the sessions. And they are configured in the exact same way. The admin role is the one that is allowed to just simply manipulate the sessions as we define in the slides. But registering, you can see that it's allowed to attendees. So in this case, any user that is registering an attendee can call this endpoint, register. That means that they can register themselves for attending a session, because that's what we intended originally. So let's go to the session service, and let's start it. And let's go here, and you can see that my speaker service has started. When Payara Micro starts, it just simply gives me a nice overview of all the endpoints that I have developed for my application. They are in here. So now let's go and see what Okta is all about. So Okta It's an identity solution, as I said. You have to pay for it, but you can just simply create a free account. I think it has a limit of up to 100 test users that you can create, and of course it has API rates and limits per day of requests that you want to do, like any other service in the internet. And the interesting things that I have configured in here is that you can see that I have a directory of people. Oh, sorry, let me refresh. Oh, did I lose? Bear with me for a moment. Do we have internet in this room, right? Yeah? That's weird. Okay, let's do the backup. Yeah, a second. Sorry about that. Was connecting to my personal hotspot, so I wanted to hide that from you. Okay, so we're back on track. On Okta, you can see that I have a sample directory of users that I have created. Of course, I am created as the manager and the owner of the account, so I am also an administrator of the service. And I have created a sample administrator. You can see here that I have created a conference manager admin. If you go in the user's identity, you can see that under the groups of this user, I have admin, attendee, and there is a default group that Okta creates that's called everyone. You can change that. It's a default staple of the service. So it's always like that. And the intention is that Okta allows you to configure applications. On the sample tier or the free tier that you create, I think that it allows you only up to 3 applications. It's strictly limited, but again, this is just for testing purposes. But under the applications, you can see that I have configured a sample or a demo single-page application. And this is OpenID, connected staple. Every application that you are going to secure has an ID, a client ID that you have to supply to the application themselves or the application itself that will authenticate against the service. And now we are going outside the confines of Java, and I'm going to show you a bit of the application in JavaScript that I have created for this example. Oh, sorry, let me go up here. So this application is created Angular 13, if I recall correctly, pretty, self-code that the IDE helps you to do with, Angular toolset. And the intention is that I will show you in here the important part of the application is that whenever you are configuring Okta itself, Okta and many other identity solutions also have development kits on multiple platforms. Okta has one for Java, JavaScript. So the one that I'm using is the JavaScript Angular development module that they have. That means that I can just simply import the objects on the code here. You can see that I'm using an Okta out module and Okta out guard. And the intention is that whenever I import the module, I provide a configuration object in here, config.okta. And this configuration object, which is just a simple JSON object, you can see that it has the same ID of the client that I created on the application on the dashboard. And it has an issue, and this is the important part. This is where OpenID connects everything. Whenever you are authenticating applications using OpenID Connect, you have to understand that the services themselves have to verify who issued the tokens. The service or toolset that generated the token has to be verified in every request. And this issuer corresponds to an API endpoint on Okta itself that is mapped to the application in Java that I have created. And you can see that in here. I go to security, I go to API, and Okta creates a default endpoint. I don't care about that one. The one that I care about is the conference endpoint that I created for this demo. This has an audience. Technically, the audience is just a standardized endpoint that you use to identify uniquely that service that you are authenticating. And it will provide me a new issuer ID, a URL. And this URL is the one that I have to provide to my application in here. So you can see, oh, my issuer is the server that I will go and cross-reference the identity that I have requested. And afterwards, you have to provide a redirect URI. This is just simply a callback URI. This is a staple of OpenID Connect, where after a correct authentication, you will have to go back to. So look that I'm using localhost 4000, which is the standard port that we use for this Angular application that will be running. So let me do that. Let me start this up. And I will keep explaining. And I have to provide a set of scopes. This is another OpenID Connect requirement, a set of basic scopes that you have to provide for the application to obtain a set of claims. By definition, we always use the OpenID scope that will give me all the standard claims of a JSON Web Token, the profile that will give me personal information of the user, as in the first name, the second name, address, country, etc., if you have configured that information on the identity, and the email for the email address. These are standard OpenID Connect scopes. These are not something that I have created for the application. They already exist, and any OpenID Connect provider will have to provide you these scopes by default. You can create your custom scopes, but that's beyond the scope of this. And afterwards, then I just simply have to specify the exchange algorithm for the cryptographic key that will be used to cipher this token, and I'm using PKCE, and I'm just simply configuring this. That's it. That's the only thing that I have to do on my web application to connect this service to Okta. And you can see that, okay, I have 2 sessions. Actually, I do. Okay. Was wondering if you're seeing. Okay. So let me go to localhost. In here, you can see that the application has started. Whenever I log in, you can see that I'm getting redirected to a standard login interface that is provided by Okta. In this case, it maps with the tenant that I'm using. I can change that to use a hostname of my preference. And then I can provide a password. But in this case, I don't remember which identity I'm using. Let me see. 2020. Nope. Yep. Okay, can't remember which one was open. So in this case, we'll have to kill this. And I'll have to log out from here just to test this. Whoop. Okay, so back to this. Let me log in. Okay, so in this case, you can see that Okta also, this is a feature that they have. This is not a standardized feature, but they have self-registration. That means that the user can create a new account if they wish to. So if I click sign up, you can see that, okay, I can provide an email. I have turned email verification. So if you see me providing a dummy address and you see, oh, why is it not validating that? It's because I turned it down for the demo purposes. Don't fret. So we'll create a test fnd1 at payara.fish. Then it has standard basic password verification for, password stability and integrity. And that's ND. I'm going to register this. Then it will redirect me back to the application. Before that, again, by default, they will ask me some security questions. So let's say, well, no, Space Invaders. I know that's not a PC game, but technically qualifies. And I will select an image that I want to reference my account. And hopefully, there we go. It's calling back to my application. Now I have a profile. Everything was authenticated. And let me open the, look here, open the console tools in here. Where are they? What are they? Settings, developer tools, okay. Elements, network, here. So, okay. Whenever I request data from my services, let's see, for example, I want to see the information of the sessions. So you can see, I can see the sessions. What was called in the background? You can see that it's calling this endpoint, all, in this case, and it's passing a token in here. The token is passed in the authorization header as a bearer token, and this token that I have in here, let me see if I can copy it. You can just simply use the JWT page in order to decode the token, because technically it is signed. Anyone can decode it as long as they have the key. Let me paste it in here, and you can see that here is the payload that I got. It is token version 1. I have a user, in this case is the server on Okta that is generating the token. It has an audience. Remember, the audience is the service that I'm authenticating. It has an issue time, it has an expiration time. Once a token expires, you can no longer authenticate using that token. You have to renovate it, a set of basic scopes, an authorization time, the subject, which in this case is the identity of the user that you are validating, and a UPN. This is not a standard claim of OpenID Connect. This is something that was created for MicroProfile in order to correctly identify the user if in the case the standard subject claim is not enough. So it is seen as a complementary. In this case, the UPN is the internal Okta ID that is generated for the entity, and the groups that this user belongs to. In this case, everyone and attendee. And this token is passed over to the server, and the server validates that. But you will wonder, how are the services validating the token? I just only show you on the code how the services will authorize, but not how to authenticate. Well, that is done in a simple manner using system properties. So on the speaker service itself, I will show you both ways on how this is done. Give me a second. On the speaker service, oh no, it's on the session service actually. Okay. So on the session service, you can see that when I run in Payara Micro, I'm just simply passing over Java system properties. And I'm passing these system properties, MP, JWT, verify public key location, verify user, and verify audiences. And these are 3 standardized MicroProfile configuration properties that you have to point out. This one, the first, is the location that your identity solution provides for the public key that we'll use in order to verify the signature of the token. This is a standard one. It will basically be the name of your, or the host name or the URL of your Okta tenant, and then the ID of the application that is being authenticated, B1 keys. I think B2 is still not open. The issue, it's exactly the same configuration that I showed you on the JavaScript application configuration, and the audience is the server that we are authenticating to. And in this case, it's the API conference.payara.fish, exactly the same service. The speaker service, on the other hand, is not using system properties. It's using a standard file named, MicroProfile config properties. And this is just a Java properties file that it contains exactly the same configuration properties. If you wonder, well, how do I do that on a Docker container or on Kubernetes or on something that doesn't have access to these files? Well, you can use environment variables, Kubernetes secrets, or configuration directories, and whatever suits you. The standard is fully flexible with these configuration sources. Important thing is that the service itself doesn't do any authentication or authorization. You haven't seen any code that grabs the identity, that encrypts or decrypts a password, that validates, nothing. All of that is handled by the identity solution. The service itself is only concerned with verifying with the user, are these tokens valid? Okay, now that I know that, I will go and check if these users are authorized. And the service itself is only tasked with validating that authorization. Everything else is done for you because it has been outsourced in a sense. So back to the slides. Can I see the slides? Okay, cool. Very well done. Okay, so to finalize, in summary, Okta will allow you to delegate user management and authentication. None of that was done in the applications. The applications are just simply concerned with integrating everything. Simplify the authentication workflow in applications because the workflow itself is managed by the identity solution, and remove security complexity from microservices. Instead of worrying about whether or not you're properly securing passwords or properly sanitizing user identities or making sure that, are my identities or are the identities of my users properly stored in a way that I don't have to worry every night when I go to sleep about them? You don't do that. You are outsourcing all of that to an identity solution. Whether or not you pay for that identity solution or you maintain that solution yourself in another, let's say, infrastructure, that's up to you, but that's your decision. The service itself and its developers don't worry about it. They just simply focus on the business, and that's it. And MicroProfile, JSON Web Token will allow you to plug in an existing Okta domain via configuration properties, not to worry about token validation algorithms, and focus on setting all role constraints to existing services. The only thing that the service cares about, again, as I said, is just making sure that every user is properly constrained within the role of the operation that they want to call. Okay, so this is standard plug-up for Payara Global Meetup. If you want to know more, please go to our booth tomorrow. We're happy to touch about this with you. So any questions that you guys have? No? Okay. Thank you.
Hey everybody, my name is Lucas Beeler. I am a principal architect in the office of the CTO at Hazelcast. We're based in the San Francisco Bay Area. I wasn't originally supposed to give this talk. One of my colleagues was, but unfortunately he had a bit of a travel snafu. So I'm here with all of you guys today. I'm going to be discussing Hazelcast's Viridian cloud offering in the context of deploying and building efficient microservices in the cloud. But before I do that, just a quick question. Anyone who has used Hazelcast in their career, raise your hand. Okay, we have 2, 3, okay. Raise your hand if you've used any other in-memory data grid solution in your career. That would be Pivotal Gemfire, Apache Ignite, GridGain. Okay, got IMDG users. Okay, GridGain, Red Hat Infinispan. Any Infinispan users? Okay. So yeah, I will definitely need to retain the part of my talk where I explain sort of what an in-memory data grid is. So with that said, let's go ahead and get started. So the outline of my talk is sort of, we'll start out with Hazelcast and microservices and their long history together from the dawn of sort of service-oriented architecture around 2010 to 2012. Hazelcast was founded as an open source project in 2012 and only later became a commercial entity. As part of that, I'll describe the Hazelcast platform, which has evolved significantly over the 10 years of its existence. I'll then give some practical examples about how Hazelcast platform has enabled traditional microservices deployments. And sort of by traditional, I mean people who are using on-prem deployments or bare metal in large enterprises. I'll give a specific example from Capital One Bank. And then we'll talk a little bit about the features in Hazelcast and how those move to the cloud with Hazelcast Viridian. And also how you can sign up for a Viridian managed service account and hopefully tie it into your own applications and use Hazelcast to help you build more compelling microservice endpoints in a cloud environment. So with that said, let's go ahead and continue. So the Hazelcast platform began 10 years ago as an in-memory data grid. An in-memory data grid is a relatively common piece of enterprise middleware, but not one that a lot of people have heard of unless they work in certain areas like finance and IoT that require very low latencies. We're not the only one in existence. There's also Oracle Coherence. There's GridGain and its open source flavor, Apache Ignite. There's Red Hat's Infinispan. There's Pivotal's Gemfire. But we are, according to dbmetrics.com, the largest deployed in-memory data grid in the world. So an in-memory data grid is basically a fault-tolerant in-memory object store. It's basically a NoSQL database that keeps all of its data in RAM. It is, by necessity, a clustered solution. It would have to be, right? Because as we all know, memory is volatile, right? A server goes down, you would lose data, right? So the point that I'm trying to get at by saying it's by necessity a clustered solution is that in building this out as a data grid, we've already had to think about things like cluster member management, failure detection of cluster members via different mechanisms. You can use standard TCP timeouts, or if you want more aggressive failure detection, we have an ICMP failure detector, which obviously, doesn't require an open TCP connection, right? Because it runs on UDP. And at that point, you can get, your failure detection timeouts down to a handful of seconds. One of the other things that comes with having been a clustered solution from the beginning is the ability to do an elastic horizontal scale out. If you want to expand cluster capacity, you just add more nodes. The data is sitting hot and ready in memory, and it's very easy to rebalance data. And that is to say, to achieve an approximately uniform distribution of data throughout the cluster. There's a consistent hash algorithm that's used that's relatively complex, and it's an implementation detail, but all you need to know is that if you add another node, your data will be rebalanced in a relatively uniform way. And a lot of this just came out of the reality of dealing with memory as the primary storage medium instead of disk. But it becomes really important when we get into, I bring these points up just to say when we get into deploying in the cloud, when you look at a lot of solutions other than Hazelcast for doing similar stuff, they have a much bigger footprint as a clustered solution. So if you think about a product like Apache Spark, right, which came out of the Hadoop ecosystem, it has all of that Hadoop ecosystem stuff that goes along with it, right? So it uses Zookeeper for cluster management, right? It uses HDFS for intermediate storage. None of that's necessary in Hazelcast as we built our entire cluster fabric and clustering mechanisms from the ground up very early in the development of the product. It's not very hard once you understand an in-memory data grid to understand the beauty of in-memory data grids in a microservices world, right? I mean, microservices are inherently stateless, as we all know. So, you know, we are looking at a situation here where, you know, there's a request that comes in through a load balancer, and it happens to be routed to service instance 1. And the request says, it's an HTTP post request. It's got JSON payload in there, and it's HTTP request body, and it says, apply this transaction to this customer. Well, that's great, but where does the transaction and the customer, where do they actually live, right? I mean, by definition, these services here in this tier, your service tier is stateless, right? And that's the whole point of statelessness in the service tier is the load balancer can route the request anywhere. I mean, here in this example, right, we're routing to the other service instance. You can also elastically expand the number of service instances, right? But we all know this. This is sort of the core of microservices design principles. So you need an externalized state store. And you could use a relational database. These standard Java Spring Boot services, this is a Java conference, so I'm assuming we're using Spring Boot, not Nginx, say, to implement our microservices. We could have a JDBC connection coming off of, this guy, and it could go, and it could, there could be I'll try to draw one of the Oracle cylinders here. Sorry, I'm not an artist, so this is, that's a relational database. Point being that you could touch your customer and transaction state that way, right? And a lot of services are actually built this way. What are the problems that you immediately run into, right? One of them is scalability. Relational databases generally scale vertically. You want more capacity, you need a bigger machine. That doesn't work very well when the entire point of microservices is, as your load increases, expand the number of service instances you have. You can see if you were an online retailer, the difference in service call volume to your inventory processing services might be 100 times or 1,000 times higher on Black Friday compared to an average Tuesday in the middle of March, right? If you're talking several orders of magnitude difference, you want horizontal scale out to deal with that from a capacity standpoint. You can't do that, with a traditional relational database. You do have NoSQL databases that are horizontally scalable and are clustered solutions. Cassandra is a clustered solution. They're disk-based, however, right? So if you want low latency and data to be kept hot and ready in memory, which means it's not only easy to access and fast to access, by which I mean sub-millisecond access time, it's also very easy to put on the wire for the network to rebalance it, right? You don't have to read it into memory and then put it on the wire for the NIC. So the point that I'm getting at here is that in-memory data grids one of their chief use cases throughout their entire existence has been to operate as an externalized state store for microservices, a place to keep the customer and transaction objects, the actual business objects that your services are going to apply logic to. So think about any kind of service that we have, right? Whether you're making an HTTP post request to a RESTful microservice endpoint, whether you're making a gRPC call, or if you're in the cloud, which we're going to get to in just a few moments, you might even be having serverless functions, right? Like AWS Lambda. So the basic idea is you want to apply behavior or mutations to state, and that state has to live somewhere. And in-memory data grids have become, in very high-volume organizations, a standard piece of middleware to be backing state stores for rich ecosystems of microservice endpoints. So if you guys aren't using an in-memory data grid to externalize state for your service endpoints, I would highly recommend doing so. I'll talk a little bit about why I think Hazelcast is the best choice among IMDGs out there, because Hazelcast does a little more than just being an in-memory data grid. So with that said, I think we understand the basic idea of IMDGs and microservices. The last thing I wanted to say is that the IMDG solutions, including Hazelcast, all allow you to write through or write behind the mutations to these business objects to a system of record, and to have pluggable support for object relational mapping of various kinds, whether that's Hibernate or custom or whatever. We can see that this is, definitely a better way to do state storage for our microservices. If we want a bigger cluster, that's no problem. We can scale from 3 nodes to 7 nodes to whatever in a matter of seconds. One of the questions that I often get asked is, what's the difference between an in-memory data grid and a simple cache like Redis? The answer is that Redis is just that. It's a key value store. It has a queue and some other stuff as well, but that's pretty much it. And, unless you know the primary key of something, by which I mean the key value key, it's actually very difficult to get data out of something like Redis, or Memcached, or any of those products that are simple caches, right? In-memory data grids allow a number of very compelling features. You can execute code that's co-located with data, and you can have robust query APIs that support SQL. We support SQL queries by creating virtual tables, even though what you're going to store in the in-memory object store is an object. The fields of that object can be treated as virtual columns in a virtual table and indexed appropriately for, very rapid indexed queries. I will talk about, if I'll just switch to my web browser real quick here, and just share, if you just Google Capital One Hazelcast, this is one of our customers that has written significantly about their use of IMDGs. They had a great article in Medium as part of the Capital One Tech blog, the ABCs of building IMDGs with Hazelcast. And so they actually use Hazelcast for their fraud detection service endpoints. So think about the ability to query every credit card transaction that you've made in the last year, to compare that with a new transaction that's come in, to execute as part of asking, think of the service request response here from a microservice design standpoint. The service request is, I have a transaction, tell me if it's potentially fraudulent. The response is, this is a confidence score that we're 76% confident that this transaction is non-fraudulent. So they do all of this over a year of previous transactions to make sure that your current transaction is in the ballpark, and they use several stochastic ML algorithms to do it. But the point is that they have less than 100 milliseconds to do so in the event of a challenge response to credit card authorization when you do a swipe. So the point that I'm making is there is no other way other than in-memory solutions to get latency like that. And that's something that we take very seriously at Hazelcast as a core design principle, is ultra-low latency, high throughput, high performance solutions. So it's also something, by the way, that you could not implement with a simple cache, right? Because simple caches cannot execute code on top of the data in a co-located fashion, which is you could see as sort of like a stored procedure in a database. Nor can simple caches do robust queries that you would need to get a cross-sectional view of customer behavior. So that's where the Hazelcast platform began, and that Capital One blog was from 2019, which is now 3 years ago. So the Hazelcast platform today has evolved into a platform that combines two distinct elements. There is fast data management, or I would call a fast operational data store. This was the IMDG API. This was the original Hazelcast product in a nutshell. On top of the IMDG API, we added what has become known as the JET API. And the JET API is an API for expressing streaming computations. I'll actually show you some JET code in just a moment. It's a fluent declarative API. And you can think of the JET streaming compute engine as something analogous to Spark or Flink. It could be run on live continuous business events, or it can be run in batch mode. And the two APIs are within the same runtime, and they're coupled together. So if you're doing something like, let's say you're listening to a Kafka topic, and a new event comes in, so you've got a business event that's arrived, and it's basically a UUID for a network device. Let's say you're in an IoT type scenario where you're monitoring your routers and switches in your network, and a UUID for a network device comes in, and you want to fill that into an actual record that has semantically meaningful information about the device, like who manufactured it? Was it Cisco? Was it Broadcom? What model is it? What's its firmware revision? Because that can be a big issue if you need to patch firmware. So one of the notions that we have in the streaming engine is this notion of data combination, which is one of the forms of combination is enrichment, which is what I was just getting at, which is you can query the in-memory data grid layer during a stream computation, and you're doing so within the same cluster. So one of the things that you'll see in deployments of Spark and Flink when people are doing pretty serious heavy lifting and trying to do analytical failure prediction of, is this network switch about to fail? If people are using Spark or Flink, they often need some kind of external store in which to store state for enrichment, right? And in Hazelcast, that's all within the same runtime. And the runtime is just a Java application. It's like a 40 megabyte jar file, basically. And we do all of the other stuff that you would expect from a streaming API. I mean, your filter map, flat map, various forms of aggregations, rolling windows, that sort of thing. We also have a machine learning inference runner. And the purpose of this is when we talk to our customers, when we introduce the streaming API, we found that a lot of people wanted to implement ML in their organization. The most natural way to do it was as part of stream or batch jobs where you already were performing streaming analytics. But there was a disconnect, right, in the sense that most actual data engineering pipelines are built in Java, or in some cases C++ for very high performance. Whereas data scientists tend to work a lot in Python. This is a Java conference, obviously, but I am going to talk a little bit about our inference runner and how it bridges this divide between data scientists and data engineers. Obviously, the purpose of doing ML inference is just so that you have actionable context that can come out of this, right? I mean, if you see an IoT device that's about to fail, issue an alert, right? The one thing that I was going to say is that there's a very robust ecosystem around this product. Do I need to stop my show real quick here? So if you go, for instance, to hazelcast.com/hub, you might be interested in ways to kind of prime your streaming pipeline. So one of the things that you might want to do is change data capture from MySQL. So if I just do a search for MySQL CDC, oh wow, there it goes, the MySQL CDC connector. Let's say I want to connect to Kafka. Oh, I've got quite a few Kafka connectors, actually. Legacy JMS. Got a connector for that. ActiveMQ, we're good to go. And to step back a second, as nice as all of the streaming analytics stuff is and talking about machine learning, one of the other things that I admit as a developer is that, like, I don't do that much ML stuff on a regular basis. But one of the things I do a lot of is data transformation and moving data from one place to another and converting its format, basically ETL type operations. So when we talk about streaming compute, you don't necessarily just have to think about streaming analytics. I mean, that enrichment that I talked about earlier, where you go from a UUID to a record, that could be really valuable as part of an ETL process. So one of the things that has sort of come out of this fusing of an in-memory data grid, which also now supports the ability to spill over to SSDs, so you can have more data than you have available memory, with a stream processing engine, is this notion of a digital integration hub, right? So this is, you're taking data from a bunch of places, change data capture from databases, IoT devices, right? You're using the stream processing engine to move this data in to the operational data store that's not just in memory anymore, but we'll say it's memory first or memory centric, very low latency access. And you can a lot of customers kind of use this as what I would call a materialized view store, or what Gartner and Forrester call it in their reports is a digital integration hub. So, you basically want to mash up real-time data that's coming in with contextual master or reference data that's stored in the grid, right? These could be for 360-degree data views, customer 360 type stuff, right, where you have customer click streams and that sort of thing, and you want to combine that with historical data about customer behavior, and then try to determine whether they're going to abandon their shopping cart or not. That's all possible, and you can have applications that connect to this, and this digital integration hub once you have it. And one of the most powerful things you can do with the digital integration hub is stick it behind a microservice endpoint, which becomes a way of querying it, right? So Hazelcast handles the combination of data from Kafka, IoT devices via MQTT, change data capture events from traditional relational databases. So all of these business events are happening. You're capturing them and you're mixing them with sort of contextual or historical data, and in doing so, you're allowing your microservices to do a great deal more than they have in the past, and to see a much richer view of your data, and to make querying through service endpoints a richer experience for your consumers. So with that said, I don't want to go over here. So we'll move on past some of the boilerplate slides that I have. I think we covered the fact that the Hazelcast platform unifies data at rest via the IMDG API and data in motion via the streaming API. The streaming API gets a lot of discussion about doing ML execution, and the one thing that I did want to point out that we have figured out how to do in Hazelcast is to execute Python code in a massively parallel way. So Hazelcast itself runs as a JVM process. Knowing the constraint that you have with Python, that Python is basically a single-threaded language, right? It has this notion of a single interpreter lock. We can, for instance, spin up as many CPython VMs. These are not Jython, these are actual CPython VMs, as you have available CPU cores. And so if you've got a 2-core machine, you'll have 2 CPython VM instances. If you've got a 4-core machine, you'll have 4 CPython VM instances. I can actually show you an interesting example of this in my IDE here. So this is actually a common problem that happens to us Java developers. You get this, which is a bunch of Python code that a data scientist used, in this case, to develop a movie recommendation engine. It takes its input from input.txt and writes its output to recommendations.txt. So was fine, I said I liked Top Gun, but let's say I instead like Toy Story, right? I'm going to go ahead and execute this, and the most interesting thing that you'll see here is that this is a Java process, but you'll see all of this Python initialization code here, right? Do you see we're actually running pip, the Python package manager? When the Hazelcast cluster starts, it will actually load and create an entire Python virtual environment, and it will create as many instances as it needs to execute a Python ML model. It'll build wheels. How many of you guys are Python developers at all? Raise your hand. Yeah, so you're vaguely familiar with wheels as compiled artifacts, right? So yeah, this is going to take a second to run because we have to prepare the Python environment. Obviously, in a real-world scenario, you would not be waiting 1.5 minutes for this to happen because I would already have my Hazelcast cluster running. But what I'm actually doing here is creating a Hazelcast cluster locally on my laptop, and it's now uploading the Python resources that I need, including quite a bit of ML libraries. Like if you look at my Python imports here, I've got a lot of scikit-learn, stuff. So yeah, while that runs in the background, and we're going to spin up 10 CPython VMs because I have a 10-core machine, that's the ML execution part of Hazelcast. And if you're in a situation where you want to operationalize ML, one of the simplest things that you can do is, let's imagine that we're working for, big old streaming service, or BOSS, B-O-S-S, and someone wants to watch something on their tablet device, and they've said that they like Toy Story. The kind of cool thing is you can abstract that entire process behind a typical Spring Boot endpoint. I mean, you make a REST call, the HTTP request body is Toy Story, the Hazelcast JVM will execute that Python in a massively parallel way. You get your results back. And one thing that I would point out is that we have a series of benchmarks comparing us to other streaming products, including Spark and Flink, and we were able to do a billion transactions per second with our 99th percentile latency under 30 milliseconds. That said, this did require 45 nodes, which is a pretty big cluster. Let's go back and check out our recommendations. Did it populate them? Yes, it did. So here you see the IMDb movie ID, the movie title, and here you see the confidence score. And what we've gotten is Aladdin is, of course, another Disney movie, as is Balto, as is Hercules. 101 Dalmatians makes sense, the classic kids film. So yeah, the recommendation engine worked vis-a-vis Toy Story. So there we go. And that was Python code being completely managed from inside of a JVM. That said, we've only got a few minutes left, so let's do the cloud, right? You like Hazelcast, you like what you've seen, you like stream processing, you like Python execution, you want to just take your Python code, use our jar packaging tool, upload it into the cloud. You want to use the Hazelcast in-memory data store to externalize state in your microservices. We do cloud native very well, right? We don't require, being that we were built from the ground up with our own sort of clustering engine built in and for failure detection and all of that, as I mentioned earlier, we don't require all of this complex stuff that something like Spark does, where you have master nodes and worker nodes. And then you have Zookeeper to keep track of what kind of nodes you have. And then you have HDFS for intermediate storage. I mean, if you've ever deployed Spark or like a Cloudera solution, there's a lot to deploy. So because of our simplicity, it was very easy for us to build a fully managed cloud solution called Hazelcast Viridian. The fully managed cloud solution is multi-availability zone. So you lose one AZ, you don't lose your data. You can do even multi-region via our WAN replication solution. One of the cool things is we support multi-cloud. We're available on all three major cloud platforms, AWS, Azure, and GCP. And we can do replication between them. So if you don't want to get locked in to a particular cloud provider, it's a very powerful idea. We can also use our WAN replication feature to replicate from on-prem into the cloud. Viridian is fully managed, it's easy to use, it's highly scalable, it's Hazelcast just running on top of Kubernetes plus Docker, and given what you've seen about how easy clustering is in Hazelcast, I'm sure that you can see that this is a marriage made in heaven. We're SOC 2 and ISO 27001 certified, so if those certifications are important, because we'll be holding your data potentially, that's all available. The sort of technical use cases for this, I probably don't even need to spend that much time on it. Here is externalized state store for microservices. Here is externalized state store for serverless tasks, where you have, a function as a service, be that, AWS Lambda or something like that, and you need to manage state. Auto scaling. One of the coolest features of the product is that given the fact that it runs on Kubernetes, you can grow and shrink the cluster based on a number of monitored cluster metrics. Auto scaling is triggered when various min-max values are exceeded. These can be heap memory usage, off-heap memory usage, CPU use, number of clients, etc., garbage collection pause statistics. You can also manually scale with a single click when desired. You want to go ahead and give it a shot. It's pretty straightforward. Let's go to hazelcast.com and say that I want to start coding now in Hazelcast Viridian Serverless and sign in with my Google account and Yeah, you can see I have a serverless cluster here deployed in AWS US West region. You know, the other thing that I'll say is that the documentation is actually great. So if you want to click on the Learn, you can see things like building cluster-side modules, how multi-factor authentication works, how you connect remotely to Hazelcast clusters, potentially from function as a service endpoint. So I've gone over time, I believe, by about 5 minutes. So my apologies, but that's pretty much all I got. I'll take questions if anyone has one. Go ahead, please. Yeah. Yes. Yeah, it's, I mean, you can actually achieve ACID level consistency provided you use the Transactions API. And we also have a CP subsystem that uses the Raft consensus algorithm. So yeah, the level of consistency you can achieve is extremely high, even though it is an in-memory system. But it's fungible. You can trade off consistency if you want higher performance. Any other questions? Well, I mean, you can turn persistence on, for one, which means, and you can use fsync level persistence, which means that everything that's in memory is going to be mirrored to disk, right? That'll save you in the event of a power failure. But that's not going to help you if your cloud provider's region is down for a while, which is why we would recommend using multiple regions with one cluster in each region, and then enabling our WAN replication feature, which is an eventually consistent batching replication feature that's designed for slower WAN links between regions, and that's going to give you, a robustness even if, you need to switch to a completely different region or a completely different data center if you're in an on-prem scenario. Yep. Okay. Thank you, guys. And come by the Hazelcast booth if you want to learn more.
That one is Pocket Paste.
This one's the little guy.
Is that the like this?
Yeah.
Let's do like that.
Okay.
Yeah. Choose. Ha. 1, 2, 3. Yeah. That's all. Yeah. Good. 3 minutes then. It could be.
Try this.
Yeah, yeah, yeah. I think it's working too.
Renegotiate. Okay, now you have presenter there.
Okay.
Might have extended.
Let's kill that. Okay, so that's better. Cool. Okay. It's nice not to have bright lights in my eyes. Java Zone. So the Java Zone conference. For audience is in the seats around an ice rink, right? So it's like that. So the first person is got on my eye level, and then they go up. You know, and it's like you know, like an old theatre where it's really, really steep. So it's like that, and bright lights, so you can't see the audience. So I'm talking into the dark. So it's nice to see faces. Cool. Wow. Look at this, 4:30. And some people are still awake. Well done. Okay. So this talk is, well, there's lots of words, you know, log4j, shell thing, blah, blah. I'm going to take you through a little bit about log4j because it's a exciting example of how not to do things. But mostly I'm going to take you through a bunch of other stuff to do with security and bad guys, and then a whole bunch of things about what we could do. So there's some consequences coming down the pipe that as developers you should be aware of, and I'm going to cover those and try and bring it all together. So hopefully you can walk away here feeling a little bit more informed and also understanding more about what your responsibilities are in what's going to be the new world of software development. Right, so this is me, and if you were here this morning, it hasn't changed. I used to do Java. I used to do JVMs. I was an engineer did lots of that, worked on all sorts of open source projects, and even ran a DevOps team. I used to run a European DevOps team for IBM in the UK. It sounds a bit weird, but that's what we did. And so I've been a developer, DevOps person, etc. When I was a developer, I really didn't pay much attention to security, because we don't, do we? The security is somebody else's problem, right? But when I took over a DevOps team, suddenly security became almost the most important thing. Sometimes it was more than the most important thing. It was the most critical, urgent thing, okay? So I want to talk to you about how you as a developer need to think about how you do development at a very high level, and hopefully get to change your mind. Sorry, I've got this twice. To talk about why you as a developer need to think differently about how you behave. Right? So let's start with the bad guys. Let's talk about why it is that I'm here talking to you and why you should pay attention. There's lots of conceptions that bad guys sit in bedrooms and hack FBI and Uber and whatever, right? And they do it for fun, though not necessarily for your fun, they do it for their fun, right? It's not like that at all. Let's talk numbers. 2016, 6 years ago, was sort of about when I started talking about cybersecurity and cybercrime. And that's a point where the value of cybercrime became more than the value of the illicit drug trade, i.e. the bad guys made more money out of cyber attacks than they were making out of selling, moving illicit drugs, okay? $450 billion a year, okay? Or $14,000 a second, or the same as buying 50 Nimitz-class aircraft carriers, right? That's how much they were making in 2016. So now, 2020, let's roll forward. What are the numbers? Okay, I'm glad you're all sitting down. Let's go through the numbers. They now make $6 trillion a year. That's the same as $200,000 a second, or more amazingly, the same as 620 Nimitz-class carriers. Okay, that's an enormous amount of money. And if you want to make it even more scary, here's a list of countries by their GDP, how much money they bring in. And if cybercrime was a country, well, look, it would be the third biggest country in terms of GDP. Just think about that, right? That is the driver, and it's going to get worse. $6 trillion. You just can't imagine that amount of money, can you? And of course, one of the reasons this is growing is because it's easy, right? Because as human beings, for some reason, we think that if the threat is further away, it's less risky. And in physical terms, that's true. You're sitting here, and a bad thing is happening on the side of the country. You're not at risk because it's over there. And we apply that to the internet for some weird reason. So we think that if the bad guys are in some faraway country, that the risk is less. But of course, that's not true, is it? Right? There's no distance in the internet. The bad guys live next door, effectively. And the only thing between them and you is software. The stuff they're hacking. That's all that keeps you safe, is software. Right? So let's talk about software. This is where the Log4Shell comes in. Who's heard of Log4Shell? Okay. Sorry. Okay. Right. I'm just trying. Are there people here who have not heard of Log4Shell? Or Log? Okay. Cool. Okay. But we're going to go through it anyway. Right. So, 9th of December last year, I'm talking to a colleague of mine who is a cyber journalist. He reports on all these issues, and I'm going, all you ever give me is Python ones and Node ones, and have you got something juicy in the Java space? And he's going, no, we'll never get one of those. Next day, Log4j turns up. Suddenly we have this Log4j problem, and it gets more and more press. It ends up on TV because it's becoming, we're seeing how bad it is. Right? It gets reports from government organizations saying this is really bad. Even the White House perks up and says, this is really, really bad. We need to do something about this. Because ultimately, we think actually it turns out that maybe the Log4j, Log4Shell vulnerability is the worst one we know ever. The worst being easiest to exploit, and the ability to give the bad guys the things that they really want to do, which is full access, the ability to run arbitrary code on your systems. Right? That's like the big score. Right? And even worse, this thing had been around for a long time. 2014, the particular challenge, the code changes that made it that dangerous were made. The reason I put this here is because this is a great example of how developers behave, and also, more importantly, just also how vulnerabilities evolve, and we're going to talk about those in more details. Right? Right. So it's been around since 2014. Let's talk a bit about the details, because it's important to understand with all vulnerabilities that vulnerabilities aren't smoking guns. There's not a big thing that says, there's no comments that says, this is a really bad thing, we mustn't do this, but we do it anyway. It's always a combination of things. So Log4j, everybody uses Logger. You have some logging entries in your code, and then you create a logger, and then you have, in the lines at the bottom, you log stuff. Whatever it is you need to log, and that turns up in the log. That's what it's for, isn't it? You have logging instructions to put data into the log. And because logging is for diagnostic purposes, we want to make sure that whatever data we're going to log is as unchanged as possible. We get data in from somewhere, we want to record it because it's going to tell us when we're diagnosing the problem which way our code went. Right? So it has to be as is. Right? The other thing that Log4j gives us is some help. Because when you're writing logging, you might need to know things like what version of Java am I running on, or what platform am I running on, because your application may be something that other people are using. And so for diagnostic purposes, you might want to know what version of Java you're running on. So rather than have to do system.getProperties, Log4j says, no, I've got these special versions, the $sys, and that lets you short circuit it. You don't have to do the heavy lifting. You just put those in the logger in the format, and it just happens. It gets interpreted, you get data, right? Which is why you get the line at the bottom. These things are called lookups, and there are a lot of them, because over time, Log4j has been extended to include not just asking for system properties, but also environmental properties, maybe asking for how Log4j is configured, and a whole bunch of others. So Log4j is a very powerful system, and it's grown like that. And we've got more to say as well, because in 2014, JNDI lookup got added for a very reasonable reason. If you're reporting config information, and you have a tool that will do it easily for you, so system properties, environmental variables, well, it turns out there are config information that gets stored in JNDI databases, and people wanted to record those in a nice, easy manner. Nothing wrong with that. Maybe a bit of an overkill, but it was in the spirit of Log4j. But when that happened, nobody realized that with dragging in JNDI, you also pulled in those other things that JNDI can deal with, like LDAP and RMI and DNS, right? And if you've paid any attention to Log4j, you know it's the JNDI LDAP type thing that was the Achilles heel that broke everything. And we're not finished there. There's one more thing about Log4j that made it a godsend to the bad guys. And that is that these lookup values are recursive. So Log4j will take one, whatever it may be, and expand it by asking the lookup to do its stuff, and you get some data back. And if the result contains a valid lookup, it'll do it again and again and again, right? Okay, so that all these things combined meant that Log4j became this enormous weapon, right? It let you run arbitrary code, and you know that all it took was somebody to force your system to log something that was in the right format, and then they could exploit all these capabilities. They could do JNDI calls, they could extract data from your systems, right? So loads of stuff you could do. That's another talk, right? So if you take all that capability, way more than was ever envisaged when we tried to do logging, all these extras, and the fact that you want to write this stuff as is, so you're predisposed to take data in and record it, well, you take all that, you add the bad guys, and then within 4 days of all this, the world is being probed for Log4j vulnerabilities, right? And all sorts of clever ways of making use of this were created and expanded, and it was an exciting time, wasn't it? Many of us thought that they were going to spend Christmas, with their families, and many of them found themselves trying to figure out how they could find out whether they had Log4j in their system. Because another reason for me putting this up is that what this exposed to us all was that actually we're not very good at this, and that developers assume that somebody knows what they're doing in terms of managing this stuff, and that there's some IT folk that manage all this stuff for you, and that it's not a problem. And it turns out that IT guys use tools that do things, but they don't understand whether those tools are good enough, because they don't understand how Java works and where Log4j could be hidden. It might not be in a dependency, it might be a fat jar, it might be pulled out. The bad classes may have been taken out and put somewhere else. So this exposed to us the fact that developers, us, have a vision that somebody else is fixing a problem, and those people may or may not think they're fixing it, but they don't actually understand what they're asking of the vendors they're getting tools from, right? And we know this is the case because if you go to sonatype.com, there's a tab you can go find which will tell you the latest status of Log4j downloads. So here we are, almost a year later, 33% of the downloads of a Log4j version from Maven Central is of a bad version, one with this vulnerability in. We as developers are culpable for this for multiple reasons, and I'll go through some of them, right? But we make assumptions that somebody else is protecting us, and those people are relying on tools that they are not making sure do the right thing, because a lot of them just want a tick, right? But actually they trust that the vendors they're getting these tools from know what they're doing, and sometimes they don't. And the net is that still 33% of downloads of Log4j a year later are still vulnerable versions. It's really scary, don't you think? Right, let's move on. Part 3, new bad guys. So, okay, so loads of money being made, developers not really paying attention, the tools we use not necessarily being the best they could do. Can it get any worse? Oh, yeah. So there are still all these things going on. There are still all these botnets trying to get into your system. There's still people trying to steal your data. There's still people trying to hold your data to ransom. There are still people trying to steal your CPU to do Bitcoin mining. All that's still going on. Now there's a lot more. Now there are people trying to get into the open source projects of the dependencies that you're using. Now there are people trying to create fake versions of packages. If you're in the Python space or the Node space, it's a traumatic time to be because it's very easy to get fake packages installed. In the Maven space, the Java space, it's harder because you have rules in terms of putting stuff on Maven Central. But effectively, the idea is every time they can figure out, for instance, that you have some internal package, they can get the name for that, and they can get it on the public repo, then the download process tends to be that you go to public first. And suddenly people are pulling down, you're not pulling down the version that you thought you were pulling down, you're pulling down a fake version. And you know about, sometimes you might type the name wrong. And if you type the name wrong, you would expect there to be a failure because that package doesn't exist. Bad guys like creating packages that have the same typo in it, and you'll hit that instead. You won't realize that you made a typo. You've now got bad code coming into your system, right? This is what's going on. And the reason this is going on is because of this wonderful new word, well, not new, cyber warfare. We had a bunch of people who were trying to get into your systems for the money. Now you have a bunch of people trying to get into your systems because of other reasons. And we'll talk about those in a second. So they're motivated differently. They like the money, mind you. They still want the money from you. They are much more professional. Right? Well, generally more professional, definitely well funded because they're funded by nation states to do this. Right? And because of what they're trying to achieve, which we'll go in that second, they are very different in their approach to attack you. They're not drive-by. They're not going after you because you left the window open and you're more vulnerable than somebody else. They're going after your systems for very, very specific reasons. Okay? And everyone is at risk. And I mean, individuals, you can be at risk because you know something about some system, and everyone, state, political body, you name, is getting into this act. You can begin to see why, and we'll talk more in detail about why, but basically everybody is waking up to the fact that they can use cybercrime techniques to attack people's systems. Okay? And they want all this stuff from you. I can't express enough just how scary this is, because Log4j has shown you that we tend to over-engineer things without thinking about security implications. The tooling we use is not good enough to detect a lot of the usage of these vulnerable systems. And now we have people who are going to the next level of trying to exploit all that, not just for money, but for other purposes. Right? And it's all through this thing called a supply chain. You will hear the term software supply chain more and more as time goes on, because it is about relationships between software. Right? And we're all part of software supply chains. Right? Well, look, here's the slide. If you think about it as a supply chain, it's taking things in, giving things out. So you consume code, you give out binaries, you might just bring in dependencies. You're consuming somebody else. You may publish binaries. You may be part of an open source project. Right? You may be calling APIs. You may be using particular toolers. They're all part of your supply chain because you use a compiler. Where does the compiler come from? It comes from somebody else. Where does the operating system? It comes from somebody else. You're often at the end of a supply chain for software, but often you're also in the middle of it because you're giving software out. And what the bad guys want to do in this instance is getting to your systems, right? They want to get into your supply systems, whether you run a hotel, whether you're a bank, whether you do, I don't know, whether you do video services, whatever you do. Software none of us are here in this room without software, right? We all use software to get here. One way or the other, you use software to get here. And the fact is, we're using software now for me to communicate. So you imagine the value of being able to get into somebody's software supply chain and disrupt it. So obvious things like heating, gas, transport, pharmaceuticals, supermarkets, train stations, you name it. The aim is get in there and then manipulate or terminate. Sometimes they're doing this for long-term purposes, because at some time in the future, it may be that we want to terminate your ability to deliver ammunition. Or more likely, and this is what's more likely and is sort of beginning to be realized now, is it doesn't have to happen in wartime. It can happen now, because I can affect your economy. What happens if I get into your system and I switch the addresses of a delivery? Tiny thing, but it causes difficulties. It causes complaints. You know, what happens if I manage to stop all the milk being delivered to a supermarket for one day? You know, you see, these small things can be made to impact your economy. And there you can see why suddenly everybody's waking up to the fact that this is all real and has enormous potential, right? Weaponized cybercrime, cyber warfare is the new reality. It is emerging now, and it's been quietly building, but now we're beginning to see that it's suddenly surging. Sonatype keeps track of supply chains because it's our business, and recently we can work out the different types of attack, and you can see that last year the number of what would be considered to be supply chain attacks went up by 650%. No spoilers to tell you that this year you're going to see similar numbers, because it is such an important activity. And it means, who's heard of zero-day windows? Anybody heard of zero-day windows as far as CVEs are concerned? Okay. How long does it take you from, how long do you have from a vulnerability being reported to you fixing it? How long is the window before the bad guys will come probing you? Well, way back it used to be, you can see 2006 used to be 45 days. Right? Log4Shell showed us that basically there is no zero-day window. You have no time. When a vulnerability is reported, it's already been exploited. And worse than that, we now know that the people who are finding the exploits, the bug hunters, are in some instances being paid very large amounts of money to not report the bug, because it's such a wonderful weapon for one of these pieces. Yeah.
If your chart had to go into negative territory,
yeah.
for how long exploits have been exploited before they're publicly known, how deep would you expect it to go?
Okay, so if we went into negative numbers, what would the number look like? Well, if you take Log4Shell, we were talking, what, 6 years? So, yeah, could be any number. It's a very good question. I haven't thought about it, but basically, months, years.
It's 2 orders of magnitude bigger than the biggest number on the other end of that chart.
Yeah, 2 orders of magnitude bigger. Yeah, exactly. Yeah. So, good news. If your software's everywhere, and the things I'm talking about aren't just attacks in the Java space. No, it's attack everywhere, because software is everywhere. If you've got software in your car, what happens if I can affect it to, I don't know, use more fuel or not start at traffic lights? Can you imagine the chaos? And this is all real. This is all turning up, right? And it's not just drive-by. I need to impress this. Where drive-by is the idea that you just happen to be unlucky. Because this is state-oriented and this is focused, they're looking at people, different organizations. So this was from last year, some guesses as to the sort of who's most likely to get attacked. It's a factor of importance, and it's also a factor of how easy it can be, right? So if you're in one of these groups, or you provide software to one of these groups, then you could easily be high up on the list, right? It gets worse, okay? Because it isn't just targeting industries, it's also going up the chain. So we're now looking at open source, right? Look, most of us use open source. Applications that we build, majority of it is open source, like with the numbers of, like 90%. So you have your application, you have a bunch of dependencies, that's your application, right? And the amount of open source that is being created is just growing. Right? Enormous extension of the number of classes and Python code and Node code, open source. It's just growing and growing and growing. They reckon by 2025, there could be 20 trillion downloads a year of open source. 20 trillion downloads. The world runs on open source software. And where it used to be that the bad guys would go and wait and search for vulnerabilities, which is cool, that's part of the process, they're now making their own. So you will see these words, typo squatting, dependency confusion. These are terms for different types of attack, but they're also after your open source project. They're open after how you do your builds. So if you have an open source project and you've got a build process, that's great. Can they get into your build process? Can they get at the end piece? Because if they can get at the end piece of the build, maybe they can add some malware. So they'll target that. But they'll also target your code as well, right? So those dependencies that we talked about, the other way of looking at it is that they're looking for weaknesses. Sure, they're looking for ways in, but they're adding their own. They're looking for anywhere. Can they get in the compilers? Can they get in the tools? Can they get in the platforms? Can they get in the runtimes? And they're not designed to be visible. These are stealth, because at some point, they'll want to set them off, but not necessarily immediately. So we have this situation where they're now beginning to target the open source projects of the dependencies that you're using, right? And there are so many ways. We could spend a whole day talking about how they get in there, but you've got to understand that they are now an active target. So the dependencies that you take down and we scan for vulnerabilities, that's one level. Now there's another level. Bad guys are trying to get into the open source projects. Right, well, I have a few minutes left. Let's talk about what we're doing to make this go away, because it sounds a bit scary. So the first thing is, 2021, this happened, an executive order that basically said, bad things have happened, we have to fix this. And since then, there's been a lot of coming together of many people in the industry, the large companies and the foundations, the Linux Foundation, others are getting together, because what the executive order ordered, and remember this is not done by the White House going, I have an idea, it was all by consultation, was a whole bunch of thought about how we deal with it. So apart from agreeing we have a problem, there was this idea of going, well, like all governments do, we'll put rules in place. And we'll make it so that you can't sell software to the US government without passing these rules, right? Which I'll touch on in a minute. But when you dig into the executive order, you start to see common patterns. So there are things like SBOMs, which I'll touch in a second, but look at the other words there. Look at automatic and integrity and evidence and demonstrations, right? The expectation is that you will have build processes and tools and everything around that that demonstrates that you are in control of the how you create software. What comes in, what you do with it, what you give out. And the SBOM, which is the other bit that you will hear about if you haven't already, and there are two standards, well, at least two standards, CycloneDX, which is an XML format, and SPDX, which is a different format, it doesn't really matter. Right? An SBOM, well, let me show you what an SBOM is. And the reason this is important, I said about scanning, right? When we're trying to scan, the scanning tools we use, they look at your final build and they track it and they go, what have you got? They investigate, they scan, they dig deep, and they pull out stuff, right? And they try and figure out that you've got this version and that version depends on this other thing and so on. So they build a tree of dependencies. But that all depends on how visible that information is, right? And you can imagine there's all sorts of ways to lose track of what version of some piece of code you've got, right? That just goes on all the time, right? So that carries on. So an SBOM says, let's not do it that way. Rather than try and discover what we've got, which has problems, the SBOM inverts it. And the SBOM says, you will provide digitally signed proof of the dependencies and whatever else is required of the thing that you're giving to somebody else. And every component that you use has to also provide you with the same proof so that you can pass it on, okay? I don't know if that picture really shows that, okay. So that means that everything you have, every dependency you have, breaks down into having an SBOM, digital signature, etc., and it just gets bigger and bigger, right? So SBOMs, not that you have an SBOM this big on your system, but an SBOM is a URL to a digital proof of what your product, how your product was built and what's in it. And it then links out to other digital proofs to show you all the way down as far as we need it to go to show you that we know exactly what you've got. And if you know exactly what you've got, then when a vulnerability turns up, you know that you've really got it. No scanning, no checking. It's guaranteed because you have a list of bill of materials of what you used, and you have a vulnerability that says this thing, this version of this component is in your list. So you found it. The trouble is now it means you can have a lot more of those because now you have complete visibility of what you've got, and therefore it means that every single vulnerability that's important to you, you're going to know about, right? So effectively, that means the way that we create software is going to change. So we've got executive pressure to be more rigorous in how we develop software, and we're going to find that if we can't automate this stuff, we're not going to get there. And we have to automate it because if you think about what I said about vulnerabilities being disclosed, vulnerability timing being negative, as soon as you know, you've probably already been exploited, so you need to shut the door. So you need to be able to press the button. And so we're going to move to a world where your build processes have to be very accurate, very fast. They have to start producing all this data, etc., etc. If you think about what that means to you as a developer, it means that your choices, the way that you choose open source, has got to change. You often choose open source because of functionality. But now you've got to start thinking about choosing open source for different reasons. You think about what I said about them trying to target open source. How do you know that the dependency that you've chosen is good? Well, you've chosen it because it's got some functionality, and you've also chosen it because it's safe. How do you know it's safe? How many people here download stuff on the internet? You know, everybody? Okay. How many people here? You're downloading. You've got to download. You put a dependency into your POM. You download it. How many of you would maybe check the license? Anybody check the license of the thing you download? Oh, look. Oh, maybe. Okay. Would you check the license of the dependency you've downloaded? No. That's where we're moving, because you need to know this, and more than this, and I have so many more slides which I should show you, but I want to cut to the end because I want to show you the important bit. Right. We can't continue to do software development the way that we do now. The open source projects are being targeted, so if they're being targeted, we need to be more savvy in choosing them. So when you choose an open source project, you've got to start looking at whether or not it's a good project. Right? Actually, I'm going to flick back because I was going to show you something else. Just the last couple of slides. We are building with people like the Linux Foundation, the CNCF, and other foundations, tools to help assess these open source projects for you. We're still working out what the rules are, but here's a couple that are coming up, and there are more. Right? I've got, because we run Maven Central, we're looking at putting all sorts of analysis tools into Maven Central to make it available to you, so that you as a developer can choose software more wisely. So not just because of the function or because of the license, but also because the open source project has a clean bill of health, that it's got the necessary security.md files, that maybe it's fulfilling all the requirements that the US government has placed upon it. Because if we don't get into control of these things, then we just let bad things come in, right? So that's where I am with this. It's early days, right? It really is early days. We're all talking it through. You as a developer need to think differently about this stuff and start thinking, what can you do? Start using these tools, go look at them, take a look at how your build system works and work out whether you can automate it. Look at, if you're involved in an open source project, have a good look at maybe who's allowed to press the build button. Can anybody build it? Do you use GitHub Actions? What do you do to make sure that that GitHub action that you've just picked is actually safe and hasn't been corrupted by the bad guys? Because they will. You as a developer are the ones who have to make these choices because you know what you're looking for. The IT guys, they'll run the tools that people say are the right tools, but they need your input to actually make the right choices. So I'm going to say, you know, developers, we've not been very good at changing our spots, but I hope to give you a little bit of a sense that you have to start thinking about this. You have to start getting clued up into what's coming. If you're very close to, if you are a company that work for a company that provides stuff for, say, the US government, you're probably beginning to get aware of this already. But as developers, it's our responsibility to help make this work, because we're the people who create the code, we're the people that choose the code. If we don't do things differently, it's not going to get any different. And I think I will stop there. Thank you very much. Are there any questions? Oh, look, loads. Go and shout. Yeah. Well, so what is there general about code signing? Well, so the SBOM thing, sort of, the idea is when you've compiled your thing, you get an SBOM, which is this bill of materials. And in there will be some indication of like the source code you used. You know, and I'll wave my hands because it's all a bit fluffy, but it might be, I don't know, a GitHub checksum or something. But at the end of the day, that thing, that SBOM is itself digitally signed, and the signature is then is stored. The other term you'll hear around is a thing called SIG store, signature stores. People are setting up SIG stores. So, because obviously, it's more than just here's my SBOM, and here's my signature. You need to prove it. So you have to have a public key to access it and prove that you can do that. So where do you put that? And where do you put all the other stuff? So that's all ending up on these SIG stores. You will see Google started it. You will see other people start to create SIG stores because it'll become an important part of it. But basically, yeah, everything, the theory is you should have a digitally proven track from the product that you've taken off the shelf all the way down to everything that's in it, and so on and so on. I mean, in theory, but not yet, but in theory, the compilers you use, the dependencies of the compilers, all the way down to the source code. So I will say there's another thing you'll hear, and that's called reproducible builds. So the idea is that, and we realize that if I give you an SBOM, you should be able to reproduce it. You should be able to create the same environment and end up compiling it using the same tools and the same way and get exactly the same signature. And unfortunately, as we've all probably figured out, is quite often, if you do the same build twice, the binary is different because it's got like dates and things like that. And so there's another effort that's working on how we can make builds reproducible so that you can prove that the SBOM that you've got that you can apply to take this source code and build it, you can prove, right? It's the close the circle. Does that answer the question? Or have I just rambled? Yeah. Okay. Anybody else? Yes. I can't tell you that I've seen that, but I have heard those stories, and we know that other tools have been corrupted. Compilers are sort of pinnacle, I think, but other tools have been corrupted. But to be honest, right now there's so many other ways of just easily corrupting you, just like giving you a Docker image or a GitHub action, because it's not even like, the question is, how would I get you to use the compiler? Right? And the simple answer is I don't really have to, because quite often all I have to do is go to your build process, and that last step where you do the zip, I'll get in there and I'll add some extra malware because you don't check. Right? So there are these esoteric things knocking around, but in general, don't need to use them because we're all, pretty much we don't have any security in anything else. That's a good question. I don't know. That should be reproducible. I don't know. Good question. Don't know. Yeah. Cool. I tell you what, you can do it for me overnight, and we'll chat about it tomorrow. Yeah. Okay. Well, look, I'm around a week. If you have any more questions, or you want to come and tell me that I didn't cover something, or it wasn't clear, I'm around. Other than that, thank you so much for listening. And wow, look, on time. Thank you.
It's not showing the presenter view though.
You want them reversed?
Yeah.
So, okay, I think you need to make the other ones, the other screen main. Let's go to displays, do a command space and type display. Okay. Okay, let's do display settings. Keep the first one. Alright, let's try the second. Yeah, let's stop mirroring. Alright, try to put it now. No, they're still reversed. I know there's a way we can say, okay, make the other one main. Mm-hmm. Click that and say use it as main. Alright, I think they're reversed now. See if you can go to your slides and click that presenter mode.
Interesting though. I don't think it's Zoom. Oh, here it is.
Is it the first icon?
Pardon?
Was it the first icon for the... I know there's a shortcut. Is this PowerPoint?
Yeah.
Shift F5, I think. Or at least on Windows. No. Just F5?
I
know the shortcut.
No, I'm on this screen now.
No, I know we wanted them reversed, so you have notes here and...
Yeah, I'm like on the wrong.
Is this what starts it? Presenter view? You click it?
No.
Yeah, I think we have... They have to be reversed.
I don't know what you want me to do. I can't get to it. Yeah, it's still not working.
All right, let's can hear it, see it.
Sorry?
We don't have the notes.
All right, well, we'll just wing it.
No notes? We're good?
Yeah. All right. All right, so this is stream processing with Hazelcast. I'll try to get through my presentation quickly, and we'll get to the code and the demo. So hopefully that'll be interesting. We're here all week. We're one of the sponsors, so stop by our booth to learn more about Hazelcast. Pick up a t-shirt, one of our Speed Matters. We also have stickers, meet the team, learn more about Hazelcast. If you were here earlier, one of my colleagues talked about the in-memory data grid. I'm actually not going to talk about that. I'm going to talk about stream processing, which is actually what the future of Hazelcast is. I'm going to talk a little about digital transformation with Hazelcast, and then I have a demo that I want you to imagine what the future is going to be like with Hazelcast, stream processing, and I think really it's kind of what the world is going to be like going forward. It already is in a lot of ways. I did want to ask, until today, has anyone ever heard of Hazelcast before? Show of hands, a couple of people. Anybody using it, open source, enterprise at all? Not really? Okay. Hopefully this will be a good introduction, give you an opportunity to check us out, download the software. It is open source. We have the serverless offering as well, so it's got a lot of potential. So this is really about the digital transformation piece. My colleague alluded to it earlier. He was talking about this digital integration hub. Really what it's talking about is the idea that right now when you build a solution, you have all this data that's going from all these different applications and all these databases, and you have to do this exchange of information. Really, that's a lot of I/O, that's a lot of reading and writing back and forth. But with Hazelcast, you can send all that data into Hazelcast and have that provide the, basically, the storage, for lack of a better term, for where the exchange can happen. So now I want to go into our demo here about stream processing. So the demo is basically about, if you would imagine the Royal College of Physicians in England, they had come up with this, basically this news scoring algorithm for patients. And the idea was that if you had these, originally they did these 6 physiological factors that were to, if you monitored them, you would be able to provide a score as to whether or not a person is in a fair state or they needed more medical attention. Now, they've since expanded that to 8 criteria, and that's what these 8 criteria are. And what we've done is we've taken that a step further and said, well, some of this information currently has to be handwritten, monitored, and it's not necessarily easy to check this information.
on an ongoing basis. But we imagined if we had devices and we were able to monitor a person and stream that data in, then you would be able to, how you then would be able to monitor a person, and then every instance that their physiological factors changed, then you would be able to get them rapid care to be able to increase healthcare outcomes. And they've proven this out. So to be able to talk about what this demo does is we've taken 8 devices essentially, software-wise, and we've streamed that data in, and we're using basically Apache Kafka as the message bus to serve that through to Hazelcast. Then Hazelcast takes those basically the CSV files, the data streams from that, and we're able to take all those 8 streams of data and process those into a patient record. So you basically have a device that's attached to multiple patients, stream that data in, process that, we're able to run it through a rules engine, and then push that to a scoring to be able to produce a score from that, and then push that to a visualization. So we'll see how that shows. We'll show that in a minute here. Again, this is just a demonstration or a picture of the processing pipelines here. And then, so for the code portion, we have these Kafka producers. These basically are the 8 streams. So we have 8 devices. They're creating the 8 Kafka producers from that. Then those feed into our 8 pipelines from there. And then the last pipeline is then sent to the rules engine, which then creates the score for each algorithm, and then puts that out to the scoring engine. So let's get to the demo. And this is where it's going to get interesting. Sorry about this. Let's wait times. Where is my... There we go. Okay. Pardon? Okay. All right, so I've already started up Kafka, Hazelcast, the Graphite, which is just a time series database that I'm using capture the output from the rules engine and then Grafana. And then now I'm going to start the actual application. And while that's running, I'll show you, we had just, like I said, there was the Kafka producers. So this code basically this produce records. It's essentially grabbing the CSV file for each of the devices, which is essentially the CSV data that we had mocked up. And that it's a simple data, but it's all sorted by date timestamp, and then each of those devices. So we've got the consciousness device, the breathing device, the heart device, from that diagram I showed you earlier. And then those all feed into the map data loader. And then this makes the connection to Hazelcast, pulls that in. Now these are the 8 pipelines, so they're all consuming those Kafka producers. And now they're taking those streams and then they're merging it into, basically they're processing each of those individual streams into a patient record, a patient instance record. And then they send that to the scoring engine, which is a Python. So we've got our Python rules engine file. A colleague talked about an ML inference that we can do. We didn't go down that path of doing machine learning. We figured this was pretty simple to just write a rules engine with Python, so that's how we approached it. So, because the algorithm from the News 2 was pretty straightforward. And then it returns back the result into this pipeline to the, so we've transformed these streams back into the output here, the scoring algorithm. And then I can come here and we'll look at Hazelcast Management Center. So I've got my one cluster. I've got all my patient device maps, and then I've got my results. And then in here, I can see my jobs running. This is the risk detector. So this is after I've processed all these streams, then now I am getting back the risk detector algorithm from the machine learning. And then here is Grafana, which is now showing me each of the, I have a patient scorecard, and a patient monitoring. Guess I was doing something here. Cancel. Cancel. And you can see all the patient IDs that have been, and then it'll show the data here for each of the patients. So, as the processing continues, some of the stuff that says no data will continue to fill in. So you can see here's, for the air oxygen, so this person is on oxygen, so that's why that's red. This person is not alert, so that's why that's red. And then, the rest of the data is being formulated and coming in, so. Okay. And again, the whole purpose of this is that this is all real time. We're just streaming this data in, processing it, and scoring it. We're not saving anything to the database. We're not using in-memory cache. We're not doing anything. We're just using Hazelcast to just basically take in the data, process it, and then output the data to the visualization. So if you can just kind of imagine how if you were on a head nurse on a floor and you had this information, you could see how, oh, this person's state has changed. We need to go and administer further care to that person. So, okay. That's essentially, sorry for the technical difficulties, but that's essentially what I was going to present today. So, any questions? Okay, thank you.
one in here, and then 4 on the other side of the building in the alphabet rooms, D, E, whatever, on that side, okay? So make sure you check the schedule. The breakfast will be out at 8 a.m., so you can come early and beat traffic if you like or whatever. And we do have a reception in the evening tomorrow in the lunch area and sponsor area next door, okay? And without further ado, let's get Venkat up here. While he's coming up here, I'll tell some jokes about Venkat. Is that okay, Venkat?
Go for it.
Okay. So this is not a joke, even though it sounds like one. When was it? Well, you can fill in the rest of the story in a minute, okay? But I remember one Christmas, about 3-4 Christmas holiday season in December, I was talking to Venkat because he came to the Atlanta Jug. I live in Atlanta and help run the Atlanta Java user group. And Venkat comes to the Atlanta Jug every December right before Christmas. And I said, oh, what are your plans for the holidays? And he said, oh, I'm going to write a book. I said, oh, that's great. When do you think you'll finish it? Like March or April? He's like, no, I should have it done before the end of the year, like basically in 2 weeks. So anyways, it's not a joke, but it sounds like a joke. So anyways, I'll turn it over to Venkat. Please give him a big round of applause.
Thank you, Pratik. Thank you. Thank you so much. It's a great pleasure. Thanks for being here. We're going to talk about the excitement around good old Java. So, but before we go, I just want to spend just a couple of minutes talking about, you probably see my name, and one of the things that absolutely bothers me is, if you really think about Java, and I was thinking, what is Java? And somebody asked me, what's Java? And my answer to them was, truly, Java is the passport to the world. And I say that Java is a passport to the world because Java has, as a language, has really enabled me to travel to so many countries around the world, meet so many exciting people. I can't tell you how many times I'm in a random city, in a train or a bus, and suddenly somebody comes up and says, hey, and then we sit down and talk about Java for an hour or 2 hours, waiting for the next transportation and so on. And then one of those things that really helped me was to get to know some amazing people in different parts of the world, and that really meant that I actually got to spend some time in Ukraine. And I've been to Kyiv and to various other parts of Ukraine, and it absolutely disturbs me to know what is going on over there. So I just want to first of all express my support for all the friends and all the people who are going through such a suffering right now due to the insanity that we are facing. And I hope, truly hope, that this all comes to an end for the better. And just a couple of weeks ago, the Devox Ukraine conference, they put up a charity event for collecting money for the cause of Ukraine, obviously, and which also, once again, absolutely blows my mind. I always think about how would I react when things really go bad. And I'm almost in tears to say this. And for these people who are being attacked right now, to have the courage to put up a conference in the time, what a positive attitude to deal with this. And just absolutely blows my mind. So my heart and my thoughts are with people over there, and I'm really hoping that things get better for them soon. And in any way we can support, I think we should really do. So I want to talk about Java in today's world, and then how Java is today compared to years ago. But I want to start with this word that we all talk about quite a bit, about agile development. So thinking about agile development, we all work in various companies. We are all, I'm sure, part of certain agile projects that we are all working towards, an agile initiative. So what is really about agile development? I'm going to start with 2 words that I really hate the most. I'll get that out of my system to begin with. And then I go to companies, and the first thing they want to tell me is, Venkat, we want you to know we are agile. And I always tell them, I'm so glad we got that out of the way. Now let's talk about what you do. But there are 2 words that absolutely bother me in development today. And the first word, maybe a set of words, is Scrum Master. I have no clue how this actually happened or why. This was never supposed to be a job. This was never supposed to be a role. And now I come across people who say, what are you? I'm a Scrum Master. I'm like, I'm sorry. That's all I tell them. I actually had a session a couple of weeks ago where there was room full of Scrum Masters, and that's exactly what I told them. And they are like, oops, so I'm sorry. I'm not personally insulting anyone, but I think this was never meant to be. This was never meant to be a job or a title or a position. And so, in effect, this is one of the things that really surprises me. We as humans love rituals. The reason we love rituals is rituals give us relief from reality. We don't have to do the real work anymore. We can practice this ritual. We can have a stand-up meeting. That's so much better than actually getting the real work done, isn't it? So the point is, we tend to really hide behind rituals because it gives us that relief from what we actually have to do. And I don't understand still this role of a Scrum Master because this was never meant to be. The first thing that you see in the Agile Manifesto is people over process. And what are we doing now? We're creating process over process over process. That doesn't make sense. The other thing that absolutely makes no sense to me is this other word called velocity. And I don't know why, again. If you want me to be on a project, and if I show you speed in the beginning, you should be worried, not celebrate. Because if I give you speed in the beginning, what that tells you is I'm doing easy things. I'm not putting enough time into quality. I'm just trying to impress you, and you don't want me to impress you. You want me to deliver the results for you. And so if I'm really fast in the beginning, I'm going to come to a grinding halt when it really matters as we progress on the project. So it's a very misplaced focus, again, on companies when they focus on velocity. So I once tweeted this. It took me all these years to realize TDD stands for ticket-driven development. Thus, many organizations actually practice it. And this is one thing we commonly see is these practices that we drive towards that we're not really meant to be, but we get really excited about these things. So let me ask the question, what is really then Agile development? And I'll tie this back to why I'm talking about this in a few minutes. What's really Agile development? And I'll say Agile development really is feedback-driven development. That's what it really comes down to. You want to drive your development based on the active feedback of what you're creating. And a feedback gives you the ability to know if you're heading in the right direction, if you're meeting the customer's expectations, and if it's not what you need to be delivering, you want to alter it. And we as humans are driven by feedback. This is amazing. This is in our DNA, and yet we reject it so much when it comes to developing software. When I walk, I'm able to walk steadily because my brain uses the feedback from me walking. If I blindfold myself and try to walk the stage, I'll bounce across the wall or fall down because I don't have that feedback loop. We rely on that feedback heavily as humans. And I remember this was back in 1993. I was on the very first trip to Grand Canyon. Beautiful place. I've been there several times, and I'm hoping I'll be there again. But this was about 30 years ago, my first trip to Grand Canyon. And I started driving from Phoenix. And I was on the car for about 2 hours. And all of a sudden, my question was, am I going in the right direction? Because Grand Canyon is not a mountain. It's a hole on the ground. You can see it from afar. And so am I in the right direction? And remember, 1993, this was time before GPS and all the other wonderful technologies and smartphone. And I pulled over by the side of the road, and I was thinking, what should I do? I got 2 options on my hand. I can turn around, make a U-turn, drive for an hour until I get to the civilization and say, excuse me, was I going on the right direction? And they say, yes, you are, and I'll make the trip back again an hour. Or I can keep going in the direction I'm going, not knowing if I will ever get there. And you say, oh, Venkat, didn't you have a map on your hand? That would have helped, isn't it? Oh, sure, I had a map on my hand. But there was one thing that was missing on the map. You know what that is, right? That blue circle. And the blue circle did not tell me where I was. So the map said where everything is, but it never told me where I am. To me, that is Agile development, where I know where I am, and not how far I've come so far, but how far do I need to go to get to where I need to be. And that kind of feedback is what we thrive upon. Today, I just don't care about much. I get in the car, start driving. Oh, that was the wrong direction, make a U-turn, and I can go now because the GPS is tracking most of the time. The other day I was using Google Maps. It said turn left. I ignored it. It said turn around and turn right. I ignored it. It said no, turn around again and turn left. It wanted me to go on the railway track. I'm like, good try, no. I'm not going to do that. Most of the time the feedback loop is really good, but we still have to pay attention to it. But that feedback-driven development can be really amazing if only we can use it. But let's talk about Java. Java as a language, can you imagine any language that's done this in the history? Let me rephrase it. Can you think of any good language? Because when I say that, people say JavaScript, so I always rephrase it. Can you think of any good language in history that's done this, where it's been popular for 27, 28 years? That's never happened in human history. Programming languages were popular for about 10 years. Sure, they're used for a long time. I'm sure you will dig up somebody who is still working on COBOL, right? As much as C++. But for a language to be popular this long, there's only two languages I think that's done this so far, Java and JavaScript. But of the languages, the power, amazing capability of the ecosystem of the JVM is just amazing. But I'll be absolutely honest with you. If you switch back to about 2007 time frame, I was that person on the other side of the picket line, constantly screaming that Java is not moving, Java is stagnant, I hate Java. And I'm not kidding with you, I've saved these emails for history purpose. I've used to get emails from people that started saying, Venkat, I hate you because you hate Java. Because apparently it was wrong to hate Java back in time, maybe even today. And I really did not favor Java. I would complain about it. And the reason I did was the language was very stagnant. It did not go anywhere at the time, and I would be vocal about it. And of course, as time went on, I realized that the snail-paced development was not going to help at all. And I was worried, this language is going to die. And it was, time to sing the last rites of this language. And then all of a sudden, when Java 8 came out, the one language that was on the deathbed was jogging and having parties and celebrating. And you look at this and say, whoa, what just happened here? A language that was supposed to have died really came back to an amazing power. But the merit, the reason for that, of course, is the innovation that went into Java. Now, clearly, I often say jokingly, when I talk about Lambda expressions and the functional programming, we clearly know functional programming has been around for a long time. Java was not the language that created it. But Java, of course, came with some interesting characteristics in it. The amazing power of invoke dynamic, which made really the implementation of lambdas very powerful and efficient in the language. So jokingly, I often say that Java came very late to the party, but it came with some amazing desserts, and that made all the difference in terms of their late arrival into it. But that definitely changed where Java was going to head, and looking at it, it's amazing to see how that development went along. But if you look at the timeline, it's very interesting to watch it. If you notice, the Java 1.0 was released in 1996. Then came in 1997, 1.1. Hey, that's a 1 year. That's awesome. 1.2, 1 year later, 98. In 2000, 2 years later, 1.3. What happened to 1.4, 2 years later? 1.5, 2 years later. And Java 5. And Java 5 was the biggest release of Java since Java 1 at that time. We had things like generics and auto-boxing and a few other things exciting. But that was Java 5. Then 2 years later, Java 6. And many of you may remember, Java 6 had no language features 2 years later. And then what happened? Java 7 was nearly 5 years later. And you may remember at the time they were debating, do we release Java 7 with Lambdas, but delay it by another few years, or should we release Java 7 now without Lambdas? And there was a lot of debate about it. And of course, as history shows it, they released Java 7 without Lambdas back then. But then 3 years later came along Java 8. Now you may say, wait a second, these were 1 year releases away, but these were 3 and 4 years apart. What just happened? You and I know this exactly what happened, right? Because they are much like us. When your boss comes to you and says, how's it going? What do you say? I'm almost done. And that I'm almost done usually means 3 years or 4 years. And this was the biggest mistake that they did, is to tell what should be in a release of Java before we actually get down to implementing it. And we all know what that's called, waterfall. And we plan on what we want to release, then start working on it. And when we do, now you have like 3 or 4 features you want to release. Hey, how's it going? I'm almost done. Okay, let's wait for them to finish. We'll release it with it. And now we are trying to synchronize all of these things. And by the time a feature is released, the person who wrote it doesn't even remember it. And the time has gone so far. And when people start adopting it, it is so many years after it was implemented. That's a very slow cycle. What good is a feature if you implement it if nobody gets a chance to use it? So this was the place where we were a few years ago. And as you can see, Java 9 was again 3 years later. And at this time, the folks behind the language realized this is not going to help us. And they took a very bold decision. I call it bold because it was not easy for them. It was not received with open arms. And they took a very bold step to accelerate the pace of development of Java. And at that time, of course, they announced that we're going to have a release every 6 months. Now, if you notice over here, Java 10 was in 2018, March, and then a September and a March, and a September, March, and a September, March, and a September, like clockwork. There's a release every 6 months. Now, you may look at that and say, whoa, that's a 6 months release cycle. And when you ask people what do they think about it, there was a lot of skepticism. Nobody believed this would work. And I really want to emphasize about the 6 months release cycle. And that is, make note, Java is not being developed on a 6 month cycle. It's very naive to think that the features that go into the language can be cooked up in a 6 month cycle. These are very complex details that get developed. It takes time to think through them, to design them, to implement them, and to really get them working. For example, take one feature in Java 10, which is a local variable type inference. That feature took them 5 years to implement. Take the feature that we are seeing in Java 19 as a pre-release, Project Loom. That's taken them 12 years to implement. These were not implemented in 6 month cycle. It's naive to think that they're developing this in 6 months. So some people are worried. They say, oh my gosh, if they're doing this in 6 months, what about quality? What about, no, they're not developing this in 6 months. Java is not going through a 6 months cycle for development. But a few years ago, this was back in the year 2018, the year I was turning 50 years. And as I was turning 50 years, I was on a train ride between Krakow and Thorn. And I was on the train and thinking what I want to do, and suddenly a thought occurred to me. Hey, what if, this is my 50th year of birthday, what if I go to speak in 50 user groups? Wouldn't that be awesome? And immediately I texted my wife, who was just about waking up here in Colorado, hoping she would say, you madman, get out of the train and come back home. But instead she replied, what a great idea. And the next thing you know, I dropped an email to one of the user group leaders, and they said, we love the idea, let's do it. And all of a sudden, I blogged about it, and within a matter of days, I had most of the 50 user groups signed up. My 50th user group actually was coinciding with the 25th anniversary of the Paris Java user group, and this was on the top of the Eiffel Tower, where I gave my 50th talk that year in the 50th user group. So it's an amazing experience to be able to speak in all these user groups. But more notably, one user group visit was a visit where I spoke in 6 user groups in 1 week, pretty much one night a week except for Sunday, I think. And I was supposed to land in Zurich, speak in Zurich, and then Lucerne, and then back in Bern, and so on. And then I was going to hop into a train and go to Germany and speak there as well. And I was thinking, one user group per night and across 6 different cities, I don't know how it's going to work. And I land in Zurich, and Marcus is the user group leader of the Switzerland user group. And Marcus meets me in the airport. And Marcus is such a calming, fatherly figure. If you ever meet him, you will just absolutely feel comfortable. I just spent a week with him 2 weeks ago, once again. But I just absolutely love his company. And he picks me up at the airport and hands me a folder and says, here you go. I said, what is this, Marcus? And he said, this is your train tickets. And this train will take you across Switzerland, any city you want to go to. And I bought these tickets for you. And he said, the train leaves at 10 past the hour, and it leaves at 40 past the hour. And you can take any train you want to. You can take the train at 9:10 or 9:40 or 10:10 or 10:40. You can go on any train you want to. And I would wake up in the morning, I would do some work, I would jog, I would exercise, I would have some nice breakfast, and I would say, it's time to go to the next city. And I would wander to the train station, and I would find somebody random, have a nice chat with them. And when I absolutely don't have anything else to do, I'll take the train and go to the next city. And I thought to myself, this is amazing. If I have a flight to catch, I keep looking at my flight tickets days in advance. What if I miss it? I'm all stressed out because there's one flight, and if I miss it, I may not be able to make it to the city in a day or two, and I'm absolutely stressed out. But here, there's a train that leaves every 30 minutes. If I don't take this train, I can take the next one, not a big deal. And all of a sudden, the way I thought about this was very different. I was very relaxed. I was able to focus on what I want to do rather than just taking the train or traveling to another city. So in other words, there's a train that's leaving every 6 months. You can leave on any of those trains. If your feature is ready now, you can get on the September train. If your feature is not ready right now, but it'll be ready soon, you can get on the March train. And you get to decide if you want to take the March train or the September train. How does that change your way of developing software? And I would say that's brilliant. Because now you're not trying to hurry up or slow down to meet a deadline which is artificially created to synchronize with other features of the language. And I call this the brilliance of releasing software. They completely decoupled what goes into a release from having the release. And you get to decide what goes into a release when you are ready to release it. And what is this called? Maturity. It's amazing to see that in our industry, isn't it? Because you're not forced to do things because somebody told you that's what we will do. You get to choose when it's the right time. You're working hard on this feature, you think it's ready, go for it. You don't have to wait for other things. Besides, the features get released as a preview feature. People get to use it. They give you a feedback, and based on that, you make changes. Has that happened? Quite a few times already. The text block feature is an evidence of that, for example. In more recent release, in Java 19, the syntax for guarded pattern matching is different. We use a when instead of an ampersand. And again, going back to switch, they decided to use the yield as a way to exit off a switch. Every one of those changes in the language came from active use and feedback. So as a result, there's a train that leaves every 6 months, and they can take any one of those trains, and that really makes a huge difference. And so Java is being released on a 6-month cycle, but it's not being developed on a 6-month cycle. And this really comes back to the true agility that we all only think about and wish for, but they took a very bold step to make Java really agile in that regard. And as a result, there is a 6-month release cycle, and before the time, you know, if I ask people, what is the thing that comes to your mind when I say Java 8? Just think about it in your own mind. When I say Java 8, what are you thinking? I know some of you thought about Lambda expressions. I know some of you thought about streams. But how many of you truly, at this moment, thought of completable future? Yeah, not a single person, isn't it? Is that not important? It's actually quite important, quite significant. But why did I not? I wrote an entire book on Java 8 functional programming, never even mentioned the word completable future in it. But why? Because when you have so many features being released, there's only so much you can focus upon. But now we have these bite-sized improvements. You get to enjoy one little feature at a time. You can catch up with it on a 6-month cycle. You don't have to face this water hose where everything is poured on you and you're trying to really struggle. And that is an amazing journey, if you will, that we can take. For example, one of the things about Java is moving, I would say, in a very pragmatic and practical phase. Java developers are not interested in changing the language for the sake of changing. They're asking 3 important questions. The first question they're asking is, will this new feature that we are considering in Java, would it really help the Java developers? Is this something they would benefit from in a fundamental way? That's the first question they ask. The second question is this feasible to implement it without breaking things that exist? Backward compatibility is a very interesting thought. When you look at programming languages, there are languages that really work hard to provide backward compatibility. There are languages that don't. They change things, and the people using the language, maybe a small community, they get really excited. They say, whoa, that's great. We can change everything now. But that's not going to work for a lot of people. Java simply has no luxury to do it. Why? The reason is, if you look at a lot of other languages, with all respect, I don't mean any disrespect to any of those languages, but when you look at a lot of other languages, the user community is much smaller, relatively speaking, compared to Java. Java as a language has more than 10 million programmers and thousands of enterprises that use the language. Well, think about it for a minute. If you have 10 million users, and out of the 10 million users, 1 million users know where you live, you have to make decisions differently, isn't it? So as a result, they don't have the luxury to make changes the way a lot of other languages do. But the story of backward compatibility is this. Languages that really want to provide backward compatibility are doomed. And languages that don't provide backward compatibility are also doomed. So this is a path of no return. You're doomed if you do, and you're doomed if you don't, and it's a question of choosing which way you want to get doomed. And Java decided they will really provide backward compatibility, and that is a lot of work, a lot of effort. So that's the second thing they consider. Is it useful? Is it feasible? And the third thing they ask is, what else will this make it hard in the future to implement? Are there features that are going to get really hard to bring in if we go back and implement these features? A case in point, they wanted to really implement the ability to do raw string. But 3 weeks before the release of raw string, they took the bold step and removed it. And people blogged about it, people talked about it, people wrote tutorials about it, and they all like, whoa, what happened to this feature? It's gone. And they said, well, we learned from the experience. We learned that this needs to be really reworked if we really want to support the next use case we aim, which is text blocks, which is amazing. So I'm sure we all have worked with this in the past. For example, I could say message plus equal to, I could say, hello there, for example. Then you say message plus equal to, how are you? And of course, then we go on and say message plus equal to, and we can write more after this, and we can keep going. Every single one of us have written this code, isn't it? But it's not a one that you're proud about. Do you care to put that on your resume? I've got 7 years of experience putting plus equals in the code, right? No, this is the code you hide from humanity. You never want anyone to know about it. If you work from home and you got small children at home, you close the lid very quickly when they walk in, because they look at this and say, that's what you do for a living? And that's pretty dangerous, isn't it? I mean, I really wish my elders told me this. When I was a little young, when my children were really small, I would put them on my lap, and while I'm working, they would be sitting and just playing. And I never thought about it. But as time went on, the children are just not playing. They are actually watching the code you are writing as well. And one day, one of my children said, Dad, don't worry about it. I will grow up and take care of you. You don't have to do this anymore. Well, that's what happens when we write poor quality code, isn't it? That's not a code we want to show anybody. Well, good news, we don't have to because of text blocks. We can simply write a nice little string, a multi-line string. We don't have to be escaping over and over and over. And we can also put many different things inside of it without much effort at all. And that becomes incredibly easy to write, as we can see. And that becomes really a nice little text block we can write. So, and of course, this concept is called the here docs in other languages. And I always look out for what's the innovation in here. And to me, the innovation is not just they brought in text blocks because that was available in other languages. I've used here docs in other languages, and I'll be honest about it. It's a nice feature, but occasionally it would misbehave. And it'll cost me about 15, 20 minutes of my life. And I'm not very happy when that happens. I would sit there and say, please work. Please line this up properly. And I'm like, what's going on here? Why wouldn't this work? And you're deleting code and building it back together, and you're just waiting to please this compiler or the runtime. Well, the innovation of text blocks is, when you look at this particular code example, for instance, the indentation that you see right here, those are called incidental indentations. They simply strip it out, knowing you're just following a convention. These indentations, of course, are the essential indentation. So the compiler is really smart, where the compiler thinks like you and makes it easier for you to get the code done. That becomes a lot easier. Similarly, some of the changes that I'm really, really excited about. For example, let's say I'm going to call a function called process, and I'm going to pass a 1, or call a process and send a hello to it, like so. And in this case, I'm going to say public static, let's say string, a process, which takes an object as an input. I just want to process some set of messages that are flowing through, let's say. Well, in this case, I'm going to simply return, let's say, whatever to start with. I'm not interested in processing that right now, so I'm just going to say whatever. But in this case, I say if the input is an instance of, let's say in this case, an integer, I'm going to simply return from this return, let's say, got a number. Well, that's a good step. I can process if it's a number, do some processing. But on the other hand, if input, let's say, is an instance of, oh, what if it's a string? I can return from this over here. I can say, hey, got a string. Well, a good first step, if you will. So I can say, got a string, and return that value. But then I say, I want to say of length, and I want to say what the length really is. But how do I know what the length is? I'll say int length is equal to input.length, and I want to call that method. Well, as you know, if you try to write that code, unfortunately, what does the compiler do? It promptly tells you, method length, variable input of type object, error. Let's think about this for a minute. Imagine you're leaving the building one evening, and you see a good colleague of yours and say, hey, where are you going? And your colleague says, you know that movie I've been waiting to watch? I'm finally going to see it today. You said, awesome, have fun time. The next morning, you see them at breakfast, and you ask them, did you go to the movie yesterday? They say, yes, I did. And you say, how was it? And they say, how was what? And you're going to stare at them and say, really? You're not going to have much of a conversation with this person, right? Because you said, did you go to the movie? They said, yes. You said, how was it? And they say, how was what? Well, we as humans carry a context, carry a conversation. And if somebody doesn't, there's not much of a conversation to have at that point. Now look at what the compiler did to us. Compiler, is the input a string? Yes, it is. What's the length of what? And you're like, really? Seriously? Now they call it casting, I call it punishment. Because at some point you ask the question, do you work for the compiler or does the compiler work for you? In this case, you're working for the compiler. It says, how is it going? I'm working. Work harder. I'll check on you after lunch. And now you're spending all this effort writing the code. That's no fun. But you don't have to, thankfully. When the language matures, we become more productive. So in this case, you can go to this and say stir. And you can come back and say stir. And the compiler is quite happy with this. It says got a string of length 5. So we are able to specify a casting as part of the instance of check. So basically in this case we said, hey, if it is an instance of input, a string, give me a reference called stir, I can simply use it. Now of course they call, other languages like Groovy and Kotlin call this smart casting. Java calls it pattern matching with instance of. The reason they call it pattern matching with instance of is this blooms into a full-fledged pattern matching syntax, and as a result, it becomes easy to do not only switch over constants, you can do switch over objects and types of objects as well, and that really reduces the verbosity in the code. And that's an amazing journey because it reduces the noise in the code, and it helps us to really write less code, which is less error prone and makes us more productive as well, and that's a big change. In a similar way, there are several things that every single version of Java almost is bringing to the table where we can get better at writing the code. So rather than having to really struggle through the language in one big release, we are able to incrementally evolve and adapt as the language is incrementally evolving and adapting. And all of a sudden, it feels like the language has not left us behind. When you're a corporate developer, enterprise developer, writing the language because that serves really well in production, you don't have to feel left behind. The language is growing and moving. And those interesting features that often we talk about in other languages are not just things that are available for others, it's things we could use for ourselves as well, and that becomes really powerful for us to embrace and move on. And as a result, we are able to work in a very powerful environment, but at the same time work very powerfully with it as well, and that becomes absolutely phenomenal. A case in point, for example, is one of the things I really enjoy in Java is this concept of records. And records are pretty powerful in that we've all been writing code for a long time, but the code can become really verbose and error prone at the same time. For example, let's say, for instance, I want to create a class which is going to be representing a stock trade. So I'm going to say, here's a stock trade. I'm going to say private string, let's say ticker. Then I'm going to say private int, and I'm going to say a price as well. Well, that's great. We defined a ticker and a price. That's awesome. But then you say, are we done? No, we're just getting started. We then need to say public stock, and we can say string ticker and int price, and of course go through the ceremony of saying this dot ticker is equal to ticker, and of course this dot price equal to a price as well. And then once we write this, what are we going to do? And of course you may make a decision at this point to say that's a final and that's a final too, good for us. But then what do we do? And one of the things I always think about is when it comes to programming languages, what are the defaults of a language? I want languages to give me safe defaults, not unsafe defaults. When a language gives us safe defaults, we are able to write code more productively and it's less error prone. When a language offers defaults that are not safe, we have to work hard to keep saying these kinds of things. I need to say final. Why? Because the language chooses not to make it final. But when you program in languages like Haskell or Kotlin or Scala, what kind of defaults do they choose? That's something to think about. So in this case, of course, we also write a public string get ticker, where it's going to return the ticker. Then, of course, you may have to write the get price function. And you say, oh, come on, Venkat, that's not true. I never write those functions. I define the fields, and then I gently right-click on it. And before I can blink my eyes, the IDE vomits the rest of the code. And now you have to live with that vomit. And that vomit is an unerasable ink. And you live with it forever, and it gets smelly over time. And then you realize, but I still have to write the equals with the toString method. Oh my God, you forgot the hash code method. More error in the code. Why do we have to deal with it? Instead, you can simply say, hey, I have a record called stock, and I'm going to get rid of a lot of these noise. And I'm going to simply say, here's a ticker string, and here is a price, and I am done. And I can remove all that code that we would have otherwise had generated for us. So as a result in this particular case, as you can see, we don't need to be writing as much code. So we can say stock over here is equal to new stock, whatever you want to call this, let's say Goog and 100, or whatever you want to create, and you say stock. Well, records actually offer buy one, get 5 free offer. How cool that is. You write a record, but you got 5 things for free, a constructor, a toString method, a equals, a hash code, and a getter for that as well, for the properties of the components as they call it. And the toString method is a little bit more intelligent, gives you some relevant details, but you can override it if you really wanted to, and that makes life a lot easier. But not only that, you cannot mutate a property that you create in this case. You cannot mutate a ticker or a price. So you got really nice immutability built into it as well, which makes the code a lot more safer when we write it. So as a result, these things take us in the right direction. Not to mention, one of my other favorite features is the sealed interfaces and sealed classes. Sealed interface and sealed classes is phenomenal because it gives us a way to model in a way that we can convey our design criteria more effectively. So in a way, you could say Java 8 was functional programming capabilities. Well, guess what? Java says there's more improvement in object-oriented programming. We're going to make your life better by providing records. We're going to make your life better to do OO programming, again, by providing sealed classes in sealed interfaces. So not only can you do better OO, but you can also do better programming in object-oriented style. But that is not to say, if you look a little deeper, one thing, if you ask me, what are the changes in Java that are absolutely significant? Sure, Java 5 was exciting. It gave us generics and a few other things. So that was really, maybe we should say, significant. Java 8 was life-changing, in my opinion, because you could do functional programming with Java 8. Java 9 was significant in terms of bringing modularity, even though several of us have used in different degrees. But I would say the next big thing in Java is Java 19. And that is probably more significant, honestly, in my opinion, than even Java 8, because it fundamentally changes how we do asynchronous programming. With the concept of virtual threads, you are able to write non-blocking calls in almost an effortless manner. And this is where I really admire the power the programming languages and capabilities give us. I'm not going to show you examples of that here today, but I'm going to just talk about why I'm so excited about it. So that way you can be as excited about what's happening in Java 19 as I am. But let's step back for a minute. Suppose you're writing programs and you're using single thread. Imagine this was Java 7 or Java 6, and you're writing these single-threaded programs. How do you know you're working on a single-threaded application? I'll tell you how you clearly know. You go to work, and people smile at each other. That's how you know it's a single-threaded application. And one day somebody says, we got to improve performance. Let's put multi-threads in here. That's the day, the last day, there was joy at work. And everybody is grumpy because we have written code that's unmaintainable. We're fixing bugs. And late in the night, one night, you're tired because you just could not keep up with these bugs in the multi-threaded code. So while you're fixing your bug, you applied for the next job. That's called concurrency. And you said, no, I'm done, right? So in the past, what happened? This is what happened, right? The structure of sequential imperative style code was very different from the structure of parallel imperative style code. The imperative style code, sequential code you wrote, was beautiful. Okay, almost. At least we can believe it was, right? You could see it. You could reason with it. You could say, here's what is happening. And somebody put some threads into it. And they put a few locks into it. They put a few synchronize into it. And now you cannot recognize it. The code turned into a monster in front of you. And you look at this and say, back in time, how beautiful this code was. And occasionally, you go to the version control and take a look at the old code as it was, just to feel better. That's the problem, code that is unmaintainable. Well, with Java 8, two things happened, right? The first is the structure of sequential functional style code is the same as the structure of parallel functional style code, thanks to, of course, Java streams and, of course, Lambda expressions. The structure of sequential functional style code was exactly the same as the structure of parallel functional style code. You could write the code sequentially, change a stream to parallel stream, or just insert a parallel, and you got multi-threading on it, cautiously, of course, but you didn't have to change the structure of the code. You can reason the code sequentially, and you can carry that reasoning to parallel execution very nicely. Not only that, we saw one more thing. The structure of synchronous functional style code, let's try this again. So the structure of functional sequential style code, functional style, synchronous functional style code is the same as the structure of asynchronous functional style code. Of course, thanks to completable future. So we can write the same exact code that can run synchronously and without much effort at all, make it asynchronous. But notice the trend in here, unfortunately. If you want to buy into these flexibilities, you have to turn in your passport, sell your house, and migrate to this unknown world of different style of programming. You could no longer program in imperative style. You had to program in functional style. Don't get me wrong, I'm a fan of functional style of programming. But functional style is great as long as you don't deal with impurity, side effects, and that evil exceptions. The minute exceptions creep in and you have to handle multiple levels of exception, what just happened? The functional code becomes dysfunctional. It becomes horrible to write and maintain it. And we struggle with it. And now we are like, gosh, what's wrong here? I thought this was a great way of writing code, but there is limits to everything we do. And this is what blows my mind. Finally, the structure of, you can say, the structure of synchronous imperative style code is now the same as the structure of asynchronous imperative style code, thanks to Project Loom, virtual threads. So this really brings this into a closed circuit. If you're programming imperatively, not because you can't program otherwise, it's because that's the right thing to do. Because you have a nested exceptions you have to deal with. Then what this gives you is the ability to really bring them all together. And it says you can write your synchronous code using imperative style, and you can make that same exact structure work for asynchronous as well. And the virtual thread says, I'll be non-blocking for you behind the scenes. When a task is blocked, a thread is not blocked. Think of this like a waiter in a good restaurant. You're sitting around in the table, the waiter comes along and says, what would you like to drink? You say, I'm not sure what I'm in mood for. What do you have? And the waiter gives you a list of things you could order. And you say, I'm still not sure. I'm thinking, what will a terrible waiter do? Sit around and say, what do you want? Let's talk about it. But that's not efficient. The other tables are waiting in the meantime, and the restaurant is not going to make profit doing so. A good waiter says, why don't you think about it? I'll be right back, and swings by to help other tables. What if your threads are not held hostage when a task is blocked, where it can be truly non-blocking? And as a result, your coding becomes simpler, but you get performance and throughput behind the scene. The structure is the same, but the semantics is different. And you're able to get that benefit of just flipping a switch, thread, virtual thread. And to me, that's why I feel this is going to be huge. This is going to be huge because it's going to fundamentally change the way we build our servers. It's going to be huge because it's going to fundamentally change how we build large-scale applications, microservices, enterprise systems. In every aspect of what we do, it's going to make a change. So if you ask me what I'm excited the most in Java, I would have said that was Java 8. But now I would say that's really Java 19. And the reason is you can see the fundamental change that's happening here in terms of the capability it's offering. Java 8 made a substantial difference in how we program the applications. Java 19 is going to make a substantial difference in how we program our microservices, how we program our systems and servers. And to me, that's one of the reasons why this is exciting. So a fundamental shift in the paradigm is a lot more powerful than a shift in syntax. And to me, this is not a syntactical change, it's a semantical change. It's a paradigm change. And I think that's what is going to benefit. We're going to take years to really realize this benefit, but it's also going to be very long lasting. So that's one of the reasons why I'm truly excited about this. So every step of the way, Java has consistently shown the amazing things we can do with the language, but also with the infrastructure, the ecosystem, and I think that is absolutely phenomenal. And that's why I respect the changes that are happening in the language, is because they're very thorough about it. And not only they do these changes, but they're driving these changes based on the feedback cycles. So many people can talk about being agile, but it's so refreshing to see that Java is being agile. They're not saying we want to be agile, they're just quietly being agile. So that to me is absolutely refreshing. It's very rewarding, it's enjoyable, and I hope it is for you as well. Thank you so much. Hope that was useful. Enjoy the conference. Thank you.